Recording in progress.
Salam MGEI dimanapun Anda berada. Nama saya Noel Pranoto dan saya sehari-hari bekerja sebagai geoscientist di dunia pertambangan. Dalam kesempatan ini saya ingin berbagi sepintas mengenai program Fresh Graduate Mentoring yang dilakukan oleh Masyarakat Geologi Ekonomi Indonesia atau MGEI. Seperti banyak lulusan geoscientist pada umumnya saat kami kuliah dan baru lulus dulu, gambaran sebagai geoscientist itu sangat menawan, apalagi buat mereka yang menyukai perjalanan, kegiatan di alam bebas. Ibaratnya kami bekerja dan jalan-jalan, melihat banyak tempat di Indonesia dan bahkan dunia ya. Namun atas biaya perusahaan, ya siapa yang nggak mau ya. Namun setelah sampai 1-2 tahun bekerja, ya ternyata realitasnya tidak hanya seperti itu dan terus terang saya kaget. Ternyata gambaran yang indah itu cuma penggalan kecil aja dari tuntutan nyata pekerjaan sebagai geoscientist. Mulai dari pekerjaan di lapangan, lalu kemudian menulis laporan, menyusun program dan anggaran, menjual ide atau presentasi, hingga harus memimpin tim kerja dan juga melakukan banyak-banyak hal yang sama sekali baru begitu. Nah, repotnya lagi hal-hal seperti ini tidak kami dapatkan secara terstruktur dan sistematis di bangku sekolah. Nah, untunglah pada saat itu kami memiliki atasan-atasan atau senior-senior yang mau mementor dengan sabar dan penuh dedikasi. Tentu saja di samping itu perusahaan juga memberikan resource untuk kami yang baru-baru lulus ini untuk bisa belajar sambil bekerja. Nah, berbekal kisah nyata yang berharga ini, gitu ya, dan pengalaman di organisasi yang lain, kami bersama kawan-kawan di kepanitiaan MGEI memulai suatu program Fresh Graduate Mentoring di MGEI yang menyasar pada lulusan geoscientist dan mereka yang baru memulai karir di dunia eksplorasi dan pertambangan. Tentu selain meningkatkan kompetensi ya, dan menjadi ajang sharing dan learning antar generasi geoscientist, program ini juga bertujuan membangun jaringan yang berkelanjutan antara mentor dan mentinya di dalam mereka meniti karir. Batch pertama ini tentu saja banyak hal yang kami harus benahi. Kami belajar ada hal-hal yang waktu itu kami lupakan atau kami kurang begitu ya. Namun tujuan kami adalah progress, bukan perfection. Saya yakin sudah banyak hal positif yang telah dilakukan oleh para mentor dan mentee dibanding saat kita memulai program ini di awal tahun 2021. Akhir kata, saya mengucapkan terima kasih untuk para mentor dan mentee, khususnya untuk rekan-rekan yang sudah mendedikasikan waktu, tenaga dan pikiran untuk mewujudkan Fresh Graduate Mentoring program ini. Saya yakin para mentor, mentee, dan panitia ini telah menjadi bagian dari tonggak sejarah dalam usaha kita untuk terus meningkatkan kemampuan geoscientist Indonesia di dunia eksplorasi dan pertambangan. Salam MGEI.
Halo semuanya, nama saya Dina Durardi. Saya adalah HR profesional yang saat ini bekerja di salah satu perusahaan tambang batubara di Indonesia. Saya pernah mengisi salah satu program FGMP. Topiknya pada waktu itu adalah Successful Interview to Score Your Dream Job. Ketika pertama kali saya di-approach oleh Mas Nol, yang juga pernah menjadi rekan kerja saya di perusahaan sebelumnya untuk mengisi sesi ini, saya tentunya sangat excited. Karena selain dapat membantu FGMP, saya juga memiliki passion untuk terus memberikan kontribusi sosial di luar kontribusi profesional saya di perusahaan. Pemilihan topik dalam proses mentoring menurut saya juga sangat tepat, karena dengan menguasai proses interview, tentunya bisa mempersiapkan mereka untuk memasuki dunia kerja secara lebih mudah, hal yang mungkin tidak mereka pelajari pada saat di bangku kuliah. Secara keseluruhan, MGEI menurut saya merupakan salah satu wadah yang sangat powerful dan barangkali perlu dicontoh juga oleh mereka yang berasal dari disiplin ilmu lain. Saya yakin program-program MGEI ke depannya akan lebih banyak dan lebih menarik lagi. Wadah ini saya percaya ke depan akan semakin solid dan bisa menjadi support system yang terus berlanjut, di mana anggotanya bisa terus melakukan sharing knowledge dengan pengalaman kerja di perusahaan masing-masing. Salut saya untuk MGEI dan sukses terus ke depannya. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. Saya Agaton Chandra Setiawan selaku mentor untuk bidang hidrologi dan hidrogeologi kegiatan FGMP MGEI tahun ini. Bagi saya, peran mentor cukup penting untuk kegiatan kali ini sebab dapat memberikan wawasan dan pengetahuan di dunia kerja bagi para mentee yang merupakan pelaku baru dalam industri eksplorasi ataupun pertambangan. Lalu, wawasan dan pengetahuan ini dapat berupa teknikal ataupun non-teknikal. dan sehingga harapannya para menti dapat lebih cepat untuk beradaptasi. Seperti yang kita ketahui di mana dunia kerja dengan dunia kuliah tentu sangat jauh berbeda. Hal inilah yang kami harapkan selaku mentor agar dapat memberikan seluruh wawasan dan pengetahuan yang kami mungkin hanya lebih dulu kami dapatkan pada pengalaman kami di dunia kerja. Lalu bagi saya kegiatan FGMP tahun ini cukup baik dan cukup positif, baik para untuk mentor ataupun untuk mentee itu sendiri. Sehingga harapannya di tahun ke depan dapat dilanjutkan dan dapat terus lakukan evaluasi perbaikan sehingga baik mentor ataupun mentee untuk di kesempatan selanjutnya mendapatkan manfaat tentunya. Salam dari saya. Assalamualaikum warahmatullahi wabarakatuh.
Halo semuanya, perkenalkan saya Salma. Saya adalah salah satu mentee FGMP batch pertama. Saya merasa senang dan merasa tercerahkan setelah mengikuti mentoring ini karena saya dapat mengukur perkembangan saya juga dapat menentukan smart goal saya, dan saya juga merasa beruntung dan merasa bersyukur dipertemukan dengan mentor saya yang hebat, yaitu Pak Wesley Randa yang telah sabar mengajar dan membimbing saya melalui tugas-tugas, diskusi-diskusi, atau sekedar sharing-sharing pengalaman beliau tentang karir, tentang on-demand karir misalnya. Dan saya berharap untuk FGMP batch selanjutnya bisa dieksekusi secara lebih baik lagi dan komprehensif, dan bisa menciptakan program mentoring yang aktif dan komunikatif.
Bapak dan Ibu, terima kasih atas partisipasi serta dukungannya dalam acara kami, The 13th Annual MGEI Convention 2021. Saya Emi, dan saya akan memandu Anda dalam mengakses website dan platform untuk event ini. Untuk mengakses event ini, Bapak dan Ibu dapat melakukan registrasi melalui website www.mgeifan.com. Anda dapat memilih pilihan Click to Visit, kemudian pilih opsi Go to Convention Site. Di sini, Anda dapat memilih opsi Exhibitors untuk mengunjungi booth exhibitor dan mendapatkan informasi mengenai info perusahaan, katalog, handout, atau live chat dengan staf representatif dari perusahaan. Untuk masuk ke dalam Zoom presentasi, silakan mengakses dashboard akun Anda, kemudian memilih opsi memasuki live sesi convention yang akan menghubungkan Anda dengan Zoom meeting. Jika Anda belum melakukan registrasi sebelumnya, silakan melakukan registrasi pendaftaran melalui opsi Register yang ada pada halaman muka dari website convention. Silakan mengisi form informasi dan data diri, kemudian pilih opsi Create Account untuk membuat akun baru. Konfirmasi akun Bapak dan Ibu akan dikirimkan melalui email. Terima kasih atas perhatian Bapak dan Ibu. Kami berharap Bapak dan Ibu dapat menikmati acara ini.
Ladies and gentlemen, the event today will start in 5 minutes, so please get ready as soon as possible. Thank you.
Bapak dan Ibu, terima kasih atas partisipasi serta dukungannya dalam acara kami, The 13th Annual MGEI Convention 2021. Saya Emi, dan saya akan memandu Anda dalam mengakses website dan platform untuk event ini. Untuk mengakses event ini, Bapak dan Ibu dapat melakukan registrasi melalui website www.mgeifund.com. Anda dapat memilih pilihan Click to Visit, kemudian pilih opsi Go to Convention Site. Di sini, Anda dapat memilih opsi Exhibitors untuk mengunjungi booth exhibitor dan mendapatkan informasi mengenai info perusahaan, katalog, handout, atau live chat dengan staf representatif dari perusahaan. Untuk masuk ke dalam Zoom presentasi, silakan mengakses dashboard akun Anda, kemudian memilih opsi memasuki live sesi convention yang akan menghubungkan Anda dengan Zoom meeting. Jika Anda belum melakukan registrasi sebelumnya, silakan melakukan registrasi pendaftaran melalui opsi Register yang ada pada halaman muka dari website convention. Silakan mengisi form informasi dan data diri, kemudian pilih opsi Create Account untuk membuat akun baru. Konfirmasi akun Bapak dan Ibu akan dikirimkan melalui email. Terima kasih atas perhatian Bapak dan Ibu. Kami berharap Bapak dan Ibu dapat menikmati acara ini.
Our world faces challenges that no one imagined. We only have one planet. To make critical decisions for its future, we must first understand it. Working together with customers in over 100 countries, we create the Earth modeling, geodata management, and collaboration software that connects science, people, and the planet. Because when everyone sees the bigger picture, they can make faster, more sustainable decisions with less risk to humanity and the environment. Across the civil, environmental, mining, and energy industries, professionals use Sequence software to integrate their teams and data to build Earth models that better reflect reality and can evolve with changes, turning complexity into clarity. Every day, they're changing the world. We're here to help them. A better understanding of the Earth creates a better world for all.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, to the third and last day of the 13th MGEI Annual Convention. This year's theme is Accelerating Perpetual Endeavor Towards Sustainable Mineral and Coal Resources. The future starts today. First, let us all pray according to our own personal beliefs. May today be beneficial and that we are all safe and healthy. Prayer starts. Prayer finish. Ladies and gentlemen, my name is Rahma Marsha. I'm a graduate geologist from Universitas Indonesia, and it is my honor to be your Master of Ceremonies today. Before we begin today's sessions, please give us your attention as we bring you through this safety briefing. 1. Make sure that you are safe and comfortable and not participating in activities that can bring you harm, such as driving. 2. Please locate the nearest emergency exit should there be any natural disasters or any other hazards. 3. Please sit with the correct seating position. Your back should be straight and your shoulders back. 4. Make sure all electric cables and devices are safe from any hazards. 5. Make sure your internet connection is secure and well connected for maximum experience. 6. Make sure to rest your eyes once in a while or use anti-radiation glasses to help your eyes. And 7. Please make sure to keep all masks on all throughout the convention should you be in a public space. Of course, this year's convention would not have been possible without the generous support from our sponsors and media partner. Starting from our Superbite sponsors, we have PT Geofix Indonesia, PT Merdeka Copper Gold Tbk, PT Petrosi Tbk, and our Gigabyte sponsor, we have PT Antam Tbk. Our Megabyte sponsors, we have PT Agincourt Resources, PT Aman Mineral Nusa Tenggara, PT J Resources Nusantara, PT Namsuma Luban Abadi Sumacorp, PT Reka Buana Penjuru Mineral, and PT Sumbawa Timur Mining. Our Kilobyte sponsors, we have PT Eksplorasi Nusa Jaya, Minerba Indonesia, PT Greenland Resources, Harita Nickel, PT Indodrill Indonesia, PT Nusa Halmahera Minerals, and PT Timah Tbk. Our workshop sponsor, we have Sequent Limited. Our other sponsors, PT Medco Energy Mining International, and PT Minevesting Resources Indonesia, and of course, our media partner, Dunia Tambang. To our sponsors and media partner, we thank you for your support in making this event happen. Welcome back, ladies and gentlemen, and to start the first session, we have the theme, Machine Learning for Exploration, Discovery, and Mining. We have 3 speakers. Our first speaker is Dr. Steve Garwin of Steve L. Garwin Proprietary Limited, who will be presenting about satellite-derived topography as basis for geological interpretation and gold, silver, copper deposit targeting, an example from the Andes of northern Peru. Our second speaker, Mr. Rob Bills, of Managing Director and CEO of Emmerson Resources, who will be speaking of application, the latest technology, and exploration for discovery, a lesson learned from Emmerson Resources. And our third speaker, Ibu Kiki Siagian of Aman Mineral Nusa Tenggara, who will be speaking of how machine learning driving the revolution of mineral exploration in Aman Field. This session's moderator is Bapak Bowo Kusnanto of Geofix Indonesia. But first, allow me to introduce Bapak Bowo Kusnanto's background. Bapak Bo Kusnanto previously earned his bachelor's degree from UPN Veteran Yogyakarta. His work experiences are President Director of PT Geofix Indonesia, managerial role Emmerson Resources, J Resources Nusantara, Tigers Realm Minerals, Oxiana Indonesia or MMG, and Perilia Ltd. His technical role is Zinifex Ltd, Freeport Indonesia, Snowden Indo-Asia, and Pulsar Group. His professional backgrounds is IAGI and MGEI. His latest publication is Geology and Mineralization of Biotong Copper Deposit, Nagan Raya, Aceh by Bowo Kusnanto, Stephen Hughes of Indonesian Association of Economic Geologists or MGEI Annual Convention, Palembang, South Sumatra, November 2014. To Bapak Bowo Kusnanto, you may now take the lead. Good morning, Bapak.
Selamat pagi, terima kasih Mbak Rahma. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Good morning,
warahmatullahi wabarakatuh.
ladies and gentlemen. My name is Bowo Kusnanto, and I will be moderating this session with the theme of the machine learning for exploration, discovery, and mining. With the keynote speakers are Dr. Steve Garwin and Mr. Rob Bills, while the invited speakers is Mrs. Kiki Siagian. So before we begin, I have a few housekeeping notes. Today's session is being recorded to be available for post-conference viewing. Pak Steve and Mr. Bills, you will have a total of 30 minutes for your presentation, while Mrs. Kiki, you will have 20 minutes for your presentation. And each of you will have 15 minutes for Q&A sessions, or as time permits. And I may remind the presenters when you have 5 minutes left, and also 1 minute left before time is up. Now, let's please welcome our first presenter, Dr. Steve Garwin. I think many of us has been quite familiar with you, Pak Steve. He is one of the top-notch exploration consultant with a number of world-class success story in mineral discoveries all along his journey. In this occasion, Pak Steve will present a satellite-derived topography as a basis for geological interpretation and gold, silver, and copper deposit targeting, an example from the Andes of northern Peru. Dr. Garwin is a consultant, right now is a consultant, independent consultant, but he also worked as chief technical advisor to Sol Gold PLC and Hot Chili. And he is now also a technical advisor to Japan Gold Corp. He was graduated from Stanford University for PhD and MSc, while his PhD earned from the University of Western Australia. Pak Steve is fellow of SEG, IMM, and AIG. Okay, Pak Steve, I think this time is now yours.
Hey, thank you very much. Let me share my screen. And just to let everyone know, I am on holiday, as you can see, so I apologize if there's any bandwidth problems. If there is a problem, the MGEI will control my slides, but I'll start out with my slides. So today we're going to talk about, just give me a moment while I get all this organized. There we go. All right. Today we're going to talk about basically how one can use globally available satellite topography, such as something for SRTM or ALOS. This is topography that's available throughout the globe at 30 meters resolution that can be processed as you would process magnetics data and gravity data. My co-author, Amanda Buckingham, is a geophysicist, and she did the processing for the data that we'll look at. And this was done in 2009 in the Andes of northern Peru for Hochschild Limited. And basically, topography is a poor man's structural geology. It's available globally. You don't have to put it in a magnetometer in an airplane or a helicopter and fly over very high mountains, such as the Andes, over 6,000 meters above sea level, which would be very difficult and costly. We can use topography to determine where we have peaks, valleys, and slopes. And we'll show you some processed images that help really pick out the edges of major geological contacts. And we'll talk about that as we go. So basically, we have satellite elevation data for 3D throughout the world. And this can be processed to enhance structural patterns at varying wavelengths, from regional scales all the way to deposit scales. We're going to show you an example of the Alta Chicama, or Las Gunas Nortes, Antamina region of northern Peru, which is world famous for over 90 million ounces of gold with byproduct silver and copper that are typically localized along the margins of regional topographic highs. So, and we'll show you this. This is on the margins of major mountain edges, okay, or just on the high side, near cross structures that are expressed in smaller scale topography. So these zones of topographic disruptions or breaks in the grain of the topography where mountain chains wiggle or cross valleys cross major mountain belts. Typically, we believe they coincide with zones of structural intersection, which could be the faulted and fractured margins of batholiths or major zones of uplift. So what we've noticed that there's lineaments defined by the distribution of tertiary magmatic and sedimentary rocks in this area. Most of the deposits of interest here are Miocene, typically middle to late Miocene. And we can draw lineaments that coincide with the distribution of the tertiary magmatic rocks, faults and fracture zones that control Miocene gold mineralization. And if we go ahead and compare these lineaments to regional gravity breaks and geology, we can see there's a pretty close spatial coincidence of gravity gradients and breaks in the gravity field versus topography, which would encourage us to believe that these are structures not only expressed at surface topography, but deep structures that go down kilometers through the crust. And the recognition of these geological, topographic, and gravity relationships allows for regional targeting of prospective areas for gold, silver, copper mineralization. So as a regional setting, this is a map of South America. And people talk about flat slab regions. These are regions in the subduction zone, which is subducting from west to east beneath the western margin of South America, where the slab is flatter. And areas between these flat slabs, the flat slab is steeper. And you can see the distribution of large gold deposits tend to mimic where we have flatter slab subduction zones. Now we'll go further and we'll show you what's causing these flat slab subduction zones are often the subduction of ridges. These are aseismic ridges that are younger than the adjacent ocean crust, hence they're less dense, okay? And so when they get subducted, they don't want to subduct as easily as more dense crust. So they cause more coupling and more contraction between the overlying slab and the downgoing subducting oceanic slab. And there's also a region here up in the north. People can see my pointer. Let me see if I can quickly give you a better pointer. There we go. This is a subducted Incan Plateau. So this is a ridge like the Nazca Ridge or the Carnegie Ridge that actually has already been subducted. And you can see maybe a little minor tail to it offshore here. And this ridge began subduction in the Miocene. And that's significant. It's believed to be significant for the formation of very large Miocene deposits in this region. So now we go ahead and look at the gold districts or regions. And you can see just off the edge of this flat slab to the north in southern Ecuador, we have about 8 million ounces of gold in low sulfidation, intermediate sulfidation, and porphyry systems. However, right above this zone of subducted Incan Plateau, this flat slab region, we have 10 times more, almost 90 million ounces of gold in high sulfidation porphyry skarn settings. These styles of systems, porphyry high sulfidation systems, are more likely to form in areas of contraction related to this flat slab subduction. In between the zone of steeper slab, we get more epithermal type settings, 9 million ounces of gold. We go down to the south, and we get back into the high sulfidation and porphyry settings that like that contractional setting, again, 90 million ounces of gold. So if you're looking for gold, you'll find there's a 10 times greater abundance of gold in flat slab regions versus steeper slab regions. So now if we go ahead and look at a map view and some cross sections. So north is up the page, and this is a map showing you the distribution of earthquake hypocenters for the last 30 years or so, and zones of low seismicity that are related to this coupling of the subducted ridge here and this inferred Incan Plateau that's been subducted starting in the Miocene. And again, you see both areas have lesser seismicity. If we look at a cross section, so A is to the south and A prime is to the north, we see these buoyant ridges or zones of lower seismicity, and you can see actually the Benioff zone is determined by earthquake hypocenters down to the M discontinuity at 760 kilometers depth, are showing you that the slab is flatter. All right, and here's a little section down in the lower portion. You can see the subducted Nazca Ridge making a flatter slab off the edge. It dips more steeply, and then the Incan Plateau, which has largely been subducted already. And I should notice, since the beginning of the subduction of the Incan Plateau and perhaps the Nazca Ridge, there's been quite a bit of uplift. There's been about 2 to 3.5 kilometers of uplift from 11 million years to present. And most of these deposits in this area are about 11 million years and younger. So this coupling has not only caused more contraction, but more uplift of the Andes, okay? All right, so now I'm showing you, that's a child walking behind us near a playground. I'm showing you now in blue outline, these subducted slabs. And I'm also showing you some discontinuities that have been recognized in topography and geology for over 50 years. And they have names, the Huayca Bamba and the Apancay, I'm not saying it properly, disruptions or deflections. And these are well known, have been recognized for a very long time, and they happen to overlie these zones of flat slab subduction. Now, if we look at deposits, the purple ones are high sulfidation systems, the reds are porphyries, and the yellows are skarns. We can see the distribution of these deposits, and we can see the distribution of these deflections and where the flat slabs are, okay? And then we can go ahead and put where the subducted ridges are today, but given that most of these deposits are 10 million years old, this is the location. If we back off 7.8 centimeters a year, undo it by 10 million years, this is the position of where these subducted ridges would have been 10 million years ago when many of these deposits were forming. So you see what's happening is these ridges, at the time of these deposit formations, these ridges have just interacted and just hit the subductant trench, which would have caused a profound change in the stress distribution to more contraction and the beginning of uplift. So these deposits are forming at the onset of uplift. All right, now let's zoom into this area of interest, this flat slab region, the Incan Plateau, where there's over 87 million ounces of gold, all right, and byproduct silver and copper. So what we have here is an SRTM, Shuttle Radar Topographic Mission, satellite topography, all right? And this was collected, you can get this off the internet, and Fathom Geophysics, Amanda Buckingham, collected this data for myself and for the client, Hochschild Mining. And this is this northern region of Yanacocha, Alta Chicama, and Antamina and Parina, all well-known gold, copper deposits. And what we have here in black lines are digital 1 million sort of nominal scale geology of faults. And we have it draped over the satellite topography, blue being low levels, and the going through green to brown to white being the higher mountains. Now what we have is that this satellite topography has been processed to 5 kilometer wavelengths. So imagine this is us walking up and down mountains all day, mountains and valleys. We process it to a wavelength of 5 kilometers, And this becomes that. We're seeing the bigger picture. So now what we see here, the magentas are the very, very high Andes, okay? This is the Sierra Blanco, the White Mountains, full of snow and glaciated. And this other range in here, the more coastal range, which is steeper but not as high, is the Sierra Negro, so it's sort of the black, dark mountains. And then we can see the distribution of deposits, Yanacocha, Alta Chicama, Antamina, and Parina. Okay, so that's kind of interesting. We're trying to separate the forest from the trees. We're seeing the 5-kilometer wavelength, which I find is a very good wavelength for region to pull out the regional faults. Now this has been processed to enhance the topographic highs, and it's color-coded not by elevation above sea level, but by kind of the relative elevation above the adjacent valley. So it's telling you how steep it is. This is the higher Andes here, this mountain chain here, and you can see the sort of north-northwest chain of the Andes. But you'll notice actually that the Sierra Negro, the more coastal, slightly more coastal, or I should say the western paired mountain chain, is steeper but not as high as elevation. So since it's steeper, it's got these higher colors like magenta. And the important thing is we can see the overall trend of the Andes, but look at these cross features. I call them horseshoes, all right, or cross features, where you have cross valleys and cross ridges breaking up the overall trend of the Andes. And these are very interesting, particularly when you look at where the deposits occur. Yanacocha is on one of these horseshoes, where there's a major northeasterly cross structure crossing the northwesterly Andes. Alta Chicama, the same. Parina also on a cross structure, and Antamina a bit less so. And then you can see the relationship of these deposits being with about 2 kilometers, either on the high side or low side of a 5-kilometer wavelength mountain, okay, or topo high. And that's important. So this is outlining structure for us and the location of the deposits being near these major breaks, which could be the edges of batholiths or the edges of major zones of uplift. So keep that in mind. So there's Alta Chicama, all right? So we go to Alta Chicama right here. This is looking at it from Google, all right? And now you can compare it. So this chain here, we're looking north. So you see that it's on this big horseshoe and this northerly break going here. That's this northerly break here. Here's the horseshoe. This is a cross structure. And this is where this dot, if you were to plot this exact dot here in Google Earth, it would plot there. Okay, so that's what this sort of topography 5-kilometer wavelength image translates to when you look at it from space. Now let's go down to Parina, okay, which is an active mine. All right, now we're looking to the north, and that is the Sierra Blanca, the big high mountains. But this is the Sierra Negro, which actually are steeper. It's a little hard to appreciate that in this photo, but again, if you see where Parina occurs, we're looking north, so we're seeing the big high mountains, but this is the overall chain is north-northwest, and you can see these sort of cross features going through in here, these cross valleys. Okay, so that's what that looks like. So now I'm not going to show you the gravity map from which this came, but these are gravity lineaments that one can draw, or you can get them from various sources. But they're basically saying, look, these are major changes in model density of the Earth's crust. And we can see all these blue lines are gravity lineaments, which are drawn completely independently of this topographic 5-kilometer wavelength feature. And we can see some parallelisms. We can see some breaks in the topography corresponding with gravity gradients or breaks in gravity. So that might give us, there's a very good example there, another example here, another example here. So this may give us some comfort that these major gravity lineaments could be faults, steep faults that are juxtaposing rocks of different density, okay? And that those perhaps are corresponding to the flanks of major regional topographic highs, i.e. fault and fracture zones, separating different geology on each side. So now what I've done is I've taken off the gravity gradients, and I just with hand drawn, I drew gradients in the topography. So where I saw breaks in the 5-kilometer wavelength, of enhancing the cross structures, the arc parallel Andean trend is very clear, north-northwest, but I've drawn in by hand these black lines, which are these cross-structure topographic breaks. And you see they correspond with these horseshoes. Okay, and I think those are faults, or fracture zones, or margins of rocks of different density or different competency. Some things that are hard that make mountains, some things that are soft that make valleys, and the fracture zones or faults in between. Now here's geology, okay? And so what we have here in orange and yellow are the tertiary volcanics in orange, and the sediments, sedimentary rocks, volcano-sedimentary rocks in orange. Little black or brown, I should say, tertiary intrusions. These are important. And you can see there's major, these are the older rocks, these are the Jurassic Cretaceous rocks, and this is a major structural dome here, okay? North-northwest, trending, plunging to the northwest, plunging to the southeast, intruded by a series of neogene plutons. These are the high Andes. These are the snow-covered mountains that we saw. All right, now I've drawn these geological lineaments based upon the tertiary. So you can see my lines are breaking up zones of tertiary volcano-sedimentary rocks, alignment of tertiary intrusions. These aren't necessarily mapped as faults, but my interpretation is that they were strong. They were controlling the distribution of the tertiary and particularly the Miocene rocks, and we're looking for middle Miocene age mineralization, middle to late Miocene. So that's what I'm homing in on. So I'm saying these lineaments double as fault and fractures that were active during Miocene mineralization. Okay, so there we're going. Now I put the deposits on. You can see where Yanacocha occurs in a tertiary volcanic field at an intersection of some geological lineaments. Alta Chicama right on the margin of a Miocene volcanic field. Purina on the margin of the volcanics. Antamina inboard. Antamina is more eroded, but again, it's on some of these geological lineaments that you can see offset the Jurassic and Cretaceous basement rocks, and even offset and set up the distribution of these neogene plutons, which are over 4 to 5 kilometers above sea level. So they've really been uplifted quite a bit. Now we've got the 5-kilometer wavelength topo highs with, in yellow, the Miocene volcanics, all right? And the little brown ones, hard to see, these little brown guys, these are the tertiary hypabyssal intrusions. So again, you can see very clearly the distribution of the large Miocene high sulfidation systems and porphyries are often on the edges or just within the volcanic fields along these geological lineaments, or inboard along the continuation of major active tertiary trends. So now we're going to zoom in even further into the Alta Chicama, Purina, Antamina region, blow it up. So there's the geology map. So the Cordillera Blanca plutons are as young as 2.7 million years old. They're neogene, and they've been uplifted about 4 kilometers in 3 million years. So that's pretty phenomenal. So we've already eroded through any porphyries or epithermals that were on top of this, okay? But what we do see is all around the edge of what is a major dome. This is a dome in the Cretaceous and Jurassic rocks that then have been intruded upon by the neogene intrusions. And prior to the neogene intrusion emplacement, anywhere from about 7 to 14 million years ago, we have all these deposits forming associated with the volcano-sedimentary and volcanic rocks around the edge of the dome. Okay, now there's the satellite topography from space. Again, blue is low, green is higher, brown's higher yet, and white's very high. And you can see where the deposits are lying. Most of them are occurring just on the eastern flank of this Sierra Negro, the steeper mountains, the western belt. Of course, they're not in the large snow-covered mountains because you've already uplifted into batholith levels. And these deposits, much of them predate the uplift of the Sierra Blanca, the white-colored glaciated mountains. So this is fine, and I've gotten black lines, the digital faults from the survey of Peru. But we processed this, or Amanda processed this in this case, and now we've got 5-kilometer wavelength. So this is color-coded with distance above sea level, hence the larger, higher glaciated mountains here, Sierra Blanco, and to the west is Sierra Negro. Now you can start seeing the deposits occurring around these little horseshoes, if you will, and maybe cross structures, but not so clear until you process it to enhance these steeper slopes above the adjacent valleys, color-coded by the steepness. So again, these are the taller mountains, these are the steeper mountains. I've gone ahead and drawn in my topographic breaks by eye. Now you can see where the deposits are, all within about 2 kilometers of the margins, either on the high side or in the valley side of these major topo highs, flanking the Sierra Negro and along cross structures. I think this is pretty powerful. So then you might say, well, what's here? lovely intersection zone on the margin of the Sierra Negro in a similar setting to Parina. So that's where we're going with this. So now, to show you how one might use this, is I've got some just indicative targets. And so these targets are basically shown. It's a little bit messy, but you see the 5-kilometer wavelength topo highs, color-coded by their steepness, the edge of the Miocene volcanics, all right, in yellow, and various forms of cross structures. I've got the gravity lineaments in blue, I've got some geological lineaments in gray, the topo lineaments in black, the distribution of the brown, tertiary, high-level intrusions. These are very important, be them andesitic or dacitic, okay? And again, we're looking for high sulfidation systems here. And you can see there's Yanacocha, okay? There's Alta Chicama and other prospects. So there are some other areas of interest. So this is how I'm using this. It's like a pattern recognition. Here, where you've got tertiary intrusions, you've got the edges of Miocene volcanic fields, you've got the intersection of many lineaments that are proxying for faults and fracture zones on the edges of these 5-kilometer topo ridges. In terms of geology, we can see that as well. So this is how you might use this sort of going from satellite topography, processing it to kind of bring out the large scale. Doesn't have to be 5-kilometer, it can be other ranges of wavelength, to bring out the big structures, all right? To superimpose the geology, the time of interest is the middle Miocene, okay? Well, let's say 14 to 7 million years old to late Miocene. So we're looking for that geology, interpreting the geological lineaments, using the topographic lineaments, and the assumption is that the geology is affecting the present day topography, and that's very common throughout the world, and looking for the major topo gradients, okay, which are good fault and fracture zones. Throughout the world, many deposits lie along these major topo gradients. And then using that pattern recognition to find other zones of lineament intersection in the same structural settings as the deposits. Okay, we can do that in the Parina area here too. You can see Parinas on this beautiful cross structure right on the edge of the Sierra Negro, on the edge of these volcanic fields, nearby tertiary intrusions. And we can see Antamina in a similar setting, but see here we've eroded down through, we're into a porphyry skarn setting. We've eroded through the higher level high sulfidation domes. And then other areas, look at this beautiful horseshoe here. Okay, and something else that I haven't shown you, what were used in coming up with these targets was aster inferred hydrothermal alteration. This is 2009. Okay, now you could use Sentinel-2 and other things to say, where are the zones of advanced argillic alteration? Where are the zones of sulfide or iron oxides, higher jarosite after weathering of sulfides? And so that's also been used to highlight some of these areas. Right, and again, seeing the geology here, and this is on the southerly plunge of that major dome that we talked about, filled by the neogene intrusions, and Antamina, I believe, is about 7 to 9 million years old. So it came in just before these intrusions came and uplifted the whole area. There might have been an Antamina on top of this batholith, but if so, it's been taken up by younger rocks and uplifted 4 kilometers, it's gone. But on the flanks, all around the outside of this dome, we're finding some interesting mineralization, particularly on the west side. So, to summarize, the good stuff in South America, good stuff being the large deposits that are related to intrusions and enhanced coupling and contraction related to flat slab, okay? And that's been happening since the Miocene, okay? And, you know, the deposits seem to be localized along these margins of these regional topographic highs near these cross structures that you can also see in topography. And you can determine lineaments based upon their distribution of your target horizon, which this case is Miocene, magmatic and volcanosedimentary basins, looking for the distribution of intrusions, because many of these systems are intrusion related. And we can also use gravity or interpretations of the topography, particularly where they coincide with geology, and to determine zones of lineament intersection, the idea being the more structures that are going together at the time of mineralization, the more fluid flow, focusing the intrusions and focusing fluid flow that carry the gold, silver, and copper. And most of the deposits that are big in this area lie within or near the Miocene volcanic fields, although some are inboard in areas that are more eroded, such as the Antamina skarn and porphyry system. And they're almost always associated with high-level intrusions near zones of lineament intersection at varying scales. And if you go ahead and use this pattern recognition and see how the known deposits and prospects correlate to these elements I've just discussed, then we can find other areas that have a pattern repetition that might be good zones for exploration, particularly if you bring in other layers. Those other layers might be geophysics, remote sensing, spectral work such as ASTER or Sentinel-2, or of course, field geology. And the key to all this, you might, in a period of a week, prospect from space. You have your regional digital data sets, you have your gravity, you have your satellite topography, your interpretations, and you prospect from space, but then you have to go to the field and see what's there at those areas of interest. And then you can revise your targeting scenario. You might say, oh, geez, this area here is too much uplift. So we have to throw out all those targets because we've eroded away the porphyries and the epithermals. So this is very important, going to the field and then doing a feedback loop on the targeting and incorporating field geology. You do not find deposits from space. You find deposits from field work, all right? But the Andes, it's a big place to go. It's a big playing field. So we need to focus where we go in that playing field by using these sorts of tools. But again, discoveries are made in the field, so that's an intimate part. So we need, if people are going to the field, they need to feed back to anyone doing this sort of targeting work. And better yet, the people that do the targeting, as I've done here, I went to the field for a few weeks with these guys, and we enhanced our targeting after that. I'm just showing you the general stuff which we're able to share. So thank you very much. We'll close with a picture of Parina and Alto Chicama or Lagunas Norte. And I'd like to acknowledge this originally was done for Minera Hot Shield Peru in 2009. So you know, that's how I'm able to share this data with you. Thank you.
Well, thank you very much, Pak Steve. That was excellent presentation, very interesting and of course very inspiring. So now, if anyone have any question for Pak Steve, please raise your hand and turn on your camera or write it down in the chat room. So the Q&A now is open. Well, Pak Steve, before waiting, while waiting for the questions from the participants, for me, this is quite new method in generating projects, either for regional or district scale prospectivity. But you know, this is very interesting. How if this has been one of your tools in your recently discovery in hot chili and in salt gold, because you know hot chili is really hot, while salt gold is just overwhelming on the deposit that you have just recently discovered.
Well, in hot chili, I can't claim that we use this. We're just doing it now with hot chili for regional exploration. Cordillera in northern Chile was already discovered. And of course, my involvement with that was basically helping them recognize it as a porphyry and drill to make it much larger. Now, in Cascabel too, Alpala, which is a very large ore body, 20 some odd billion pounds of copper, 25 million ounces of gold, and 100 million ounces of silver as a byproduct in the porphyry system. That was found independent of this, although we noticed early on in the exploration that there was very strong relationship to topography. And so we were prospecting after the initial discovery of Alpala, but we found more since then, including Tandayama to the north 3 kilometers. That there was very strong lineaments that we could see from aerial photographs and topography. So we didn't even have to process the data to do that. But again, that's something that was very clear, and it helped us in our mapping. And our mapping confirmed that the structural trends we saw in the aerial topography, aerial photographs and topography were indeed fracture zones filled by copper, gold-bearing quartz veins and fracture systems. Now, the most recent announcement made for the Porvenir deposit in southern Ecuador that we just discovered a year ago with SolGold and put out the resource statement of about 500 million tons at 0.45% copper equivalent, something like that. And that was just announced yesterday. That's in southern Ecuador, and that was in an area that was targeted with regional data, not just satellite topography, but gravity, geology, and the geologists were familiar with the area, and that was a grassroots discovery. So you could say the satellite topography played a part in that discovery. But of course, the discovery was found by walking the streams and the creeks and using the geological hammer to recognizing it was a porphyry system. I've done this method with Amanda, for probably 20 years now, and used it. The idea came out of Nevada, out of the Carlin Trend. And there we noticed many of the deposits and elsewhere in northern Nevada, the Battle Mountain region, were on these major breaks in topographic slopes. And it took a while working with Amanda and Dan Core, also Fathom Geophysics, to determine the best way of processing satellite topography to bring out the structure. I've used it elsewhere in the world with some pretty good effects. And, you know, we have found some small prospects and actually some things that we refound 1 million ounce gold deposits in northern Peru that we didn't know were there. We looked and we went, what are all these drill holes doing here? And it turned out a Canadian company had a 1 million ounce resource there. So I think it's useful. I'm not going to say it's the only way to find deposits, because absolutely it's not. And I can say at best, it plays part. It's this part of you have so many arrows in your quiver to shoot at the target. And there's no one arrow, there's no one silver bullet to find a deposit. It's integrating what's available and then going to the field. So I'm saying that this is just one technique that many people probably haven't used, but it's easy to use.
Sure. Yeah, but Steve, there is one question that has been written in the chat box by Pak Alfon Priambodo. Mr. Steve, by only looking on the lineaments, is there any lineament characteristic differences to regionally preliminary figure out the deposit type, like porphyry, high sulfidation, low sulfidation? Is there any unique differences?
That's a good question. I would say your geological setting is better. The topography tells you about structure and edges of geological units, but it doesn't tell you your structural level, at least not that I know. But looking at the geological setting, so saying, is there still a tertiary volcanic field there? Okay, if there is, more likely epithermal. But such as Antamina, you're off to the east, and you're in older basement rocks. You're in the Jurassic Cretaceous sedimentary rocks. There you would be looking for a porphyry or deeper, you know. So I think geological setting is the way to help determine your sort of structural level in the system.
Very good. Is that okay, Pak Alfon? And the next question is from Pak Budi Santoso. Please, Pak Budi.
Thank you, Pak Bowo. Hello. Good morning. Selamat pagi, Pak
Budi.
Steve. Hi,
Nice to see
Amanda.
you.
Thank you very much for making your time to join with us. Pak Steve, I think this is a very good presentation and very good things to share, especially in a country like Indonesia, where the regional data is not largely available like what you have in probably another part of the world, like Australia, or even maybe in South Americas or Americas. I would like to know about the scale, but is there any different scale that you could or should apply depending or targeting a different scale of targets? I mean, in the regionally, districtly, or probably in the level of prospect? That's the first question. The second question is about the whether it will. I'm sure that it will work worldwide in any other type of geological setting and terrain and age and so on. Is that the case? And is there any other place that you think you have ever worked and it has a good correlation between what you have done on the desktop on the in comparison to the ground truth checking like you have done in South America, and where we could actually get the data. Is that available publicly or something that people or companies should contact somebody or company that has provided the data? Thank you, Pak.
Okay, 3 questions. I like, for regional targeting, I love the 5 to 10 kilometer wavelength scale. Something else that we use a lot is 500 meter to 2 kilometer, 2 kilometer, 5 kilometer, 5 kilometer and upward. So Amanda and I often do about 3 different scales. You can go more detailed, particularly if you're going down to the 30 meter resolution. In many areas, you're covering large blocks of land, and that's a lot of data, a lot of processing. Sometimes the images are very large. So often Amanda will downsample from 30 meters to 90 meter pixel resolution to 200 meters if you're doing a whole country. So it really depends what you're after. I really like this 5 kilometer wavelength, although we have gone to more detailed scales, as mentioned. Age-wise, as long as there's a relationship between topography and geology, the age doesn't matter. I mean, this won't work if you're in a flat area covered by sand, like a sandy desert of Western Australia. But I've used this stuff in areas that were up to 500 million years old. As long as there's mountains and topography, it's useful. Certainly if it's young in the last 10 million years, there's much less stress. You don't have to have such an imagination to say there's a relationship of geology to topography. But even in older belts, as long as there's erosion, certain units are harder, certain users are less hard, other units are more fractured. Alteration softens the rock, so it affects topography. And lastly, yes, you can get this. This is publicly available data. Processing it's the trick. And this is where I could direct you to Amanda or a geophysicist and say, process this topography data as you would a potential field database such as gravity or magnetics. I'll let Amanda answer the question, so she'll unmute her phone or unmute her camera now, and she can tell you where you can get the original data. But for processing, I think Amanda and Fathom Geophysics is one of the best to process it. But Amanda, perhaps you can tell them where they can get the data.
Thank you, Steve. I think I'm audible now. So great. Into the chat box, I've just put the URL, so the website where you can go and download the data. It's open file, public domain, global data. There are 2 different types. You can use SRTM or ALOS, the Advanced Land Observing Satellite. I prefer to use ALOS these days. The precision is just a little better. They're both 30-meter data sets. So please look at the chat box for the direct link to where you can actually download the data.
Thank you, Amanda.
Thank you, Pak Budi and Pak Steve. And there is another question from Pak Arif Ismanto.
Hi, Pak Arif.
Good morning, Pak Steve Garwin. Thank you for your very comprehensive explanation on this topic. Long time not see you. Last time I saw you in Garini.
Yeah, sudah lama, Pak. Aduh.
Okay, Pak Steve. Yeah, there are several questions, and part of the question goes to Amanda. First is you mentioned about the filtering of a 5 kilometer. That is upward filtering, or that is a spatial in the lateral. Maybe Amanda can also explain about that. And then the second one is the challenge when we have the interpret in the structure framework. Sometimes we are challenged to differ between the scene mineralization structure and then post mineralization structure. Otherwise, all the structure is already supported by the satellite data or also the gravity. But sometimes we still deal a challenge with that in relating to focus where the structure that deal directly with the potential mineralization. And then the last one is sometime in the regional or in the before we goes to the prospect scale, sometimes we also combine with the radiometrics. So sometimes when we have for example, like intersection structure, and then it will be fit with the radiometric, that could be the potential for the potassic alteration, kind like that. So maybe yeah, that's need your explanation also about that the pattern. I think that's all, Pak Steve. We wish you continuous success for the next. Thanks, Pak Bowo.
Yeah, please go ahead, Amanda.
Thank you. Just in regards to the question about the filtering, and it's a very good question. There's a lot of filters that are available to process geophysical data. The ones that we use, the main filter is called upward continuation. It's actually called residual upward continuation. And all you're doing is treating the topography surface as a continuous surface, and you're applying a smoothing filter. And what that really does is it separates the high frequency, the very busy part of the topography signal, from the low frequency, the longer wavelength, larger responses. And by doing that, it's very easy for the interpreter to see patterns and recognize patterns in the detailed and the regional topographic surface. And they're quite different, and it's actually really useful to see them as separate responses. So the filters that we use are designed for geophysical data, actually designed for potential field data. So they're the same filters we use for magnetic and gravity data processing, but they're just as applicable to a topographic surface. In addition to that, there's some other filters that we use, and the group of filters is called morphological operators, and it's a way to separate, once again, to separate the topography based on frequency. It's probably not worth me explaining those in detail, but we really treat that surface the way we treat other geophysical data, and we separate responses from detail and regional wavelengths. And just one comment, but I'll let Steve discuss it in detail. Using radiometrics is a fantastic idea. If you've got a response, radiometric data is only a surface method, so you need to have a response in the upper 50 centimetres, but you often do in a lot of places globally. So like Steve said earlier, the more data sets you use, the more you bring different data sets together to define a target or an area of interest, the more robust your whole targeting system is.
Yeah, to comment on if you're looking for a potassic zone, Amanda said, certainly radiometrics might be effective if you've got exposure, it's not covered by forest and all these other things, landslides, or can be helpful in exposing the rock. But I think, from my experience, if you're looking for a porphyry, metal zoning is very, very useful, even more important than alteration zoning. So if you had a stream sediment database or a ridge and spur or grid soils, looking at molybdenum divided by manganese, copper divided by zinc, these help vector you towards the centers of the porphyries, which may be above the potassic zone, may be in the potassic zone, depends on the level of erosion. And then of course, mapping. Mapping is pretty powerful stuff, and there's only so much you can do from space. Spectral work might help. Again, it might help with the zoning in addition to the radiometrics. But again, going to the field is a very important thing when you get to those levels. So I agree, integrate our approach. We're explorationists, we're applied scientists, use the data that's available, and go to the field.
Yep. Thank you very much, Pak Steve and Pak Arif, for the very good question. Also for Ibu Amanda, that's very clear understanding of that this type of method, satellite-derived topography, is helping us in generating projects either in regional scale or or district scale, which is very good. But I also like the notes from the past Steve. The real deal is field work, mapping, taking some picking some rocks, samples it to see if there is any interesting minerals that we are looking for or other indications in field. But of course, this method that I have just introduced by Pak Steve and Ibu Amanda is really helping us in accelerating the process, localize the potential. So yeah, this is going to be a combination of everything will beneficial for us. Thank you very much, Pak Steve. And now I return time to MC, Mbak Rahma.
Terima kasih banyak. Nice to see everyone again.
Thank you very much, Bapak Bowo, and also thank you very much to Dr. Steve Garwin for your presentation. And now we would like to give the memento of appreciation virtually, which will be given by Professor Mega of a distinguished staff of MGEI. Okay, if Professor Mega and Dr. Garwin could please look to the screen. All right,
okay, good morning, Steve.
3.
Good morning,
3,
Steve.
2, 1. Well, just a second. Okay. All right. Thank you very much, Dr. Garwin, for your presentation again. Thank you also to Professor Mega. And now I would like to give the next session again back to Bapak Bo. Apologize again, sorry. We would like to take another group photo with Dr. Steve Garwin, Bapak Bo, and also Professor Mega. Okay. Can everyone please look to the screen? All right, I will count from 3. 3, 2, 1. Okay, very good. Thank you very much, everyone. And now I would like to give the next session back to Bapak Bo. The time is yours.
Thank you, Mbak Rahma. Now we are going to the next presenter, Mr. Rob Bills, who going to present an interesting topic of application to the latest technology and exploration for discovery, a lesson learned from Emmerson Resources. Mr. Bills is CEO of Emmerson Resources, CEO and Managing Director of Emmerson Resources. His education background is bachelor degree from Monash University, graduated in 1984, and then master from James Cook University in 1989, and is a fellow of the Society of Economic Geology and Australian Institute of Geosciences. Mr. Bills joined Emmerson Resources in September 2007 up to present day as Managing Director and CEO, and he has 25 years career in exploration and mining with Western Mining Corporation, then BHP Billiton. Mr. Bills held numerous senior management positions in mine geology, research geologies, and exploration across many jurisdictions, including 5 years as President Director of WMC in Indonesia. Oh, so you have been in Indonesia, Pak. And more recently, Mr. Bills held the position of Global Commodity Specialist at BHP Billiton. Mr. Bills brings to the company a track record of global exploration and management success, including a detailed knowledge of mineral deposits and a deep understanding of creating shareholder value from the business of exploration. That's very impressive background. So now, Pak Pils, please, the time is now yours.
Selamat pagi. Many thanks for that introduction, Pak. Welcome, everyone. Unfortunately, I've forgotten most of my bahasa since my time in Indonesia, so I do apologise for that. Today, I'd like to talk a little bit more about exploration philosophy, more than deposit scale and regional scale geology. So it's a little bit different than the presentation of Steve's. So it's based on the Tennant Creek mineral field in the Northern Territory. And also, unlike Steve's, this is a very old Paleoproterozoic craton. So it's very different than what we were talking about previously with Steve on porphyries and epithermals. So Tennant Creek, it's an exploration hotspot here in Australia. We've been in the Tennant Creek field now for over 12 years. And some recent data from a number of the government agencies, non-competitive data, has created a pegging rush. And you can see from this tenement map, almost the entire area is pegged. It's mostly undercover, and they're all looking for iron oxide copper gold. So certainly very different than porphyry copper and epithermal. It's your sort of iron oxide copper gold. So that's really what I want to talk to you today about. So first of all, like every discovery, it's really the discovery team. So this is very much, a team effort. We've had a team, like we did in Indonesia, we had some absolutely superb geologists. Pak Budi was one of those. In Tennant Creek, our discovery team is led by a Filipino geologist, Liesl Kuzon. We have Indigenous workers, also technicians, field techs. We've got a number of other people that have been with us for many, many years. And it's interesting, we've just announced a terrific copper intersection last week, and the press was, it was an overnight success. Well, it took 12 years of systematic science-based exploration to find it. I guess that's what most people don't see, and that's what I want to talk a little bit about today. So this ASX announcement, 117 metres at 3.4% copper at a project called Hermitage. An absolute stunning result. This slide is on the left-hand side, you can see the magnetics. So the red is obviously the mag high. The Hermitage project is a slightly smaller magnetic anomaly off to the east. Don't take the size of the anomaly as reflective of the size of the mineralisation, because what the theme of this talk is about the hematite, the non-magnetic end member, which hasn't been explored for before. But I think we'll talk a little bit about that. Over the right-hand side is some of the rock chips. So it was an RC drill hole. We went through a full zone of malachite in the oxidised zone, going down into about 30 metres of native copper. And then we went down into the primary zone of chalcopyrite. Now,
excuse me, Pak Rob. The screen is freezing here. Would you please wait a moment and then back again, re-upload your presentation?
Go back again?
Yes. Because here the screen was frozen and
okay. Is it okay now?
It is no, not yet. Or is this probably from the host MGEI office?
Yes, fine on my side, Puck.
Yeah, no, it's good. We can see you well.
Okay, so How's that?
Excellent.
Okay, so sorry about that, guys. The next slide is the magnetic anomaly. Can you see that slide? Yep, magnetic map. Okay, so we talked a little bit about the size of the various magnetic anomalies. Then we have the RC drill chips on the right-hand side, where we went from malachite through to 30 metres of native copper and then into the primary chalcopyrite zone. So the cross-section or long section through this is this next slide. I hope you can all see that okay. You can see the drill hole HERC 003, 117 metres at about 3.4% copper. Had some very high-grade gold in there as well, ending in mineralisation. So the last bit of the mineralisation was 3 metres at about 15 grams per tonne gold and 4.3% copper. Unfortunately, the hole was abandoned at 192 metres because the drill rig couldn't drill any further. So obviously we'll continue that hole with a diamond tail next year. But an absolute stunning result. We don't know how big yet. It's only very early days. And the geology there is the blue is what we call ironstone. That's a local term for iron oxide assemblage. And that assemblage consists of magnetite, hematite, jasper, and some quartz. And what we think we've drilled into there is a breccia pipe. We don't know the dimensions of that breccia pipe yet. That'll be the subject of further drilling next year. So now we turn to the Tennant Creek mineral field. So that slide, you're looking at about 150 odd kilometres across from east to west. The pie charts are the size of the deposits, the historic deposits that have been found, with the brownie gold being the gold produced, the blue, the copper produced. All these deposits also have bismuth. So you can see in the grey there's some bismuth. So Warrego out there to the west is the biggest deposit, over 1 million ounces of gold. The interesting thing about this field, it's been around for a long time. It's one of the few underexplored provinces left in Australia. So it hasn't seen a lot of exploration in the third dimension. Only 8% of the drill holes have reached a depth greater than 150 metres. So you can see that it's mostly covered. It's a different sort of scale than what we've been talking about in porphyry coppers. And the key to Tennant Creek is the old geological adage of grade is king. The higher the grade, the higher the value of the deposits. These are very, very high grade, high value deposits. Now, I want to talk a little bit about our exploration philosophy here in Tennant Creek. That's been explored by many very smart companies and geologists previously. But what I want to talk a little bit about is the two things, prediction and detection. And I want to use this illustration of these poor souls that were on Malaysia flight MH370, which I'm sure you all heard of. Now, they're trying to find that plane, obviously. So how do you predict where it is, and then how do you detect it? Well, their prediction, the position of the satellite, the last known signal, they think the plane flew for another hour. They didn't know at what speed, they didn't know where exactly. They can only roughly guess, and that provides very little guidance as to the area, the search area, as you can see on the left. So there's a big problem with the prediction, and then when you go to detection, you've got to cover obviously a very large area. And once that the black box signal runs out of current power, it's very difficult to detect, particularly as we're talking about 4,500 meters of sea, a depth of sea. So you're trying to find something down there a long way down. So that, to me, is what you don't want to do in mineral exploration. You're not going to be successful. So just maybe touching a little bit on scale now. So of course, this slide, it's scale dependent. So you want to be able to predict in the broad regional sense, and it's effective at the broad regional broad regional scale. You can see that here. As you get down to the prospect scale down in here, you know, you have to be flexible, but it's less effective, and that's where your detection comes in. So I want to talk a little bit about that in terms of Tennant Creek. In Tennant Creek, we used some prediction technology. We've used a number of different prediction technologies, and it's all about using multiple independent data sets. So it's a bit like the analogy with a treasure map. You give your kids a treasure map and go, here's the treasure, guys, on this map, X marks the spot. Well, unless you have independent data to actually verify it's there, it's probably not going to be there. So we've used a number of processes to try and narrow down the search space, which I'll talk about. And then in terms of detection technology, we've used a variety of detection technologies. So what we started off with was a mineral system for iron oxide copper gold, and we used our partner Kennex to run the models. We were the owners of that model, so we controlled the inputs, and it was modeled using weights of evidence and linear regression. So the key inputs were, you know, the porphyries, the source of the iron was the Warramunga group, they're the host rocks, proximity to faults, all those various things. So they were the inputs that we used to come up with, you know, these weights of evidence targets. I'd have to say it wasn't particularly successful in terms of revealing new areas, because unfortunately, where you have limited data, this sort of modelling doesn't work very well. And we found that out, I guess, the hard way. What some of the inputs into that model, however, were quite useful. So we did some age dating, and what we've come up with is a very close temporal relationship between the iron oxide copper gold mineralisation and what we call the Tennant Creek supersuite. Now, this is a suite of porphyries and intrusions. So this is probably the first time in the history of Tennant Creek that we're able to actually tie in the source of the copper and gold to specific intrusions. So obviously that's a big step forward in terms of prediction. The other thing that we're able to do is a detailed structural analysis of the field, and we came up with some primary controls on the mineralisation down the right-hand side. So there's a number of deformational events there, with D3 being the most important event because that's the copper gold event. So we know what the D3 event looks like. That's the blue line with the ironstone written on it. That's the orientation. Then there's a lot of superimposed events, okay, post-mineral events, which controls, you know, the orientation of the mineralisation. It also remobilises some of the mineralisation and you know, generally disrupts things. So the interesting thing, however, is that the ironstone event, that 90 to 100 degree orientation, is the main ironstone or iron oxide orientation in the field. So that's the one you want to look for. Now we put all these parameters, our magnetics, our gravity data, our geochemistry, our geophysics, into a 3D model. And you can see here, we supported a PhD student to do this. through the University of Western Australia. So Emmerson funded that PhD. And down in the left-hand corner, you can see a little square box with density going up to the top, which is green. So very dense up to the top, and then across to my right is very magnetic bodies. So you've got the colour scheme there. If you're looking for a very magnetic body, it's going to be red. If you're looking for an incredibly dense body, it's going to be green. And if you're looking for a magnetic body and a dense body, it's going to be black. Now, interestingly, the Hermitage deposit or discovery is right out here, very dense, black. So it's magnetic and it's very dense. So that immediately starts telling you some things about this. The red areas are the intrusions, magnetic intrusions. These are the Tennant Creek Sweep, the very oxidized intrusions. And the iron oxide bodies range between hematite, dense, non-magnetic, to magnetite, dense, and obviously magnetic. So you got the full range of iron oxide copper gold deposits in this field. This is a interesting graph of the law of natural population. So if you applied this in Indonesia, you'd have the Erzberg-Grasberg deposit up at the very top as the giant deposit in the in that particular arc. And then, you know, typically in a law of natural populations, you have one giant, you have, you know, a couple of medium-sized deposits, 5 or 6 medium, and then it scales down to a tail of smaller deposits. So if you apply that same law of natural populations to Tennant Creek, you see that there's the big giant hasn't yet been discovered. And then there's a number of undiscovered deposits all the way down that curve. What we can say about that is that because of the exploration history, there's been a lot of previous exploration in the area. They've just drilled all the magnetic anomalies. So all the magnetic deposits have been found. So all of the green triangles here are magnetic related iron oxide copper gold deposits. We can predict that the undiscovered ones are going to be hematite, so non-magnetic. So they're the ones that we're after. And this is a little bit of a discovery history where, you know, in terms of detection techniques, you start off with, you know, aeromagnetics, obviously great for the magnetite hosted deposits. After a while, though, you drill all of these, and this is a production, is the yellowy orange color is copper, is gold, and the green is copper. So that's the production. So you obviously find a lot of deposits, they start producing. You can see the deposits across the bottom when they were discovered. So most of the deposits were discovered after that initial aeromag survey. Then you become down a path of diminishing returns. So in other words, you've drilled and found all of the magnetite hosted deposits. There's no more to find, or there's very few to find. So when Emmerson came into Tennant Creek, we realised this and we applied some new prediction and detection technologies to reactivate the discovery history. And so far, we've found 3 deposits, Edna Beryl, Mauritania, and the recent one is Hermitage, and that's using new techniques and new technologies. Some of the old technologies, this is the Tennant Creek mineral field, fixed wing aeromagnetics, and you know, as I think the specs on these surveys are, you know, the planes flying 30 metres above the ground on 50 metre to 100 metre flight line. So it's fairly coarse. It's the best you can do back then. And all of the known deposits that are magnetite hosted, you can see they're magnetic anomalies, obviously. So they're magnetite, iron oxide, copper gold deposits. So what we're saying from that previous graph is that these have been drilled and tested and found and discovered, all associated with magnetite. What Emmerson have done is applied some new detection technologies, and one of these is the drone magnetics. This drone is flying at 15 metres above the ground on 15 metre space lines. So it's incredibly detailed. It's much, much more detailed, and it's able to pick up the subtle magnetic anomalies. So the subtle magnetic anomalies are those that have got a lot of hematite. And you can see over here, this is our Mauritania discovery. So the Mauritania mag anomaly is the yellow blob with the wireframe and drill holes in the background. And if you look at the photomicrograph, it's a thin section of the gold. You can see the gold associated with hematite. So the gold event and the copper event are being introduced during the oxidized phase of the Tennant Creek suite, converting what was a magnetite iron oxide deposit to a hematite one. So the reasoning then goes that the more of these oxidized fluids in the system, the potentially the higher grades there will be. And I think that's been, that's what we're seeing is that that's actually the case at Hermitage, at Mauritania. If you look at Mauritania discovery, it was a greenfields discovery, undercover, under 30 metres of sand cover, some absolute cracker grades there, 22 metres at 36 grams per tonne, 6 metres at 122. It's all in the oxide zone. It was based on structure, magnetics, geology, geochemistry, using the drone. And cross section through it, you can see it's got an oxide zone at the top, which is a really high grade gold zone. And then we drilled a hole last year through the oxide zone, through the primary magnetite zone into the hematite zone down in the footwall, and got 4 metres at 57 grams gold. And that's the primary zone. So now we've got to drill out the primary zone. So sitting underneath that oxide zone, there's a primary zone which we don't really know too much about. Just turning to a few other detection technologies that have been successful. We were the first company that applied EM, airborne EM, through Helitem. And what we first did was we looked at the historic drill core. A lot of these deposits have a reasonable amount of copper with them, so we worked out the conductivity of the drill core, and it's 30 to 70 times above background for those copper-rich deposits. So we thought, okay, based on the drill core, then that should respond to airborne EM. So that's why we flew the Helitem survey. This graph shows you the top one is the magnetic map, and the black is the underground workings. And you can see that from the magnetic map, the magnetite ironstones show up really well. So magnetics picks up the magnetic ironstones. Where the yellow circle is Goanna. There wasn't one single drill hole. So back in the day when they did this underground development and drilling, the geologists were very dogmatic. Only mineralisation occurs with magnetic. So once you're out of the magnetic anomaly, forget it. There's nothing more. So what we did was we flew Helitem, exactly the same scale, the next map down, and see where the Goanna circle is, a very, very strong EM response. That EM response turned out to be an absolute cracker copper gold discovery in hematite. So the EM was responding to the copper veins. So it just goes to again illustrate the power of thinking a little bit outside the box. Don't be dogmatic. So I think, the conclusions I draw from our time in Tennant Creek, you've got to know your geology and your mineral system. You've got to know that. And the geologists that are at the coalface are the best ones to know that. You've got to be able to interpret what your rocks are saying to you and what your mineralisation is saying to you. And you tailor your prediction and detection based on that mineral system. And also, I think, scale your land holding to your prediction capability. It's the MH370 issue. If you're unsure of your prediction, you're going to have to take up large land holdings to cover all of the possible scenarios. If you've got really nice and really tight prediction capability, then obviously you don't need to hold as much ground. And I think, you know, I quite often look at a lot of junior mining companies. They pick up postage stamp type projects, and you know what you're doing there is gambling on that the deposit is going to be within your postage stamp. So you know, I think you know, not too many of us win when you gamble. Detection technologies, their effectiveness diminishes over time as you drill them. So you need to think about variations on the theme of the mineral system and deposit. So the variation in Tennant Creek was, you know, the association of the gold with the copper. So let's try airborne EM or to see whether we can pick up the signature of the copper in the IOCG. And then, of course, drone magnetics came along, and it's kind of reactivated the search space once again, because we can now look at the very subtle mag anomalies, which are mostly hematite. But I think the overriding comment is it's unlikely that there'll be a single effective technology. So you need to think very carefully about your mineral systems and your deposits, and be prepared to try different ones. And you need to know the limits of those detection technologies and keep abreast of improvements. At the end of the day, it's systematic, science-based exploration. It's hard work, it's a slog, it's hard to keep your board engaged, your shareholders engaged. But what I would say is that that is the best way for discovery, to make a discovery. It's systematic and science-based. You need to include support from applied research from universities. I think we've sponsored 3 or 4 PhD and master's students. We've got research projects going on with the University of Tasmania and the Centre of Exploration Targeting down here at UWA. So we've harnessed some cutting edge research on these sorts of deposits. And I would say that it's geological intelligence, not artificial intelligence, that is going to make the discovery. The guys at the coalface are the best ones to make that discovery. And you need to obviously match your technical strategy with commercial. And, you know, look, that's a whole different discussion. In Tennant Creek, we've managed to open up some new search space through having commercial agreements with the traditional owners, where we're able to access areas that have previously been locked away. But that's a whole a discussion for another day. So look, I'd just like to leave it there, and I'd really like to acknowledge the exploration team that we used to have back in our Indonesian days. We had some of the best geologists ever in the business back then. Also the geologists in the Tennant Creek mineral field we've got today. And I thank you, Puck, for the opportunity to talk about some of these you know, things we're doing here in Tennant Creek.
Thank you very much, Pak Rob. That was really inspiring presentation, Pak. It is truly lesson for all of us that systematic science-based exploration is very important for discovery and, of course, to maintain the sustainability of the existing mine. And surely strong support from top management and stakeholders are also very important, because it will involving cost, risk, and time. So now, if anyone have any question for Pak Rob, please raise your hand and turn on your camera, or just write down in the chat room. Okay, first question from Pak Budi Santoso. Please, Pak Budi.
Thank you, Pak Bowo. Selamat pagi.
Selamat pagi, Pak.
You look great. Thank you very much for making your time. And ladies and gentlemen, I just a bit emotional here, because Pak Rob is one of my mentor back then. Thank you very much for supporting us as young Indonesian geologist back then, Pak Rob, and also for supporting the MGEI to present such a great and comprehensive presentation, especially the philosophy of exploration. I think this is something that been missed by lots of company. It's not just the major company, but also juniors company. Pak Rob, you mentioned that all of the method that you have done, techniques and so on, strategy and so on, you've been lucky probably because you are in the area where you have lots of data, not necessarily exposures, because some of your discovery are undercover. I would like to know, say, if you're back in Indonesia, will you be able to make discoveries, more than two discoveries in the area that you're working at the moment in Indonesia, and the terrain that it is very challenging. It's not just the terrain, but also the availability of the data. And I like when you said GI, it is not AI. I think maybe some of the participants will a little bit not disappointed, but they think that AI is going to take over the GI. I'm still with you about that, the GI versus AI. Okay, but that's the second one was just a comment, but yes, what about if you're back to Indonesia and you have to make a discovery? Would you be doing something that you are doing at the moment at the same level of optimistic as what you have at the moment, Rob? Thank you very much.
Thank you, Pak Budi. Look, it's a great honour to present to MGEI and to the Indonesian participants in this conference. Look, Pak, I think the principles are exactly the same. It's getting the prediction and the detection right and doing it at the right scale. And it's not glamorous, it's just persistence and systematic exploration over time. And building a good team. I think they're the key ingredients in my mind. And if I was doing this in Indonesia, I fully support what Steve Garwin was talking about. That's the sort of thing that you have to do. But you have to bring everyone else along with you, Puck. You have to bring your board, you have to bring your landowners, you have to bring everyone along on the journey, because it's going to probably be a long journey. So unless you get very lucky early on, and luck's not a good strategy. So I think you have to plan for a 5-year campaign of systematic, science-based exploration. You tap into the universities and the academics to get the best possible information on what the deposit type you're exploring for is, the best science and technology that you can possibly get in your company, and you apply that in a systematic manner. And I think I would not be deterred, Puck, if the areas that you're targeting already have a deposit, because I know a lot of people think, oh, it's already been found. Let's not worry about that. Let's go somewhere else. What we've showed in Indonesia is, providing you've got a large land holding and your prediction technology is telling you you're still within that prediction corridor, that fertile corridor, you need to persevere. There will be many more deposits there. You just need to persevere. So that'll be my approach. I would be going to Indonesia, setting myself up with a great team of Indonesian geologists like yourself, and bringing everyone along on the journey and applying the best possible science in a very systematic manner.
Thank you, Pak Rob and Pak Putih. Any more questions, Pak Putih? I think you're still muted.
Okay. Yes. Thank you. Thank you very much, Pak Arab. I think these days Indonesia has opened, especially the government has already provided the new mining laws that will allow new companies or companies to apply a new greenfields ground in the area that probably before people never thought about a level of fertility of the area for a certain type of deposits. But as you said as well, that even the area that's already well known, just some people describe as brownfields area, you still have lots of opportunity to find more in that area. And in our company also approved that concept or thought. So I do really appreciate what you have confirmed about some of us in Indonesia, in my generation and the younger generation, of course, these days, to be very and always optimistic. Especially nowadays, the MGEI is trying to put the geoscience for discovery more. So in the future, we will have more collaborations with the universities, with high caliber consultants like Pak Steve Garwin and Amanda and also others. And we do hope that we could probably have you to get some more special session, especially to elaborate on what you have just presented to us, because we only have about 30 minutes time, and we do hope that we will have more time to elaborate those interesting and very inspiring points by Rob. Thank you. Thank you very much indeed.
Thank you. Thank you. And look, as I said, GEI is what I strongly back. Geological intelligence. I'm 200% behind you, Budi. That's where we need to go.
All right. Thank you, Pak Budi and Pak Rob. The second question is from Dr. Lukas Doni from the University of Gajah Mada, Yogyakarta. Please, Pak Lukas. Pak Lukas, are you there?
Unmute mine.
Yeah, good.
Okay. Good morning. Okay. Pak Rob, I'm Lucas from UGM. I'm very interested with the histogram of discovered deposit to be used for predicting, and you show a success story. And you mentioned regarding the Grasberg iceberg that will be at the top, and that probably becoming a kind of big problem in Indonesia, because we consider there are so many prospects to discover the next Grasberg iceberg. But then in that case probably becoming the problem that where are the others. So could you explain more elaborately on the use of the histogram of the distribution histogram to predict the undiscovered prospect or future discovery with regard with the Papua Island? So, for example, what kind of discover, for example, prospect that we should include? So let's say that there are several different period of magmatic belt there, and probably different corridor. If let's say in Grasberg iceberg district, probably it is there is a kind of relationship with Wabu to the northwest. But how about further to the east? So let's say there are some prospect reported to be orogenic mineralization that probably not related genetically with porphyry and skarn mineralization. So I believe majority of us understand regional geology of grassberg iceberg. So could you give some explanation? Let's say we would like to use the model of histogram on discovered mineralization to predict the undiscovered one. Thank you, Pak Rob.
Pak Lucas, many thanks for a very insightful question. If you Google ZIF curve of natural population, that will provide hopefully some explanation. It's really a curve of natural populations, and what you need to do, exactly like you said, is make sure you're comparing apples with apples, that you're not bringing in populations that are not related. So Ertsberg, Grasberg, that whole arc in that particular age, that's the ZIP curve you want to generate. You can't include deposits outside of that age range and outside of that arc, because otherwise it won't make any sense at all. So it's predicting the endowment, the metal endowment of that particular arc. So you might have, Ertsberg, Grasberg up there, and look, back in my distant past, I'm trying to think of that, is it that Orabanda arc? I'm not sure if that's the name of it, but it goes through into PNG, into the Octetes, into some of those deposits in PNG as well. So it would include those if they're the same age and they're in the same arc. So that's the population that you need to consider.
Okay, thank you. Thank you, Pak Lucas and Pak Rob. And one last question, Pak Gayo, please. Your mic still muted.
Yeah, thank you. My name is Gayo from Tujuh Bukit project in Southeast Java. Actually, I have the same interest with Pak Lucas Doni from the curve that combining the resource and also the curve that you have just mentioned to predict some resource that undiscovered. I'm just telling you that I am working on the tenement, which the area is about 10,000 hectares, and we are now having 5 or 6 deposits in scale of 1,000 until 1 or 2 million ounces of gold with the epithermal high sulfidation type. And then down below we have 1.9 billion ton of porphyry that when we plot into that curve, so that actually in Tujuh Bukit prospect we have already found the biggest deposit that may be in place in this district. So what I need to ask you is when do I have to say that yes, this is the biggest deposit in this district? So I just need to fill the blank between the 1.9 billion ton to the 100 million ton that in the mid among the two deposits, it is still big gap between 1.9 billion to 100 million ton. So when do I have to say that? So, but is there any possibility that we will have another 1.9 or maybe more to 2 billion ton within the district is just using that curve. I think that's all. I hope you understand what I'm questioning you. Thank you.
Yeah, Paco, great question and congratulations. It sounds like you're working on a fabulous project. So keep on doing what you're doing. Don't worry about the ZIF curve, just keep on doing it. The ZIF curve is really meant to be just an early indicator of the endowment. So you can't really use it once you've made a discovery in a district. It doesn't really help you at that scale. It helps you at the scale of the arc. So I wouldn't worry too much about trying to plot. If I interpreted the question correctly, those two bucket discoveries are within the same district. So they'll all go together as a global resource, and that'll be, by the sounds of it, the biggest world-class discovery on that curve. So it doesn't really work to plot them down along the axis of the curve. It will be other such deposits within other districts within that arc, if you see what I mean. I hope that answers your question.
Yeah, but thank you, but that's answer much. Don't worry about the S curve, yeah?
No, don't worry about it.
Okay, all right. Thank you, Pak Kayo, for the question, and Pak Rob for the great answers to all of the questions from the participants. And yeah, I would like to thank to Pak Rob for the lesson learned to all of us. It is a very valuable success story from Emmerson Resources that was shared to us. And I do believe that Emmerson Resources is very lucky to have you, Pak, a geological expert sitting on top of the management, which I think it is become one of the important factors behind this challenging, successful story in unlocking the geological code in Tennant Creek Mineral District. And of course, it must be supported by great geological and exploration team behind you. So congratulations, Pak, your hard work with multiple discoveries. And finally, give a big applause for Pak Rob Bills and for you all. Thank you. And now I would like to return the time to Mbak Rahma for memento and photo session.
Thank you very much, Bapak Bo Kusnanto, and also to Mr. Rob Bills for your presentation. And now it is the moment of appreciation, which will be given by Professor Mega, distinguished staff of MGEI. Could the operator please display Professor Mega, and thank you very much. If Professor Mega could please turn on your camera. Thank you. Okay, I will count from 3. 3, 2, 1. Thank you very much. And now we would like to take a group photo with Mr. Rob Bills. All right, we'll take another photo. 3, 2, 1. Okay, thank you very much. And up next, we will take a group photo with Professor Mega, Mr. Rob Bills, and also Bapak Bo. Okay, can everyone please look to the camera again? 3, 2, 1. Okay, thank you very much. And now I will give the session back to Bapak Bo Kusnanto to open the third session. To Bapak Bo, the time is yours.
Thank you, Mbak Rahma. We are going to the next presenter again, the last presenter in the session. Mbak Kiki Siagian, who going to present an interesting topic. of how machine learning increase productivity in mining using geological data. Mbak Kiki is geologist, mine geologist, working in PT Aman Mineral Nusa Tenggara, and she was graduated from ITB Bandung. With his recent publication is a classification of the penetration rate of blast hole drills using geological data, a case study of applied random forest algorithm in batu hijau mining West Sumbawa. Okay, Mbak Kiki, the time is now yours.
Is it clear? Check. Is it clear, Pak?
Yeah, it's good.
Okay. Let me share my presentation. Okay. Yeah. Good morning, everybody. Welcome to my presentation. I will say thank you to Pak Bo has introduced me as a speaker today. And thank you for MGEI for having me in the annual convention 2021. Before I start my presentation, I will talk about the inspiration of our study. It is from the quotes that say, the best plan have done half of the plan. So this is the reason. So today I want to talk about the machine learning application in the mining industry. With specific topic is classification of penetration rate of blast hole drills using geological data, a case study of applied random forest algorithm in batu hijau mining West Sumbawa. Okay, I have 4 focus in this presentation. We'll begin with introduction. We'll elaborate about the study area background and the machine learning concept. And the second topic is data and methods. Third is result and discussion. And finally, by the conclusion. So let's get started. I want to begin with the study area, Batu Hijau Mine. It is located in the southern part, Sumbawa, West Nusa Tenggara, one of the world-class porphyry deposit, produce gold and copper that owned by PT Aman Mineral Nusa Tenggara. In geological view, Sumbawa lies in tectonically active Sunda Banda magmatic arc with trend east-west, and also convergent 3 major tectonic plates. These are Indian Australian, Eurasian, and Pacific plates. Okay, our study will conduct in the production area. These are general geological conditions. They have 4 units rock type, which consists of volcanic, diorite, intermediate tonalite, young tonalite, and young tonalite. The intrusion occurs relative to the center of the pit. For attraction, consists of full-grain mica, secondary biotite, and chloroapidite. For information in Batu Hijau, there is a major fault with the trend northwest-southeast. This figure shows us the drilling blast hole activity in the production Batu Hijau mine. Drills are operated to make holes for space blast materials. In the process of drill, rock drillability or penetration rate is one of very important in the main planning and scheduling. And penetration itself depends on the ground condition, rock properties, geological condition, and operational variables like condition the bits and operators of factor of human. And this penetration rate that we will address in this study. Okay, let's now turn to the machine learning. Machine learning is the one famous term nowadays, very powerful. Many companies, from tech company to traditional company, has using this tool for improving their business. And this study, we are using the random forest, one of the supervised machine learning. And the concept of the random forest shown by this graph. It is built by the multiple trees, called as a forest. And the random words means there is an algorithm doing some random sampling from dataset to build the tree. And the random forest itself has advantages like good classifier, robust to outlier, faster in computation, and can show the important variables for prediction. Like in the nature, we see the tree has component, root, leaf, and branch. Random forest has similar too. This component we call as architecture of learning. Okay, this is one essential how to know the concept of random forest works. Will be summed up in the 3 general steps. The first is bootstrapping. It's like the random sampling from data set. And then after the random sampling, there is a feature selection to determine what features or variables would be as a leaf or not. Like this figure, after the result in the each tree, there is the voting, and the majority result will be the final decision of random forest. Okay. Now to the second main points, data and methods. We are using 7 variables in the study, 6 experimental variables, and 1 is a target variable. This table is distribution of our data. And because our study is to classify the penetration rate, we categorize the penetration class to three classes. There is a low, medium, and high. These classes will be the target variable in this learning. And then we did to understand how data, we try to plot the matrix correlation. From this matrix correlation, we see the all features or all parameters have negative relationship to penetration rate. For information, if we are doing some geological analysis, is often use the spatial data. But in this analysis, we eliminate distinct noting and elevation to prevent the spatial autocorrelation and to prevent the performance model to predict the result. Okay. And the process of machine learning will be recapped in this flowchart. And I make some parable how to build the machine learning is like to make some food or cook the food. There is collecting materials or ingredients, and then we cleaning or raw materials, and after already we process or cooking. And as I mentioned the previous slide, after we collect the data set, we are cleaning the data. It is remove the outlier, taken down the nonsense data, and after it, we divided the data to 2 categories. There is the data sets and training data. In the study, we check again the training data. We found there is imbalance in the target variables. The high penetration rate more dominantly than other class. So we do some resampling to balancing it. Why we do the some rebalancing data? It is aims to prevent the overlearning in one class. And then before we model or training the data, we are validate the random forest to make sure how good the random forest works with the keyword cross validation. After the process, we got the idea, oh, random forest is a good tool to classify. And after the model has built, there is the last stage. It is called evaluation. We evaluate the model we has built, and then with the test data. From this process, we got the accuracy. Number of correct prediction divided by total prediction. Okay, this is all the concept or how to build the machine learning. And for information, the whole process we doing by you are using the application Anaconda with Python programming language and such of libraries like scikit-learn. Next, we jump to the result and discussion. And I mention again, our goal is to classify the penetration rate class into 3 classes. And we will obtain and derive the architecture of learning, and these tables, the very optimal to do some prediction. This is the architecture, and the model that we have built, we obtain the accuracy 74%. It means if there is 100 prediction, 74 correct. Okay. In my opinion, is a good model, I think, because there's an uncertainty variables like operational and ground uncertainty. And then from the model, we got the byproduct of random forest classifier. It's shown by this graph. We got the idea that RKD is the biggest factor to predict or to determine penetration rate class. And the rock type is insignificant variables for prediction. Okay. To understand what happens behind the random forest learning, we are using Lime library to show us how the prediction probability and the weighting each feature for prediction. We pick one data randomly to test, and we got the result. The prediction is high penetration rate, and then we looking into the central plot in here. This is the plot that inform us how behind the learning, and the bar in here 0.05 is the weighting features, and then we see the top feature is Archidae. And then if we quick calculate the low or right side is lighter. Okay, the left side of the central plot is more weighted than the right side, so the learning predict to class of high penetration. Okay, from this plot we got the explainability how the random forest predict the penetration class. And then is the next slide. We try to plot 2 elevation as a representation of model prediction. These plots are significant pieces of evidence supporting the performance of model. We can see the actual and prediction in elevation 240. Generally, the both plot has similar in pattern. The low to medium penetration rate occurs in the southwest and the northeast, and perpendicular to the high penetration rate. The high penetration rate, it is the engineer or drill blast likes, because the higher penetration rate, the quicker make holes. In the beginning, I have spoke. There is a major fault in Batu Hijau, and it is parallel to the trend of high penetration rate, northwest, southeast.
Mbak Kiki, you have 5 minutes left.
Okay, but thank you, Bawo. And the second figure, deeper than 240 minus 45. From this figure, we see the high penetration rate is dominant, and this elevation is closer to the center of pit and intrusion. So I'll try to make some interpretation, because geologists very like interpretation. If we found the fault zone or intrusion zone in the field, we commonly found more occurrence of the fracture. This leads to the lower strength of the rock, or especially Archidae. In my opinion, these features or RKDPL IWIBM has reflected the geological condition, and the random forest can capture it. So I think this is the powerful tool. In addition, I make some box plots. The box plot will summarize range value of top few important features. From the prediction, low penetration rate consistently have higher in average than other classes, in contrast to high penetration rate have lowest in average. So from the learning, we got the idea. High strength will be result low penetration rate, and vice versa. So for this learning, we can equip the engineer to understand the subsurface prior in planning and budgeting using the geological data that we have. And then we arrive in the conclusion. And to summarize, there are 5 points. The first is the random forest algorithm using geological block model data has significant ability to predict the rock reliability classification, and we obtain 70 for accuracy. And the top 4 important features for prediction are RKD, PLI, WIBM, and bulk density. The output of application machine learning random forest classifier provide information for geologists, engineers to understand the complexity of the subsurface or deposit, and can increase the mine productivities, particularly in real equipment planning and scheduling. And for improvement, further research will be conducted by applying tuning machine learning algorithm and collecting other rock hardness variable to generate a better prediction. So that is all for my side. Thank you for attention. I will back to Pak Bowo again.
Thank you, Mbak Kiki. This is quite interesting. The machine learning that used by you, especially in Aman, Nusa Tenggara, in Batu Hijau. And as we all know, that machine learning has now been used in wide range of industry, and of course, mining has also been starting using it. Now, for the participants, if you have a question for Mbak Kiki, please raise your hand and turn on your camera, or write down in the chat room. Okay, Mbak Kiki, while waiting for the question from the participants, I have one question. After following your presentation, I saw that the most important variables for the prediction is RQD and then rock type, but you haven't mentioned about the alteration. You know that alterations such as silicification may have strong and compact rock type, which may be going to have what influence to the penetration rates. So is that the kind of the important thing to be used in the factors, in the variables, or you think it is not really important for that?
Yeah. So in the slide from the graph, the top four variables for prediction is RKD, PLI, YBN, and bulk density. That is all the rock properties or physical properties. So I think the process alteration will be reflected in the the physical properties, but such as like if we have the high the alteration from massive rock to clay will be reflected in the RKD. RKD will be low, and I think in some of the all process can capture it by the rock physical properties.
All right. Any question from participants? Please raise your hand.
Pak Bowo, I can raise my hand. Hi Ki.
Hello.
It's been a
Go
while.
ahead. Would you please introduce yourself?
Yeah.
Oh, Mbak Wulan.
Mas Bowo, I have a question for Kiki. This is very interesting study. I want to ask how to select the sample, because you said that you were using the RKD, the workbook index, and then the bulk density. I mean, how to compile it and then how to select all the sample and combine of all those parameters. Thank you.
Okay. So we are collecting data from the geological block model, and then the penetration rate has such as the easting northing, and will be generate from extract for the block model, because the like RKD PLI is like the spot sample, right? But the modeling teams have modeled the RKD PLIW VBM to area of pit. That is our source of data.
So you were using all of the data and not just, I mean, like you just using the models and then compare to for the study, something like that, right?
Oh, you have the geological model like RKD PLIW VBM, the cover the pit, and then we got the actual penetration rate from 12 engineer, and the data has elevation, northing, easting, and then we try to plot to the model, and that is intersection, right? And between the penetration rate with the block model, there is the source of our data.
Okay.
Thank you.
Thank you, Ki.
Yep.
Okay, thank you, Mbak Bulan, for your question. And now there is another question from Bapak Witoto Markotomo. I knew him very well. He used to be worked in PT Freeport Indonesia for both geology and operation, and the last position, I think he worked in the drill and blast in the operation side. So please, Pak Witoto.
Thank you, Mas Bowo. Can you hear me?
Yes, very clear, Pak.
Okay, Mbak Kiki, I think it's good presentation. Just I was on several slides. Would you mind describing the relationship between the raw data of the penetration rates and the RQD? And then is there any good correlation between the geological profile and the penetration rate value directly in the pit, if you like?
It's been like how the relationship the RKD to penetration rate.
Yeah. So when you're comparing the data between RQD and penetration rates, is there any good correlation between for example, you have hard rock and soft rock or medium rock, reflect by the penetration rate and RQD.
Okay, thank you, Pak Bowo. I would like to directly answer the question. Wait. Okay. Lime library such of powerful library to show us how behind the learning. The Lime library show us that I show in the slide. The RQD, we just want plot the data. We just want plot the data in the class of high penetration. From the Lime library show us the weighting features, the central plot, the RQD with range 29 to 553 will be a tendency to predict not low penetration. It means maybe become a high penetration. So this is such a very clear example how the relationship between RQD with the penetration rate. How Pak Gatot ya?
Hello, Pak Witoto. Is that okay? The answer from Mbak Kiki. Okay, and now one last question because the time limitation. One last question from Mas Rivaldi. Hey, Mbak Kiki, just wondering if you did the comparison between the classification from field mapping versus machine learning versus actual penetration. Which one is better?
Okay.
Especially alteration and rock type that usually different from model from the exploration drill hole.
Okay, I will directly answer. I prefer the machine learning because it's such a powerful tool, can tailor the data and from the untidy data and give the insight. Maybe if we doing some mapping, there is a limitation. There is limitation, and because we just doing by our eye, and then apalagi, yeah. So I think I prefer the machine learning because it's very can capture or tailor data how each relationship between the all properties to the target. Yeah.
Okay, thank you, Mbak Kiki. This is a very, very good presentation, and I think this is going to be insight for all of us, which is majority here, I believe, are conventional geologists who don't really, tune with the recent technology like what you develop in Batu Hijau. However, I believe also that this machine learning is data-driven. And so the quality of the prediction is really depend on the data collected during from the exploration up to a mining stage, which is should be updated from time to time, as well as the geologists usually have different view to one rock. So just one single rock, it could be told by geologists in many different insights of it. So yeah, I think the data collection and the consistent of the saying ASA BSP for the whole team is very important. Thank you very much, Mbak Kiki, and
thank you for having me.
Now I would like to return back the time to Mbak Rahma for memento and photo session.
Thank you very much, Bapak Bowo Kusnanto, and also to Ibu Kiki Siagian for your presentation. And now it is the memento of appreciation and also photo session with our speaker and moderator, which will be given by Professor Mega Fatima, distinguished guest of MGEI. Okay, is everyone ready? Okay, I will count from 3. 3, 2, 1. Okay. All right, thank you very much, ladies. And now the second memento of appreciation will be given to Bapak Bowo Kusnanto as our moderator. Okay. Everyone ready? 3, 2, 1. Okay, thank you very much. And now we would like to take a group photo with Ibu Kiki Siagian, Bapak Bowo Kusnanto, and also with Professor Mega Fatima. Okay, everyone ready? All right, 3, 2, 1. All right, thank you very much to Ibu Kiki Siagian, Bapak Bowo Kusnanto, and also Professor Mega Fatima. And now everyone, before we go on a break, we would like to take a group photo with all of our participants. So could everyone please turn on their cameras? Don't forget to smile, everyone, and please turn on your cameras. We would like to see everyone's faces here. Okay, there are several slides as usual, so we will take several photos. Okay, for the first slide, 3, 2, 1. Okay, great. The next slide, 3, 2. Oh, we see someone still turning on their cameras. Okay, can everyone give me a thumbs up if they're ready? Okay, I'll count from 3. Oh, there are someone still turning on their cameras. We'll have to wait. It's okay, everyone. No need to be shy. Okay. All right, we'll take the photo now. 3, 2. Okay. 3, 2, 1. Okay, the next slide. Okay, we will wait for everyone until they've turned on their cameras. Okay. Next slide. Okay, everyone, then. We'll continue to the next session, which is the break time. And before we go on a break, we then again would like to thank our sponsors and media partners for supporting this event. Starting from our super bright sponsors, we have PT Geofix Indonesia, PT Merdeka Copper Gold Tbk, and PT Petrosi Tbk. Our gigabyte sponsor, we have PT Antam Tbk. Our megabyte sponsors, PT Agincourt Resources, PT Aman Mineral Nusa Tenggara, PT J Resources Nusantara, PT Namsuma Luban Abadi Sumacorp, PT Reka Buana Penjuru Mineral, PT Sumbawa Timur Mining. And our kilobyte sponsors, we have PT Eksplorasi Nusa Jaya, E Minerba Indonesia, PT Greenland Resources, Harita Nickel, PT Indodrill Indonesia, PT Nusa Halmahera Minerals, and PT Timah Tbk. Our workshop sponsor, we have Sequent Limited. Our other sponsors, we have PT Medco Energy Mining International and PT Minevesting Resources Indonesia. And of course, our media partner, Dunia Tambang. To our sponsors and media partner, we would like to sincerely thank you for making this event happen. And now, before we officially go on a break, we would like to invite all of our participants here to please check out our booth exhibition, which will include our sponsors, our media partners, and also student research posters, which you could check it out now. Then again, we thank again our sponsors and media partner, and also our speakers, moderators, and of course, everyone else here. Ladies and gentlemen, we'll continue to the next session in a few minutes, so stay tuned. Good morning and enjoy your break, everyone.
Sebagai ruang kehidupan, kian hari kian menurun kualitasnya akibat polusi udara. Penggunaan energi fosil dalam kendaraan bermotor menjadi salah satu penyumbang polutan terbesar. Saat ini, berbagai negara sedang berupaya untuk mengurangi dan mengganti kendaraan berbasis bahan bakar fosil menjadi kendaraan listrik yang lebih ramah lingkungan. Dan baterai sebagai sumber energi kendaraan listrik membutuhkan bahan baku dari alam berupa nikel dan kobalt. Di timur Indonesia, tepatnya di Pulau Obi, Kabupaten Halmahera Selatan, Provinsi Maluku Utara, PT Halmahera Persada Legend yang dimiliki Harita Nikel dan Emmerson Resources hadir sebagai solusi dengan memproduksi bahan baku baterai kendaraan listrik. Di Indonesia, Halmahera Persada Legend menjadi pionir dalam pengolahan nikel kadar rendah yang selama ini belum pernah diolah. Penerapan teknologi high pressure acid leach menjadi pilihan tepat karena lebih ramah lingkungan dengan konsumsi energi dan tingkat emisi lebih rendah. Dengan proses hidrometalurgi, nikel kadar rendah diolah menjadi mixed hydroxide precipitate. Selanjutnya, produk tersebut akan diolah lebih lanjut dan menghasilkan nikel sulfat dan kobalt sulfat sebagai bahan baku utama baterai kendaraan listrik. Proses pengolahan dan pemurnian nikel dimulai dengan proses penggilingan dan pencucian biji untuk memperoleh aglomerasi biji yang berbentuk lumpur. Kemudian biji diumpan menuju autoclave. Di autoclave dilakukan pelarutan dengan asam melalui tekanan dan suhu tinggi. Setelah itu, slurry dilarikan ke dalam tangki counter current decantation atau CCD. Di sini, material sisa selain nikel dan kobalt dipisahkan dengan mengendapkannya secara bertahap. Campuran nikel dan kobalt yang lebih murni diendapkan dalam bentuk campuran padatan mixed hydroxide precipitate atau MHP. MHP merupakan produk antara dengan kapasitas produksi 365.000 metrik ton per tahun. MHP kemudian dilanjutkan dengan proses pemisahan dan pemurnian yang menghasilkan dua produk akhir, yaitu nikel sulfat sebanyak 247.000 metrik ton per tahun dan kobalt sulfat 32.000 metrik ton per tahun. Seluruh proses pengolahan dan pemurnian biji nikel kadar rendah dilakukan dengan mengutamakan kesehatan dan keselamatan kerja sebagai landasan utama operasional, serta komitmen tinggi terhadap perlindungan lingkungan berdasarkan peraturan dan undang-undang yang ditetapkan oleh pemerintah. Tak kalah penting, pengolahan nikel kadar rendah merupakan wujud komitmen perusahaan dalam mendukung program pemerintah melalui konservasi mineral serta mampu menciptakan tenaga kerja bagi anak bangsa dan terjadinya alih ilmu pengetahuan dan teknologi. Industri pionir ini ikut mendorong terwujudnya program pemerintah dalam percepatan program kendaraan bermotor listrik berbasis baterai. Dari OBI untuk Langit Biru Indonesia.
PT Nusa Halmahera Minerals adalah usaha bersama antara PT Indotan Halmahera Bangkit dan PT Aneka Tambang Tbk yang mengelola tambang emas Gosowong di Kabupaten Halmahera Utara, Provinsi Maluku Utara. Saat ini, perusahaan mengelola dua tambang bawah tanah aktif, yaitu Tambang Kencana dan Toguraci, yang memiliki produktivitas dan potensi cadangan yang tinggi. Sementara itu, eksplorasi juga terus dilakukan secara agresif untuk terus menambah usia produktif tambang. Keselamatan kerja, serta kepedulian sosial dan tanggung jawab lingkungan selalu menjadi prioritas dalam semua kegiatan perusahaan. PT Nusa Halmahera Minerals menjadi salah satu industri penyerap tenaga kerja terbesar di Halmahera Utara. Kegiatan operasional perusahaan telah menjadi kesempatan bagi sumber daya manusia setempat untuk mengembangkan keahlian dalam bersaing secara global. Selain menambang secara profesional, kontribusi perusahaan untuk masyarakat lingkar tambang juga dilakukan dengan langsung menyentuh kebutuhan masyarakat yang sebenarnya. Di mana selain program pengembangan dan pemberdayaan masyarakat, perusahaan juga melakukan berbagai program tambahan sukarela lainnya. Seperti program bedah rumah, akses layanan kesehatan yang nyata, dan bantuan khusus untuk kaum duafa, anak yatim, dan lanjut usia. Menambang dengan hati. Itulah semangat yang diusung oleh PT Nusa Halmahera Minerals di Tambang Emas Gosowong, Halmahera Utara.
Welcome back, everyone, from the break. And now we would like to move to the second session. But first, we would like to make a quick announcement that there will be a presentation from the Student Research Poster Competition. So make sure to stay tuned. And now on to the second session. This theme session is Critical Raw Materials for Green Energy, a Technical Approach. This session will have two speakers. The first speaker is Bapak Imam Purwadi of University of Queensland, who will be speaking of reflectance spectroscopy and geochemical analysis of rare earth element-bearing tailings, a case study of 2 abandoned tin mine sites in Bangka Island, Indonesia. Our second speaker, Dr. Iwan Setiawan of Indonesian Institute of Science, who will be speaking of weathered crust at North Sumatra, Indonesia. This session will have a moderator, Ibu Wulandari Mandradewi of Archi, Indonesia. But first, let me introduce Ibu Wulandari Mandradewi's CV. Ibu Wulandari previously earned her geological engineering degree from Bandung Institute of Technology. Her work experiences are exploration superintendent, Martabe Gold Mine and PT Agincourt Resources. She was also a project geologist of Martabe Gold Mine, PT Agincourt Resources, and currently she is a project generation geologist of Archi, Indonesia. She also previously worked as the exploration geologist at Poboya Project, PT Citra Palu Minerals, Tujuh Bukit Project, and PT Indo Multiniaga and Totopo and Du Project, PT Avoset Mining Services. Her professional backgrounds include 12 plus years experience in mineral exploration and spectral geologist for epithermal and porphyry deposits. And she is also a competent person in Indonesia, or CPI, for gold, silver, epithermal exploration report. She has several publications, which are Mandradewi, Wulandari, Khadijah, Siti, Hetriana, Janjan, Hidayat, Andrite, and Wearer Victor, with the title Application of Spectral Analysis in Alteration Mapping in Martabe Areas, North Sumatra, Indonesia, in the Sunda Land Resources 2004, Palembang. And also her second publication is by Herdianita, Rina, and Mandradewi Wulandari, published 2010 with the title Evolution of Cisolok Cisukarame Geothermal System, West Java, Indonesia, based on its surface manifestation in the conference proceedings of World Geothermal Congress 2010, Bali. To Ibu Wulandari, you may now open this session. Good morning, Ibu Wulandari. How are you today?
Morning, I'm doing well, thank you. Thank you to introduce me. So I will take this as my time now. Okay.
Yes.
Good morning, everyone. I'm welcoming to everyone who just joined in this session. So I would like to say thank you also to MGEI to invite me to become a moderator in this session. So in this session, we're going to talk about the critical raw material for green energy, a technical approach. So this is will be very interesting, and we have two speakers. the first speaker is Pak Imam Purwadi, and then the second speaker is Pak Iwan Setiawan. So maybe I will introduce our first speaker. So our first speaker is Pak Imam Purwadi. He's gonna talk about the reflectance reflectance spectroscopy and geochemical analysis of rare earth element bearing tailing, a case study of two abandoned tin mine sites in Bangka Island, Indonesia. And here is his CV. So his education background, he is a Bachelor Engineering in Mining Engineering from University of Sriwijaya. He is graduated in 2015, and then he continued his study in Geoinformation Science and Earth Observation with specialization in Geological Remote Sensing, University of Twente, the Netherlands, and graduated in March 2018. And after that, and currently he is a PhD candidate in Sustainable Mineral Institute, the University of Queensland, Australia. So, and expected graduation in 2022. And some work experience of Pak Imam Purwadi. He has been work for the program committee Geoinformation Science and Earth Observation of the University of Twente in Netherlands from January 2017 to 2018. And then after that, he's working as a GIS and remote sensing specialist for Purwabara Consultant, Indonesia, from March 2019 until now. So, and then he currently PhD candidate, University of Queensland, and his research focus on evaluating multimodal spectroscopies for detecting metals in plants from using the X-ray fluorescence technique for scanning herbarium to the visible to near-infrared reflectance spectroscopy. So the project is focused on rare earth elements from July 2019 to until now, and he also co-founder and CTO of from the Envirometric Software in Brisbane, Australia. Maybe Pak Imam, I would like you to start your presentation. Time is yours, Pak.
Can you hear me okay?
Yeah, all good.
Okay. First of all, hi everyone. Thank you for joining my session, and I'd like to thank the committee who invite me to this great event, and Ibu Wulandari who has introduced me. And okay, let's begin this presentation with revisiting this sub-theme of the session: critical raw material for green energy, a technical approach. So some of you might wonder what critical raw material is. So if you look at here, this is from European Union. Classify a material whether they are critical or not is based on their economic importance and supply risk. As you can see here, every element with economic importance more than 2.75 and supply risk more than 1 is considered as critical raw material. And RE happen to be here with very high supply risk. And Australia also put RE on the first list as a critical high in raw material. So far we talked about RE, but actually what REs are. If you look at this periodic table, RE refers to these lanthanide groups, ranging from lanthanum, cerium, polonium to lutetium. And some researchers or some people might include scandium and yttrium due to their chemical and physical properties. Then again, why they are important? Again, this is taken from European Union website. As we can see here, RE are considered in the highest supply risk, but they are also use wide range technology ranging from fuel cell to drone and even your phone. Then, why RE are in high demand? As we know, human population keep increasing, and predicted to 9.7 billion in 2050, and it is believed to be one of factors behind the rising global temperature. As a result, Paris Agreement was signed aiming to limit the global temperature just below 2 degrees Celsius this century. And to achieve this target, there's a need to transform the way we produce energy from non-renewable to renewable energy. As a result, the demand for required metal will increase up to 1,000% by 2015. Back to the subtitle. As explained by previous speaker, rare element is not rare, and here I'm going to talk a little bit about technology that can be used for finding rare elements. First is optical remote sensing. So imagine here's a sun in the morning, and there's a RE-rich deposit, and there's when sunlight illuminates the ground soil, some light will be absorbed and some will be reflected. And if there's a airborne with a sensor put on it and record the reflected light, and we display the reflected light in a graph, it will look like this. This is the red one is a airborne hypertext sensor, and in this vertical dust line, black here is neodymium absorption band. So neodymium is one of REs. So this is from my previous research. This is about reflection spectroscopy and geochemical analysis. It was done in Bangka Island, and as we can see here, the first top spectra, we call it, is from pure elements of RE, holmium, erbium, and xenotime is high RE rich mineral. And this is tiling sample from Bangka Island. This is quartz. And when we start this research, we are in doubt whether this research will successful or not, because so far at that time, it was quite hard to detect RE from satellite. So we start our research from lab analysis. We bring some samples from Bangka to the Netherlands and measure it with ISD spectroscopy. And we measure here, as you can see, there are different tilings with different concentration. And there's a clear absorption here in N and band. And if we look at this after processing some data, we look here that there's like a failure here. We call it absorptions, and it goes deeper and deeper as the RE concentration increase. So in short, in conclusion, we might be able to see it in the lab, but again, this is in the lab scale. Then the next step is we investigate whether this can be seen from satellite. Here several satellites that may be suitable for the study. And then here, so in the middle chart here, you can see this is correlation between the depth of absorption, this depth, and the RE concentrations. So this is on the lab scale, while here you can imagine that in the lab scale is almost perfect. There's no disturbance, but in reality, in between the soils and satellite, there's like 500 kilometers. There's a lot of things affected the result, especially about the effect of the weather. So imagine that several sensors have different signal to noise ratio. So we create a noise and add noise on the data, and from this curve, we can see that when the signal to noise is quite high, it doesn't really affect the the correlation value. But as the signal to noise ratio goes down, it becomes very bad. So as you can see here, the R value is almost to 0.2 or even 0 here. So based on the study, it was concluded that to be able to detect RE bearing features from satellite, we need a satellite with signal to ratio at least around or more than 100. And on the right side, you can see the images taken from satellite to MSE. And as you can see, what we expect or what we can see from these images is that the white color indicates area with high concentration of RE. Next, so in this slide, we are going to compare between hyperspectral sensor mounted on airborne and multispectral sensor mounted on satellite. So hyperspectral sensor has, of course, is better in terms of spatial resolution. You can imagine it has 5-meter spatial resolution, and the band is around 200 narrow continuous band, while satellite here it has 20 meters spatial resolution and only 8 band in near infrared. So if you look at this image, what you expect is that the white color here. The white color here indicate RE rich soils, and this is there's like diagonal line. It is due to sensor effect, so it is ignored. And this images from satellite. So if you compare both images, it's clear that the white color, we only focus on white color because white color in both images indicates high RE bearing material, and the white color distribution is quite similar. So we can say that satellite has similar performance to hyperspectral. So hyperspectral is quite expensive. It's almost $1 million, while multispectral sensor is free. So next, because it's free, can we upscale the method? So Indonesia is this, and this is Australia. I tried to map the whole South Australia, and this is the result. This will indicate area with high anomaly of RE, and then it was combined with radiometric gamma rays. It is about uranium, thorium, and potassium. And from this one, we can see that this is orange is the boundary where RE is detected, while this white color represent high gamma ray or radioactivity. So several spot here on the left image is detected to be mine, and this mine also reported to contain some RE and uranium, and this is the result to validate the previous result. So in remarks, to detect RE using satellite, it requires high signal to noise ratio, narrow and continuous spectral bands, and also high spatial resolutions. Limitation of remote sensing is that it has very high limit of detection. So based on the study, if you want to detect RE, the material should have at least 1000 ppm. And also, some, especially Indonesia, most of the time is covered by cloud, and area is covered by vegetation cover. And also, please bear in mind that remote sensing cannot penetrate, go deep into the soil. It's only very shallow, only few micron. The benefit of using remote sensing, again, it's easy to upscale, local to continental, as shown here, and data is abundant, and nowadays there are a lot of satellite, free or commercial, you can buy it, and it's time effective. So to process this image, it only takes like less than an hour, but it covers South Australia. It can scale to Australia, and well, it may be still less than 1 day. So it's quite easy. This is comparisons between so this is rock sample, contain a lot of cenotype and monazite, and was taken by using hyperspectral camera. And this is the result after reprocessing it. And this white color indicate RE bearing materials. And if we compare again, neodymium is like a proxy to detect RE bearing minerals. And when we compare with micro XRF, this is lanthanum, the red one is aligned with the white color from hyperspectral. So hyperspectral indicate RE bearing minerals, while XRF tell us the concentration, how much it is, and it's aligned here. And this is cerium. So if you look at here, this is lanthanum, bright red, while cerium is less bright because concentration of cerium mostly less than lanthanum. Next, this is future outlooks. as we know that Australia here is mostly bare, there's no vegetation cover, while in Indonesia, a lot of vegetation. Then my research question or my curiosity is that how can we find this deposit? So when I start this research, I was introduced by the term of hyperaccumulator. So hyperaccumulator is a plant that can take or accumulate very high concentration of metals. For example, there's like in this study area, New Caledonia, there's a plant that in their leaf it contain around 4% of nickel. So it's around 40,000 ppm of nickel on their leaf, and in the sap is contained like around 25% of nickel. So this is my study area, and we use airborne satellite, airborne hyperspectral data to map hyperaccumulator or plant that accumulating metals. And because of this pandemic, I cannot return to, I cannot go to New Caledonia to validate the research, so it's still on hold. So also, I'm aiming to have a study area in Indonesia, somewhere in Sulawesi, Bangka for rare earth, Sulawesi for nickel. That may happen in the near future or next year. So another approach to find RE for highly dense forests like Indonesia. This is an example from Queensland. So we measure herbarium. Herbarium is plants that was dried and kept in museum, and we measure them by using a portable XRF instrument. And unfortunately, for most of the instrument, they cannot directly report RE concentration in the leaf. So we create an algorithm and develop a pipeline to extract RE concentration from the raw data. And from this, we found that one species, this is Helicia australica, contain up to 2,300 ppm of RE. And when we plot the distribution, as you can see on the left side, they are accumulated in several spots that maybe it can be, it's not confirmed yet. We still go to the field and confirm whether this is a local hotspot for RE during deposit. So it can be used for regional exploration to limit the study area. So this is why, this is the reason why we start a study on herbarium SRF scanning. So exploration become harder, and mostly like gamma ray, magnetic, and also remote sensing cannot be used effectively in highly dense vegetation or new young sediments. So herbarium or hyperaccumulator could be a proxy, as shown before, and hyperaccumulator indicates metal soils because they are correlated. And mine contribute to 2.7 of global CO2 emission, and mining endangered plant species as happened in Madagascar. So hyperaccumulator also can be used for agro mining. It's a practice to to extract some valuable metal from tailings or low grade deposit, and also some hyperaccumulator become extinct, and we try to protect them if we found them. Thank you. That's all from me.
Thank you, Pak Imam Purwadi. Maybe for everyone, I forgot to tell you about, if you have a question, we're gonna open the Q&A session at the end of session after the second speaker give his presentation. So, but you can also just drop the question on the chat box, like Pak Lukas. But maybe Pak Lukas, Pak Imam Purwadi will be answered later after the second speaker. Okay.
Okay.
Thank you, Pak. That's a great talk.
Thank you.
Oke, Mbak Rahma. Kita lanjut. We going to the second speaker. Good afternoon, Pak Iwan Setiawan.
Good morning.
Okay, I would like to introduce you first, so our second speaker is Pak Doctor of Engineering Iwan Setiawan, Sarjana Teknik and Master of Teknik. His education background, he's graduated from Department of Geology, University of Pajajaran in 2001, and then he continued his study in Department of Geology of Institute Technology of Bandung, and then he continued in 2013 until 2016 in Geotechnology and Material Engineering for Resource Akita University of Japan, and he is doing the postdoctoral doctor researcher for collaborative studies at Institute of Earth Science Academia Sinica, Taiwan from 2018 to 2019. Currently, he is working as a senior researcher in National Research and Innovation Agency, and from 2003 until 2021, he is also working in Indonesian Institute of Science, or LIPI. So that's the background, and he's also have some recent publication about the molybdenum isotopic constraint from Java on slab input to subduction zone magmatism. And then after that, he have REE sequential extraction of weather crust of granitoid from Sibolga, Indonesia, and published in ISMCT 2021. And then geology vein texture and fluid inclusion of the Chibaber low sulfidation, low intermediate sulfidation epithermal gold and silver or field Western Java in IJOG 2021. Sorry, it's not clear. So that's the background of Pak Iwan Setiawan. Pak Iwan Setiawan, are you ready to give your presentation?
Yes, I'm ready, Bu Wulan.
Okay, please, Pak.
I will share my presentation. Okay, can you see my presentation?
Yes, we can see, Pak.
Okay, thank you, Mbak Wulan, for introducing me. First of all, I also want to thank MGEI and the committee for having me today. My today's talk will be mineralogical and geochemical signatures of potential ion adsorption type REE deposit in Indonesia. Why ion adsorption type? Because this is also produced by the granitoid weather crust, so it's still related with the topic of the committee requested to me. Okay, this is the outline of my presentation. I've divided into 4 chapters. The first is introduction, geology. The main topics will be on the chapter 3 and then conclusion. And then move to the first about the introduction. The rare earth elements, as you know, everyone well known about this. Pak Imam, thank you for introducing REE earlier. Rare earth element consists from lanthanum to lutetium, and also scandium and yttrium, according to Henderson. And REE is mainly divided into light rare earth and heavy rare earth. Rare earth occurs in a wide range of rocks. They can be formed in the igneous rocks, sedimentary rocks, or metamorphic rocks. In the igneous rock, the REE can be formed in the alkaline, paralkaline, and carbonatite. In this talk, I will focus only in the granitoids and their weather crust. The ion adsorption type REE is low mining and processing costs make them economically attractive, a source of REE compared to the primary deposit. Ion adsorption type occur in the weathered crust of granitic rocks. where rare earth elements behaving as positively charged trivalent ions during weathering are considered to be the adsorbed or negatively charged surface of clay mineral, such as kaolinite and halloysite. The ion adsorption type RE deposit are associated with metalluminous, two weakly peraluminous, I-type, and ilmenite series granitoids. The RE can be formed as trace component in residual mineral, secondary RE, trace components of iron and manganese oxide, and exchangeable cation on clays. Weathered profile in Indonesia, Thailand, Philippines is in the ion exchangeable fractions, are mainly adsorbed onto kaolinite, halloysite, gypsite, and vermiculite. Look at this figure. As we can see, China is the tops of the list for reserves and the mine production here. China owns 44 million tons of rare earth reserve, following by Vietnam, Brazil, Russia, India, and other small RE producers countries. And also you can see for the production mine, China have been produced about 140,000 tons of rare earth. This figure on the left side showing this global distribution of rare earth elements from USGS 2019. We can see that Indonesia is already known as a potential RE producer country. At least USGS already put the deposit or occurrence of the location here, but still Indonesia have not been reported the resource, their resource. Essential parameters to form the ion adsorption type is mainly of initial concentration of parent granite, geographic location, climate condition, annual rainfall, geochemical composition, and geologic age. Look at the world map of the Copenhagen here. About the climate classification. Indonesia showing a red color here. Then they have, and Indonesia has a wide distribution of granitoid. The other country which also has a red color, such as Brazil, Malawi, Madagascar, and Myanmar, they are RE producers country. So the combination of climate condition, tropical climate, and distribution of the granitoids here as the parent rocks, making the Indonesia deal or good source for the production of the ion adsorption ore. The ion adsorption ore is one of the most important sources of REE, in particular of HREE. The ion adsorption type usually is showing reddish soil-like weathering crust developed on the parent granite, I-type, and ilmenite series granite in the Jurassic to Cretaceous Yansanian in China. So what is the main problem to develop REE-based industry in Indonesia? In my opinion, the problem is lack of understanding of the deposit of the REE itself. The exploration for REE is still sporadic actually, and then the REE source has not been identified so far. So the research of REE has been conducted in a preliminary stage in Indonesia since at least last decades. Petrography, biochemical analysis, X-ray diffraction, SEM-EDS, and RE sequential extraction are suggest to apply to get more understanding about the ion adsorption type in Indonesia. And the objective of this talk is to elucidate the mineralogical and geochemical characteristic of the parent granites that have the potential for the ion adsorption type RE deposit in Indonesia. Okay, let's move to geology. Okay. This figure showing a granitic province of the Southeast Asia thin belt. Yeah. As you can see, from the north to south and from the east to the west, The Eastern Range Province, the Main Range Province, and the Western Province are consisted of I-type, S-type, and combination of the S and I-type. Okay, and Sibolga located in the western coast of the North Sumatra here. According to Xiaoqing 2021, the granitoid of Sibolga are within the western province, but this location, this granitoid status actually is still in debate. Some other researchers didn't say it like that. Granitoid Sibolga is related more to the eastern province. Maybe I will talk later for this. And another figure on your right side, you can see the distribution of granitic rocks and their age in Sumatra, Malay Peninsula, and Tin Island. You can see here that the Bentong Raub Suca here was extended to the Indonesia Tin Belt here. The Bangka, according to Ang et al. 2019, is belong to the main range, while Belitung is unidentified granite province so far. In the mainland of Sumatra, as you can see here, the extension of the granite province, Southeast Asia Tin Belt or granite province is not clear here. This is due to the lack of the study of the granitoid in this area. Okay, this is the geological map of the Sibolga. You can see this Sibolga is here. Is mainly consisted of the Sibolga granite complex. Early Permian age, the rocks are granite diorite, granites, and diorite. The location is located at the southern part of the Sibolga city here. According to the magnetic susceptibility, the Sibolga during the field check is an ilmenite series granite. This is the value of the magnetic susceptibility. Move to the main part of my talk today, mineralogical and geochemical signatures of the potential ion adsorption. So this is the parent rocks of the weathered crust from Sibolga. The rock names are quartz cyanide, quartz alkali feldspar cyanide, and cyanogranite. Those parent rocks containing titanite, zircon, apatite, and allanite. These are accessory minerals which are very important for the formation of the ion adsorption ore. This is the figure of the petrography of allanite here. The primary allanite showing a zoning here. And by semi-DS mapping here, we can identify the existence of the cerium, lanthanum, and neodymium. And this is the apatite, and this is the element mapping by semi-DS. The apatite containing ytterbium, neodymium, and cerium. Allanite and titanite. This is allanite. And this titanite containing lanthanum, cerium, and neodymium in the center of the zoning. And this is the normalized, Conrad normalized RE pattern of the parent rocks of Sibolga. This red color is for Sibolga Julu. Sibolga Julu looks identical with the Sibuluhansya Poras A, but actually they derive from different magma source, while the Sibuluhansya Poras B and Sarudik, they have relatively similar, both showing relatively light rare earth enrichment compared to the heavy rare earth. On your right side, showing the extended spiral diagram, yeah, we can see the low content of barium, strontium, and relatively high content of rubidium, thorium, niobium, and zircon here, and also enrichment of REE except for europium. This is the characteristic of the A-type granitoids. This is some of whole rock RE geochemistry from Sibolga. You can see the range of granitoid from Sibolga and Panyabungan are relatively high compared to those from Muara Sipongi and Kota Nopan. The range of granitoid from Sibolga and Panyabungan are within the light rare earth and rich parent granite from the South China, which produce iron adsorption type. I also compare the Sibolga granitoid to some other area from Southeast Asian tin belt in Indonesia, such as from Bintan, from Unggan, from Selayar Singkep, Karimun, and also Bangka. I took the whole rock geochemistry from Irzon 2015 until 2020. I also compare the Sibolga with Phuket from Sanimatsu et al. And also from Kapuas and Daroktan from the Philippines, from Padrones 2017. We can see the chondrite normalized spider diagram here, that they usually showing light REE enrichment compared to the heavy rare earth. The granitoids from Karimun, from Selayar Singkep, from Unggan, and also from Bangka, showing higher value of higher or more enriched in those REE. Okay, Unggan and Karimut granites are A-type. The total RE content is higher than Sibolga granitoids. The Sibolga granitoids here showing by the this blue color, and the total is higher. Indonesia's southeastern belt are mainly of S-type granitoids, contain total RE higher than those granitoids from Daroktan and Kapuas, Philippines, Phuket, Thailand, and Salim Endorompin from Malaysia. This is another chondrite normalized spider diagram from southeastern belt compared with the non-tin belt. The non-tin belt taken from Palu and Mamasa from Maulana et al. 2014. And also from my own data from Tarado 2010, you can see that the Southeast Asia tin belt in Indonesia is much enriched in the light rare earth and heavy rare earth here, while the Phuket is still just between Southeast Asia tin belt in Indonesia and from Malaysia, from Palu and Mamasa from Maulana et al. So in another figure, we can see that the I-type granitoid from Phuket is much higher RE content compared to those granitoid from Salim granite in Malaysia. So the Southeast tin belt has higher RE content than the non-tin belt. The Phuket the transition I to S-type and Kota Nopan I-type granitoid showing higher RE content compared to Lagoi, Mamasa, Muara Sipongi, and Endorompin granitoid. This is the normalized spider diagram from the parent granitoids from Phuket, Thailand, Mamasa, Palu, Sibolga, and Daroktan Kapuas. I compare the granite Sibolga with those granitoid, important parent granitoids in Southeast Asia. We can see here that the granitoid from Sibolga is the highest RE compared to those granitoid from important parent granitoid in Southeast Asia. And this is the on your right side is a normalized spider diagram of whole rock. Yeah. While in the left side is the parent rocks. The bed rocks on your right side is the weathered crust. So the weathered crust of the Sibolga granitoid is a much higher, but compared to those weathered crust from Phuket, weathered crust from Sibolga is slightly less compared to those granitoid. This is the profile of the weathered crust from Sibulhan Siaporas A. There are many samples collected from this area. I couldn't take the samples from the uppermost of the area because of the slippery. And we can see that the diagram here is a sequential extraction result. normalized diagram. We can see here that the whole rock RE and RE extracted from S1 and S3 here, showing cerium negative anomaly, and total RE is higher than the from S2 and S4. This is S2 and S4. Allanite and titanite occur. Halloysite and gibbsite also occur here. This is the summary of the extraction. Most of the extracted REE are light rare earth, and compared to yttrium, light RE is more dominant. And this is the Sibulhansha porous B, another location, also showing almost similar, but the whole rock RE and extracted RE from the upper to lower horizons tend to increase. In the S8 here, RE content is higher, associated with the halloysite and gibbsite. The RE extracted from the whole rock using the sequential extraction is around 27 to 40%. Another location at Sarudik, we can see here, low total RE content in the bedrock, whole rock RE and extracted RE are low. Occurrences of the residual monazite and cenotype. The last location is from Sibolga-Julu. RE content is low due to the occurrence of the residual monazite and cenotype. Still, our light rare earth are mainly absorbed by sequential extraction. The extraction result from the whole rock is about 37 to 58. This is the summary of the sequential extraction. In the Sibulhansha porous A, allanite, titanite are likely decomposed and releasing the RE ion 3+, while in the Sibulhansha porous B, monazite and cenotype were refractory to retain RE. This made Sibulhansha porous A has the higher extracted total RE than SSB, Sibulhansha porous B. The phosphate content here of the weathered class of the granitoids from Sibulhansha porous A and Sibulhansha porous B tend to be higher than the parent rock, suggesting the occurrence of the secondary phosphate in the weathered class. REs are less mobile during the weathering at Sibolga-Julu here, due to the occurrence of the residual monazite and cenotype, which immobilize RE during weathering. The most ion exchangeables in weathered granites are most likely to have been sourced from allanite, apatite, and titanite because they are rarely found in the weathered class. The low mobility of the rare earth can be explained by the occurrence of residual monazite and secondary RE phosphate, which immobilize RE during weathering. The parent granite of Sibolga are ilmenite series and A or A-type granitoids. Total RE content in the weathered class in Sibolga are lower than those parent granitoids, suggesting that our REE leach out during the weathering. The initial RE concentration of the parent rock is less important criterion in prospecting ion adsorption type. For the cases of Daroktan in Palawan granite in Philippines, most of RE was present as ion exchangeable in form, ion exchangeable form in Sibulhansha porous, which are likely to exist on the surface of clay, while in Sibulhansha porous B, Sarudik, Sibolga-Julu, REE is in residual monazite and secondary RE phosphate. Now it's come to a conclusion. So RE content of granitoid in Indonesia is higher than that from Thailand, Malaysia, and the Philippines. The I and A-type ilmenite highly differentiated granitoid are potential for ion adsorption type I deposit, characterized by high silica content, low phosphate content. Positive cerium anomaly in the upper horizon is good evidence for potential RE enrichment in the lower horizon. RE ions are likely from allanite, titanite, apatite, and fluorocarbonates. Sibulhansha porous A is a potential ion adsorption type. The presence of the weathered RE bearing mineral is more critical in prospecting ion adsorption type. And ion adsorption type is an important to alternate source for RE exploration target in Indonesia. So that's all my presentation. Thank you very much. And ask Google for any question. Thank you.
Okay, thank you, Pak Iwan Setiawan. Maybe before we ask the Google, everyone can just drop and give a question for Pak Iwan and then Pak Imam Purwadi. Everyone who wants to give a question, you can just raise hand, and then the committee will open your mic. And then the first question is for Pak Imam Purwadi from Pak Lukas Doni. Can you just directly ask to Pak Imam?
Terima kasih, Mbak Wulan. Good morning, everyone. And yeah, it's great presentation from both of you, especially Mas Imam. It is my first time to attend your presentation, your great presentation. But there is some concern and some confirmation. In general, your research is very important to confirm either remote sensing can be used to confirm the presence of rare earth bearing minerals. As Badan Geologi actually use remote sensing, but with some different way. For example, to detect monazite, to calculate the resources. So if we read the resources that we have related with monazite as byproduct or in tiling, as product of tin mining, they use remote sensing. I personally question this one. I'm not convinced at all. So that your result will be very important to confirm either the method used by Badan Geologi to calculate the resources of monazite especially in southern part of Bangka is valid or not. But there are some differences that I would like to ask you. Number one is that you use neodymium, the specific element that actually among the most scarce. We see from data from Pak Iwan that typically lanthanum and cerium are more abundant than neodymium, but you use neodymium. So the question is that why you use neodymium rather than mineral? So for example, why not spectral characteristic of monazite, but you choose neodymium? The second question related with accuracy of the data, you use portable XRF. I will not use portable XRF at all. So Pak Iwan will be confirming this one for this very delicate, very sensitive topic. Please use the highest accuracy of measurement, especially when we would like to confirm the detail, the most precise level of element. Please do not use portable XRF. Probably for lanthanum and cerium probably still okay, but not for other rare earth elements. And then I would like to know the conclusion in so far. You mentioned about the minimum concentrate. If not 100 or 1000, please say again or confirm what is the minimum concentrate of rare earth element in tiling that can be detected based on your study so far, and how to differentiate tiling from original placer deposit. Tiling is very sensitive topic because the concentration of rare earth or monazite in tiling is much less than original placer deposit. You clearly stated it is about tiling. Do you have any idea the concentration of rare earth in tiling that you consider can be detected? And finally, in current result, what kind of remote sensing? You mentioned about Sentinel. I believe Badan Geologi use other optical remote sensing. What are your recommendation of a remote sensing platform to be used to detect this concentration? That is a question from for Mas Imam. And if if it is okay, Mbak Bulan, I would like to ask one question for Pak Iwan. Is it okay?
For sure, Pak. You just can continue.
Okay, Pak Iwan, I would like to know your data from Sibulga granitoid. Do you think those are representative for all part of Sibulga granitoids? Because from other studies, we learned that Sibulga granitoids actually composed of many different granitic compositions. So, do you please explain the strategy of selecting the location to be sample, and either your data are representative for the whole batholith system or batholith complex of Sibulga, or only specific part of Sibulga granitic complex. Thank you, Pak Iwan and Mas Imam. Terima kasih, Mbak Ulan.
Terima kasih. Thank you, Pak Lukas. And then Pak Imam Purwadi, you can answer.
Okay, thank you for the question. So I list there are 5 questions: reserve, YND, XRF, travel, and satellite. So first about reserve, yes, I agree with Dr. Lucas. Remote sensing cannot be used for reserve calculations. That's first, because it can be used for locating or localized from regional, like Australia is pretty huge, to smaller, like city, and then to calculate again, remote sensing cannot penetrate deep, especially about optical. It's only few microns, especially if it's wet, and there is no use of remote sensing or vegetation cover. That's first. The second, why neodymium? Okay, your question is here. Why don't you use like spectral characteristic of monazite? So back to monazite. Monazite, you're right. Monazite contain a lot of lanthanum, cerium, and then later neodymium. So if you measure lanthanum, rare earth is special. Okay, there's a lot of discussion about that. But in short, lanthanum doesn't absorb light, invisible. Cerium as well. But neodymium absorbs light. So if you measure monazite with visible near-infrared reflectance spectroscopy, what you see, what the reason of the absorption is in fact neodymium with a little effect of samarium and dysprosium, but the concentration of samarium and dysprosium is pretty small. So people believe that, well, it's proven by quantum physics that the absorption of monazite is characterized by neodymium. That's why we don't use lanthanum, because lanthanum doesn't absorb light. That's first. And XRF, why we use XRF? You can imagine that in my research group, we measure herbarium specimen. We have like 1 million samples, and you can imagine how much time and resource to measure them with ICP. That's why we use XRF. And then if there's anomaly, we bring it, measure it ICP. Again, even though we use XRF, it is not a pure raw data. And you know, this XRF is like portable. It's a small device, and there's like synchrotron. Synchrotron is a huge XRF device. It's like a football field, you know. It's like 100 by 100 meters. And the same principle with XRF, portable XRF. We use the same algorithm to that synchrotron in Australia and to process the data from portable XRF. You're right that portable XRF might not work for most of rare earth elements, because the sensitivity of sensor, most of portable XRF use energy dispersed. But if you use wavelength dispersed, you can go to lanthanum, cerium, neodymium, and praseodymium and samarium. But for ED portable XRF, you can go with lanthanum and cerium. Yes. The number 3. The threshold value. My research on Bangka Island, well, again, in previous research, it is stated if you want to detect RE in material, the neodymium concentration must at least 1000 ppm. That's first. But again, there's a lot of factors. You need to consider signal to noise ratio. So the signal to noise ratio should be around 100. And we also need to consider the band resolution, spatial and spectral resolution. If the spectral resolution is like 4 bands only invisible, you cannot see where neodymium absorption band. And also if the spatial resolution is like 30 by 30 meters, while the outcrop is only 10 meters, you cannot see it. You can see some, but it will affected by the surrounding area, maybe vegetation and iron-bearing minerals. So again, in Bangka Island is unique, if I may say, because the tiling in Bangka Island is quartz, and quartz doesn't contain iron. There's some iron, but a little bit. And if you try with other area which contain a lot of irons, there may be interference with iron signatures. And the last is satellite. Why I use Sentinel-5? So if you plot the absorption band of neodymium, or if you're talking about high TVRE, there will be erbium. Sentinel-2 has several bands, and one band is practically useful because they are in the position of neodymium absorption band, and the width of this band is small. So it's like it was designed for neodymium. And for satellite, you can try Sentinel-2. People try Landsat 8, 7, but it's not suitable for this job. And if you're talking about hyperspectral data in the near future, 2022, there will be a commercial satellite hyperspectral if you want to buy, but I try one, the quality is not good for, because again, in terms of spectral resolution, it's good. It has 200 bands, but the signal noise of ratio is quite low. So when you look at the image, it looks nice, but when you check the spectra, it's noisy. So you cannot extract some information. I hope that's answered the question.
Thank you. Thank you.
Okay. Thank you. Thank you, Pak Imam, for your answer. And Pak Iwan, can you just answer?
Okay, thank you, Bu Wulan. Thank you, Pak Lucas. Your question is very good, very insightful. Actually, a lot of geological data were produced in Sumatra, but mostly in the eastern part. And most of them are addressed into different aspects of geological, geochemical, and isotopic relationship of the granite. In West Sumatra, it's also the same. It's the worst, I think. West of Sumatra or mainland of Sumatra also have a very few of data. Even the many data are published, but they didn't have correlated each other. Some study were conducting petrography only. Some other study only biochemical analysis. There's no systematic study for REE study or petrogenesis in granitoid in Sibolga or North Sumatra actually. In Sibolga, they have a very wide range of granitoids. Yeah, they also form in the since early late Permian to early Triassic. Yeah, and you are right that Sibolga contain also many type of rocks, not only cyanogranite, but also many other type of granite, cyanite, monzogranite, alkali feldspar granite, and so many type of granites. But according to the combination study of petrography, same ADS, XRD, ICP-MS, those granitoid mainly classified as I-type and A-type. I-type generally derived from the partial melt of the igneous source, while A-type granitoid in Sibolga is how to say, as a mixing of the I-type or metallomanous granite later with the carboniferous metasediment in the basement. How to find the good outcrops, weather crust in the Sibolga? Actually, we need to do the petrographic very detailed. We don't need the information about the major mineral composition of the granitoid. Everyone already knows what is the main composition of the granite. But what is the most important for the studying RE in the ion adsorption type is the existence of the weatherable RE bearing mineral. So please define those RE bearing mineral which are easier to be weathered, and then find an outcrop, good profile of weathered crust who present the horizon A at least to horizon C. As you know, the accumulation of RE usually in the horizon B or horizon C. The horizon A, which is the least zone, will accumulate cerium, while the horizon B and horizon C will accumulate other RE ions onto the in the clay minerals such as kaolinite and gypsite or halloysite. I think just do petrographic in detail, find the weatherable RE bearing minerals, find a good outcrops from horizon B to horizon C, and also do another analysis if it is possible. But for early prospecting, I think petrography need to be done very nicely. I think that's my question. Thank you, Pak Lukas.
Thank you, Pak Iwan. Terima kasih, Mbak Ulan.
Okay, thank you, Pak Lukas. Thank you, Pak Iwan. Thank you, Pak Imam. So we still have a time if the other participant want to ask our speaker. It's still open. So I have question for your for both of the speakers. I just want to know about your your perception or your comment, because because Indonesia is still at the preliminary stage of REE exploration. So what do you think about the recycling the REE while we are doing the exploration, Pak? That's my question for you, both of you.
Maybe Dr. Iwan can go first.
Me first?
Yeah.
But Ulan, I don't understand what you mean about the recycling.
I mean the recycling. Doing the, for example, recycling the REE from the waste.
Oh, I see.
Technology waste.
Okay. Yeah, I think there are many RE potential resource. Yeah, it's not only depend only in monazite and sonotime, where many other RE bearing mineral, which is because we didn't do any study about that. Another unconventional RE deposit is, for example, in the red mud, in the acid mining drainage, and the fly ash bottom ash, which are they known as waste. Actually, they have a very, very good potential. As we can overcome all the technology. We have the technology. We have also the material, and we also have social. We can handle the social problem and the environmental problem. I think it's a very potential. PT Timah, as long as I know, they have only 20,000 tons of the reserve. If they produce 2,000 tons per year, we can stay only for 10 years at least. Yeah, we need a sustained supply chain for RE. So I recommend all geologists, all of us, study more, put your attention to other RE resource rather than only monazite and sonotime. Maybe that's my question. Thank you, Mbak Ulan.
Thank you, Pak. That's very interesting answer.
From my side, because I only did research on Bangka Islands, so I'm maybe a little bit familiar with Bangka Islands. So in my opinion, it's quite hard to recycle tailings from Bangka Islands, especially the area around Koba, because RE is inside quartz is like quartz inclusions. And first we need to break the quartz, and which might be expensive. And also a study from our colleague from IT we have confirmed so far, iron absorption is not sufficient or effective for tailing from Bangka Island. So if we go for Bangka Islands, we need to another approach, I think. But yeah, they have a lot of results.
Okay, thank you, Pak Imam. Maybe as Pak Iwan.
Add some comment, Mbak Pulan?
Yeah.
Yeah.
Please,
If there are no other questions, I would like to make additional comments, especially for Mas Imam. Yeah, Mas Imam, I got your answer from my question that you suggest that at least there should be 1,000 ppm rare earth within sediment or tailing that can be detected by remote sensing. So I can say it means it is not possible to be detected, because I know exactly that within tailing the rare earth element is much less than that one. So please consider that one. And then the second is your slide related with sample that you show. Suppose because your presentation is about tailing, you show high concentration of rare earth bearing mineral. So if that is true, you use that sample as representative of tailing. I think that is not representative, because tailing is not that kind of material. So please be careful with the material you consider as tailing. If we can see within tailing the rare earth bearing minerals such as monazite, cyanotypes, then that is most likely to be concentrate of tailing. So from the tailing being concentrated, and if you use that kind of sample as representative of material field data, so please be careful. That is not really tailing, original tailing. Thank you.
Should I add comment or not?
Thank you, Pak Lukas. Yeah, you can comment if you want.
Yes, first of all, who said that 1,000 is not me? It is a researcher from Alberta. It is, we call it, I don't know the name of the guy, but he is from Alberta University. And again, I emphasize in my slide, my presentations, Bangka is unique. The material is quartz. Quartz doesn't absorb light, while there's RE absorb light. And because it's clearer, and if there's a little bit concentration, it is in the lab scale, which is perfect, we can detect it. And again, it's unique to Bangka because it's quartz. But if it's in iron, we might not be able to see it. And about my sample, it is not 1,000 neodymium. If you see my previous slide, the concentration of neodymium is around 23 up to 300. Yeah, and that's why in my previous comment I said Bangka Island has a lot of results because of RE. Yeah, I just found it. Found them.
Okay, thank you, Pak. Maybe another question from other participant. It's still open. We still have like 15 minutes. So, Pak Imam, I have another question, just a quick one. So, do you think the remote sensing still can be used in Indonesia, because, as you said, so many noise or so many limitation of it. So, what do you think?
First, it might be useful for Bangka Island because a lot of their area and the material is unique. And for other area like forest area, we need to develop a method. Which currently, yeah, we are doing it in New Caledonia, but it's not for rare earth, it's for nickel. For nickel is possible, for rare earth is possible, but it's still in research.
Okay, thank you. I see Pak STJ raise hand. Please to give your question, Pak. Yeah, I saw it.
Okay, thank you very much, Pak Imam Parodi. For the first time, you sharing your knowledge and experience with our organizations. We really appreciate that. And Mas Iwan, for sure. My question will be for Pak Iwan or maybe Pak Imam later on. Pak Iwan, as now we have BRIN, I'm assuming that BRIN will have more, I do not know, more power or yeah, maybe power to emphasize what are they going to do, especially in the REE business in Indonesia, not business, maybe matters of points. Yeah. I would like to know if you have any, or BRIN has any plan to have a different approach on how we could push from the government side to do more REE minerals inventory in a better way, at least that the industry could also see that there is a goodwill from the government through BRIN, so the industry will also do something aligned with what the government would do. I think same question maybe to Pak Imam. What do you think abroad that you could bring something from abroad that could probably enrich Pak Iwan with his BRIN team for the better future of RE in Indonesia. Thank you. Thank you, Pak Iwan.
Thank you, Pak STJ. Yeah, maybe you just can answer the question, Pak Imam and Pak Iwan.
Okay. Thank you, Pak STJ, Pak Budi. So actually, LIPI or BRIN has been joining the RE research since 2015 in Yogyakarta at the time. We already proposed, we already mentioned that we only focus studying REE in the non-tin belt granite. Why? Because tin belt granite is already known before, and as we also known that also RE bearing minerals, monazite, cenote is we have not yet alternative, but monazite and cenote, while we're producing it to extract RE, it will have environmental problem, right? So we suggest from LIPI or BRIN to do an exploration, to develop exploration method in the iron adsorption type in non-belt granitoid. S-type granitoid, which distributed in the Southeast Asian tin belt, contain higher RE, but also contain radioactivity. But if you have I-type granite, weathered I-type granite, which also contain a lot of weatherable allanite, titanite, which are contain lower RE and radioactivity content, but economically is more feasible compared to those production of cost mining and processes of primary deposit. So according to the environmental sustainability, green energy, green environment, we would like to develop RE in the iron adsorption type in non-tin belt deposit. We will start from the remote sensing study. I will contact Pak Imam Purwadi maybe later. It is very important to study to identify which area in Indonesia composed of the I-type granitoid in Sumatra to Papua, and which area are overlay with some other concession of the company. So if the granitoid, the potential I-type granitoid is belong to some other company, I will try to contact and maybe if possible making a collaboration with the company. And yeah, we will go into detail in the more deeply studied in the those area, which is very potential in our future sustainability area. Thank you.
So for me, I forgot the question because it's too long. Can you please repeat the questions?
That's not question. It's just like, thank you for your. Is it right, Pak? Sorry, Pak STJ. Can you just repeat the question for Pak Imam? Is it just like say thank you for joining? Sorry. Can the committee unmute Pak STJ?
Okay, akhirnya. I thought that was blocked intentionally. Yes, Pak Imam, a similar question to Pak Iwan. So basically, we just like to have your suggestions about how do approach on the RE business differently, probably to get something from you, something that we can learn from what you have done abroad on in other countries, just like earlier Pak Iwan mentioned about utilizing the remote sensing geology approach, for instance. Is there any particular suggestion for you that is going to be doable and applicable in Indonesia, especially for or with BRIN or maybe the community or the society of the Indonesian geologists or the minerals industry itself? Thank you.
Okay, first of all, thank you for inviting me. And then regarding the questions, my focus is Bangka Island, so it is based on Bangka Island. And for the Iwan, yes, of course, we open for collaboration. And back to the Bangka Islands, I've presented my result to the ministry, and now we are writing a proposal with ITB to do what's next. And from my research, we can do with remote sensing. And the next step is to develop a method to detect rare earth-rich soil or plants by using remote sensing. That's first. And the second is that we are trying to measure herbarium at Bogor, but it's hard to get the permission to enter the museum. So if we can collaborate to get permission to enter the herbarium museum, we can perform herbarium scanning, and then hopefully by using these plants, we will know some area that is rich in metals, not only Re, but also nickel, cobalt, zinc, selenium, and yeah, rare earth, of course. And also, currently I'm trying to develop a method as well to extract some rare earths from tiling in Bangka Island. My previous finding is that, in one plant species in Bangka Islands, it contains 1,000 Re plants material, so it's huge, and it is in Pomali. So if we can develop this plant, of course, it might not be economically feasible for company, but for some local community, it might be useful. And yes, so thank you.
Thank you very much, Mas Imam, Mas Iwan. Thank you, Bapak.
Okay, thank you, Pak STJ. Okay, maybe enough for this session. Thank you for Pak Iwan and Pak Imam. So I will just wrap up the session. I make a summary for this session. So from Pak Imam Purwadi, the remote sensing gives some benefit to easy exploration from continental to local scale. The abundance of data and time effective, but maybe still cannot be effectively used in Indonesia due to some limitation of cloth and vegetation cover, also high limit of detection and limited to top earth soil surface. So need to do more study and research for the detail, what's the method or about the method of the remote sensing in Indonesian area. And then from Pak Iwan Setiawan, some essential parameter to form the ion absorb type deposit is initial concentration, the geographic location, and then also climate condition, annual rainfall, geochemical composition, and geologic age. And the total REA content of granitoids in Indonesia is higher than from Thailand, Malaysia, and Philippines. The ion absorb type is very important alternate source of REE exploration target in Indonesia, but again, still so many potential source in REE Indonesia, but still require more study and to obtain the resource of REE, because as Pak Iwan said that one of the problem is we haven't know about the REE resource in Indonesia. So collaboration study will be required and answer the problem about REE resource in Indonesia. Pak Iwan and Pak Imam, thank you for your presentation. We are waiting for your collaboration study. Maybe you can share with us in the next MGEI convention. Thank you. Thank you all. I give back to MC.
Thank you very much, Ibu Wulandari. And now we will move on to the memento of appreciation to our speakers and to our moderator. But first, this memento of appreciation will be given by Bapak Oki Budi Wijayanto as Ketua Komite Implementasi KCMI IAGI MGEI. The first memento will be given to Bapak Imam Purwadi. Okay, if the gentleman could please look to the camera. All right, I will count from 3. 3, 2, 1. Okay, thank you very much, gentlemen. And now for the next memento of appreciation to Dr. Iwan Setiawan. Okay, I'll count from 3 also. 3, 2, 1. Okay, thank you, gentlemen. And last but not least, a memento of appreciation to Ibu Wulandari Mandradewi as our moderator for this session. Okay, Ibu, all right. Everyone ready? Okay. 3, 2, 1. Okay, thank you everyone, but please do not go anywhere. We will take a group photo with Bapak Imam Purwadi, Dr. Iwan Setiawan, Ibu Wulandari Mandradewi, and of course Bapak Oki Budi Wijayanto. Okay, everyone please look to the camera. 3, 2, 1. Perfect. Thank you very much to Bapak Imam Purwadi, Dr. Iwan Setiawan, Ibu Wulandari Mandradewi, and of course Bapak Oki Budi Wijayanto. And now before we go on our next break, I would first like to thank our sponsors and of course our media partner. Starting from our Superbyte sponsors, we have PT Geofix Indonesia, PT Merdeka Copper Gold Tbk, PT Petrosi Tbk, our Gigabyte sponsor, PT Antam Tbk. Our Megabyte sponsor, we have PT Agincourt Resources, PT Aman Mineral Nusa Tenggara, PT J Resources Nusantara, PT Nam Sumaluban Abadi Sumacorp, PT Reka Buana Penjuru Mineral, PT Sumbawa Timur Mining, and our Kilobyte sponsors we have PT Eksplorasi Nusa Jaya, Minerba Indonesia, PT Greenland Resources, Harita Nickel, PT Indodrill Indonesia, PT Nusa Halmahera Minerals, and PT Timah Tbk. Our workshop sponsor, Sequent Limited. Our other sponsors, PT Medco Energy Mining International, and PT Mindvesting Resources Indonesia. And of course, our media partner, Dunia Tambang. To our sponsors and media partner, we thank you for your support in making this event happen. Next, we would like to invite all of our participants here to, of course, attend the booth exhibition, where our sponsors, media partners are ready to offer their services and products. And please make sure to also check out the posters made by our students all over Indonesia. Have a good break, everyone, and we'll see you soon for the next session. Hello everyone, while you enjoy your break, we've entered the session of sponsorship presentation, which PT Indodrill Indonesia will be presenting their products and services. For this session, we would like to invite Bapak Wahyu Wafik. Good morning, Bapak Wahyu. How are you today?
Good morning, Mbak Rahma. I'm very good, thanks.
That's lovely to hear, sir. Well, I will let you take over for this session.
Thank you. Let me share my slide. Can you see my slide?
Yes, we can see your presentation clearly, sir.
Okay, thank you. First of all, I would like to thank to MGEI who have given me the opportunity to be here. Very good day, everyone. In the next few minutes, I would like to introduce Indodrill Indonesia. As with 28 years experience in drilling industry, we are offering professional, innovative, and efficient diamond and reverse circulation drilling service to the mineral and coal industry. In addition, we also offering a wide range of drilling service to the energy, civil, environmental, and agriculture industry. Our focus on safety, productivity, and sample recovery is a fundamental to how we deliver our service. We continue to optimize our maximum rig availability and minimum downtime. Then this is a Indodrill Indonesia, formerly the company established in 1993 with the name of Antero Indodrill. At that time, we started with 2-3 rigs in operation, and then in 2001 until 2004, we got major projects, contract drilling in Gosowang, consisting of 9 rigs. And then 2004, we diversified operation into other Southeast Asian countries. And then 2010, Indodrill Indonesia, Antero Indodrill rebranded to Indodrill Indonesia. At the time, we also set up Indodrill Group Holding as a parent company of Indodrill companies operated in Southeast Asia countries. While in 2018, we renamed Indodrill Group to Global Drilling and Exploration as a reflection to diversify our operation into international globally. Then at the time we expanded this operation into Europe, Middle East, and Asia, including Australia and Pacific region. Global Drilling and Explorations Group now has an office in 10 countries and a fleet of 80 drill rigs. Indodrill Indonesia, so our vision is to be recognized and respected for providing the safest, highest quality, innovative, and competitive drilling service to every company we collaborate with in every industry and country we work in. To achieve our goal, we set up 8 values that guiding principle that provide us with a purpose and directions, which consists of safety, collaboration, quality and innovation, passion, integrity, accountability, environment, and improvement. This value help us manage our interaction with both customers and our employees. Our service consists of surface drilling and directional drilling, underground wireline and directional drilling, multi-purpose drilling, which consists of diamond and RC, reverse circulation drilling, grid control drilling, geothermal drilling, coal bed methane drilling, environmental drilling, and geotechnical drilling. Our workshops and facilities and equipment at the moment in Indodrill Indonesia has 37 rigs, including commercial brands rigs such as SRAM, Sandvik, and customized rig designed and manufactured in-house. Our workshop facility provides maintenance plans, including preventive maintenance, refurbishment, and optimization schedule that are designed for each rig and piece of equipment to maximize rig availability, optimize performance, and minimize downtimes and maintenance costs. Our current contract drillings, including underground diamond drillings in East Java, surface deep directional diamond drillings in West Nusa Tenggara, as well as grid control, resource division drilling in North Sumatra, and shallow surface diamond drilling in North Sumatra and in Maluku Islands. This is our site location as per December 2021, where we have 6 projects in North Sumatra, Marta Bay, Sihayo, and then East Java in Tujuh Bukit, Ru'u in West Nusa Tenggara, in Wetar Island, and then with a new client in Sangihe, Talot region, where we have 27 rigs on site, in which 19 of them in operation, while the other as a backup or being mobilized to site. Our personnel are central of our ability to deliver our service, work with some of the most accomplished, experienced and capable people in the drilling industry. And we make sure that our people are equipped with the latest technology and knowledge. Our financial capability enable us to invest more in development our people using human capital management strategies. Just we make sure that they are equipped with the latest knowledge, techniques, and equipment. Our customers, we measure our success by our clients' satisfaction of the service they receive from us, and we strive to provide practical, effective, and innovative solutions while building a strong, transparent, and open relationship with our client. It is our commitment to all these parties, as well as our vision statement and values, that ensure us to enable our client to achieve their drilling requirement. And this is our assessment, certification, and awards, including in 2021, we received ISO 9001, so quality management service in diamond drilling, as well as safety culture implementation from WSO, and the latest certificate of appreciation 3 million hours LTA free from PT Sumbawa Timur Mining. That's all I informed today. Thank you.
Thank you very much, Bapak Wahyu Wafiq, for your presentation, and we hope that this will make all of our participants here understand better of PT Indodrill Indonesia's products. And up next, it is our special session where we would like to thank personally to our sponsors. Welcome back, ladies and gentlemen, and now we've entered the session for the memento of appreciation, especially to all of our sponsors. The memento will be given by Ibu Rosalyn, Deputy Chairman of MGEI. The first memento will be given to PT Geofix Indonesia. All right, I will count from 3, 2, 1. Thank you very much from PT Geofix Indonesia. And up next, it is PT Merdeka Copper Gold Tbk. Okay. 3, 2, 1. Thank you to PT Merdeka Copper Gold Tbk. And up next, it is PT Petrosi Tbk. Okay. 3, 2, 1. Perfect. Thank you very much to PT Petrosi Tbk. And up next, a special thank you to our Gigabyte sponsor, PT Antam Tbk. Okay, please hold your position. 3, 2, 1. Thank you to PT Antam Tbk. Up next, we would like to give it to our Megabyte sponsors, starting from PT Agincourt Resources. The Megabyte sponsors will be given by Ibu Rosmalita Dita, Event Committee of MGEI Annual Event. Okay, 3, 2, 1. Thank you to PT Agincourt Resources. Up next, we have PT Aman Mineral Nusa Tenggara. Okay, hold your positions. 3, 2, 1. Thank you to PT Aman Mineral Nusa Tenggara. And next we have PT J Resources Nusantara. Okay, 3, 2, and 1. Thank you again to PT J Resources Nusantara. Next, we have PT Nam Suma Luban Abadi Suma Corp. Is Ibu Dita ready? Okay. 3, 2. All right. We apologize for a bit of technical difficulties. Okay. Again to PT Nam Suma Luban Abadi Suma Corp. Okay. 3, 2, and 1. Perfect. Thank you again to PT Nam Suma Luban Abadi Suma Corp. And up next we have PT Reka Buana Penjuru Mineral. Okay, hold your positions. 3, 2, and 1. All right, thank you very much to PT Reka Buana Penjuru Mineral. And up next, but not least, we have PT Sumbawa Timur Mining. Three, 2, and 1. Perfect. Thank you very much to PT Sumbawa Timur Mining. And up next, we would like to thank our Kilobyte sponsor, starting with PT Eksplorasi Nusa Jaya. Okay. Is Ibu Dita ready? All right. 3, 2, and 1. Perfect. Thanks again to PT Eksplorasi Nusa Jaya. And up next to E Minerba Indonesia. Okay. 3, 2, and 1. Wonderful. Thank you to E Minerba Indonesia. Up next, we have PT Greenland Resources. Okay. 3, 2, and 1. Okay, thank you again to PT Greenland Resources. And up next, we have Harita Nickel. Okay, smile to the camera. 3, 2, and 1. Fantastic. Up next, we have PT Indodrill Indonesia. Okay, I will count again from 3. 3, 2, and 1. Perfect. And then up next, we have PT Nusa Halmahera Minerals. Okay. 3, 2, and 1. Beautiful. And last but not least, to PT Timah Tbk. All right, 3, 2, and 1. Wonderful. Next, we will have a special thank you also to our workshop sponsor, Sequent Limited. Okay. Smile. 3, 2, and 1. Perfect. Next to our other sponsors, we have PT Mindvesting Resources Indonesia. Okay. 3, 2, hold your positions. Okay. And to our other sponsors, PT Medco Energy Mining International. Okay, thank you very much. 3, 2, and 1. Thank you to PT Medco Energy Mining International, and a big thank you to all of our sponsors, Superbyte sponsors, Gigabyte sponsors, Megabyte sponsors, Kilobyte sponsors, workshop sponsors, and other sponsors for supporting this event. And now, we will move on to a short break, which we will see you in a few minutes before starting the next session. See you soon, everyone.
Welcome to PT GeoFix Indonesia. GeoFix is a multidisciplinary and multi-commodity exploration and mining consultant drawing all over Indonesia. With a band of highly skilled professionals as our core, GeoFix committed to maintain the highest standards and best practices, comply with the code and policies, and never compromise on safety, health, and environment in doing our business. We support all scope of mining enterprises to unravel their proficiency to fix, build, and enhance their assets' value through explore, discover, develop, and repeat. With the provision of innovative, reliable, and high quality of services and solutions, whilst nourishing state-of-the-art platforms and ecosystems in mining industry. Our services encompasses GIS, Greenfield Exploration, Brownfield Exploration, 3-dimensional modeling, geometallurgy, metallurgy, resource estimation, technical due diligence. We also provides drone LiDAR survey services, a high-precision aerial topographic survey provide reliable and accurate data for your project. GeoFix has diverse professional experiences in assessing across the range of multi-commodities and project stages. How do we execute a strategy and deliver a goal? Reputable expertise with passion, teamwork with state-of-the-art technical and non-technical capability, consistent and persistent management and stakeholder support. Guided by our values: respect, reputation, technology and innovation, breakthrough, quality and integrity.
The energy and minerals sectors are experiencing significant times, and the willingness to embrace and ability to harness change will become crucial factors to continuously move forward. Here at Petrosi, embracing this change is exactly what we continue to do. Established in 1972, Petrosi has been listed on the Indonesian Stock Exchange since 1990 and is now recognized as one of Indonesia's leading contractors that serve the mineral resources, infrastructure and oil and gas industries. In carrying out our operations, we are supported by our main shareholder, PT Indica Energy Tbk. Drawing on rich and varied experience throughout the Indonesian archipelago, we are now entering a new stage in our journey, harnessing emerging enablers to drive better performance and pursue new growth opportunities. With over 45 years of experience under our belt, Petrosi continues to be one of the most trusted contract mining service providers in the country. Ready to tailor our integrated mining solutions for each of our clients. But experience is not the only thing that sets us apart. Our willingness to continuously innovate is also our winning factor. The company has taken a strategic step towards the transformation of our entire mining operations. With the implementation of new enablers within our other business lines also slated in the near future. We believe that the visibility and clarity delivered by these new enablers will enhance our agility, improve our productivity, and positively impact our future financial performance. Petrosi also has vast experience and expertise of providing engineering and construction project management and services, the mining and infrastructure industries, while constantly maintaining strong relations with key stakeholders such as the government, consultants, and communities to assist our clients in meeting their business goals. With the acquisition of PT Kuala Puebloan Indonesia in 2018, we have also continued to strengthen our ability to provide logistics services for the mining and infrastructure sectors. Petrosi provides services for the oil and gas industry in Indonesia through our Petrosi Offshore Supply Base, or POSB. From our deepwater supply base located in Sorong, West Papua, we consistently deliver international standard and cost-effective services to all of our clients. In 2016, Petrosi was officially inaugurated by the Indonesian government as a bonded logistics centre, PLB, for the oil and gas sector. Here at Petrosi, safety is our #1 priority. As one of our core values, safety, health and environment has become part of our culture, which is embedded in every employee. We continuously strive to achieve safe, efficient and productive operations, with an ultimate goal of zero harm to people, the community and the environment. Our talent is our key asset to be successful in the industry. Through our human capital management strategies, we have and will always strive to attract the best talents, develop their full potential and encourage them to become champions of the industry. Implementing quality management that fulfills our clients' needs and adds value to their operations is an integral part of our success. To this end, we persistently apply our Petrosi Quality Management System, or PQMS. By continuously improving our business processes, the system allows us to meet the requirements of operations, quality, as well as safety, health and environment. A firm believer in the triple bottom line, Petrosi is committed to the implementation of corporate social responsibility programs that are directed towards local communities and the environment surrounding our operations, as well as our own employees and their families. By focusing on issues such as education, health and economic empowerment, these programs will positively impact the betterment of their lives.
Petrosi is no stranger to innovation. Our continuous improvement program and portfolio balancing strategy has enabled us to navigate through sea changes within the industry and to continue to thrive throughout the years. In order to further improve our corporate performance, we are continuously enhancing our operational excellence, while always being very disciplined in implementing good governance across all elements of the company. Going forward, Petrosi will continue to transform and embrace change in order to successfully provide enabling solutions for our clients, thus creating value for the shareholders and also help create a better Indonesia.
Bapak dan Ibu, terima kasih atas partisipasi serta dukungannya dalam acara kami, the 13th Annual MGEI Convention 2021. Saya Eni, dan saya akan memandu Anda dalam mengakses website dan platform untuk event ini. Untuk mengakses event ini, Bapak dan Ibu dapat melakukan registrasi melalui website www.mgeifan.com. Anda dapat memilih pilihan Click to Visit, kemudian pilih opsi Go to Convention Site. Di sini, Anda dapat memilih opsi Exhibitors untuk mengunjungi booth exhibitor dan mendapatkan informasi mengenai info perusahaan, katalog, handout, atau live chat dengan staf representatif dari perusahaan. Untuk masuk ke dalam Zoom presentasi, silakan mengakses dashboard akun Anda, kemudian memilih opsi memasuki live sesi convention yang akan menghubungkan Anda dengan Zoom meeting. Jika Anda belum melakukan registrasi sebelumnya, silakan melakukan registrasi pendaftaran melalui opsi Register yang ada pada halaman muka dari website convention. Silakan mengisi form informasi dan data diri, kemudian pilih opsi Create Account untuk membuat akun baru. Konfirmasi akun Bapak dan Ibu akan dikirimkan melalui email. Terima kasih atas perhatian Bapak dan Ibu. Kami berharap Bapak dan Ibu dapat menikmati acara ini.
Welcome back, everyone, from the short break. And now we will move on to the third session with the theme Strengthening Coal and Mineral Inventories. Today we will have 3 speakers. The first speaker is Bapak Sarjono of Independent, who will be speaking of the exploration leads of primary diamonds in Kalimantan. Our second speaker, Bapak Elino Febriadi of Cakrawala Langit Sejahtera, who will be speaking of sustaining coal inventory through persistent exploring brownfields area. And last but not least, our third speaker, Bapak Yoga Surya Negara of Para Consulting, who will be speaking of Indonesian metallurgical coal, current update, and the future. This session will have a moderator, Ibu Asri Dia Wijayanti of PT Greenland Resources. But first, allow me to introduce Ibu Asri Dia Wijayanti's background. Ibu Asri previously earned her bachelor's degree in geology in UPN Veteran Yogyakarta. She also has several work experiences with the top 3 from 2020 until 2021 at PT Wirama Entity Nusantara, or Coal Trading, as Executive Director. Then from 2015 till 2021, Ibu Asri worked at PT Lamaru Bangun Persada, a drilling contractor, as commissioner. And now, from 2012 until 2021, at PT Greenland Resources, a mining consultant as director. Her professional backgrounds are competent person Indonesia for SNE, KCME, JORC report, coal exploration and resources estimation, geotechnical engineering, and project management in exploration and mining. Her recent publications are FACES Volcanic Modeling at Derajat Geothermal Field and GORC and KCME Public Report for several mining company in Indonesia. To Ibu Asri, you may now take the lead. Hello, Ibu Asri, how are you today?
Yep. Hello, I'm fine, thank you.
I'm glad to hear that. You may now take the lead, ma'am.
Okay, thank you very much, yeah, for the time and the screen. Okay, good afternoon, ladies and gentlemen, all MGEI squad who always keep in spirit on, to always inspiring the exploration and mining industry. Okay, now we are in the third day and the third session of the 13th MGEI annual convention. And we have 3 experts here in diamond, thermal coal, and also metallurgical coal. They are ready to share their expertise and discuss about the strengthening coal and mineral inventories. We will have Bapak Sarjono, who will present about the exploration leads of primary diamond in Kalimantan. And then the second one is Bapak Elino Febriadi, who will present about sustaining coal inventory through persistent exploring brownfields area. And then the latest one is Bapak Yoga Suryanegara, our friend, who will present about Indonesian metallurgical coal, current update and the future. Yeah. And then for the first speaker, I will introduce the CV of Bapak Sarjono. Committee, please share the CV of Bapak Sarjono on the screen. Sorry, I cannot see the screen. Sorry, yeah. Okay, yeah. Okay, yeah. Pak Sarjono, his education background is graduate in physics, yeah, from the Institute of Technology Bandung, and then Master of Science in Exploration Geophysics from the University of New England, New South Wales, Australia, and then PhD in Exploration Geophysics from the University College London, England. And then his experience on the work, Bapak Sarjono joined the Geological Agency, the Ministry of Energy and Mineral Resources, and already retired right now. And then currently he independent work in the retirement time. And then let's welcome the distinguished of the Bapak Sarjono to deliver his presentation. Bapak Sarjono, time and screen are yours now.
Thank you. Good afternoon. In this occasion, I will be presenting the exploration leads of primary diamonds in Kalimantan. The results of my analysis of gravity and topography. Could I have the next slide, please? Hello? Thank you. Can you have bigger one? Okay, thank you. Okay, we all understood that to this very moment, diamonds in Kalimantan are found as alluvial deposits with no clear traces on what and where the primary sources are. As such, people often call the diamonds as enigmatic and headless deposits. This is a century-long left frozen mystery. Dated back to 1930s, Koolhoven, a Dutch geologist, raised a speculation on the presence of mantle plume structure when he, for the first time, found alluvial diamonds in Kalimantan. The mantle plume, which reside at the depth of about 150 kilometers or deeper, is known to be associated with the formation of diamonds. The formation of diamonds in that depth involves the pressure of about more than 4 gigapascal and temperatures of about 1000 degrees centigrade. Despite extensive geological studies through the time, the status of the knowledge on the occurrences of diamonds in Kalimantan is ambiguous and inconclusive, as the eviction of the expression of mantle plume is lacking. This was primarily because all geological studies in the past relied only on data at surface. The next slide, please. The present study carried out the analysis of gravity and topography, and results in the revelation of the mantle plume structure beneath Kalimantan. Then the discrimination of the gravity signature of the exploration leads of primary diamonds from the deep concealment of gravity effects generated by the mantle plume. Then the third identification of exploration leads using the discriminated signature of the gravity anomalies and topography. And I also present an example for estimation of gross reference of primary diamonds at one lead area. And last, the implication on the presence of the pockets of alluvial diamonds at the river mouth areas as resulted from the rapid uplift in the central range region. The rapid uplift in the central region causes a high degree of erosion and intensive weathering. The eroded and weathered mineral, which contain masses of diamonds, are subsequently transported downhill by the river. Next slide, please. This is the spectral analysis of bogey gravity, the map on the left, and which shows 3 distinct lithological boundaries beneath Kalimantan. That is, the apex of the mantle plume at 158.9 kilometers below the sea level, the Mohorovicic discontinuity at 23.8 kilometers, and the top of the granite crust at 7.9 kilometers. Map D, smaller map, illustrates the approximate geometry and the depth of the mantle plume structure. Next slide, please. This is the lithospheric scale model gravity model of the mantle plume structure beneath Kalimantan Island. The mantle plume structure is approximately elliptical in shape, with the long axis oriented southwest-northeast, approximately 600 kilometers long, 300 kilometers wide, and about 40 kilometers thick. The depth to the top of the plume structure is approximately at about 160 kilometers below sea level. Could I have the next slide, please? This is an illustration how the discrimination of the mantle plume, the discrimination of the exploration lead from the deep concealment of the mantle plumes carried out. At the bottom part of the slide, a circular disc representing the mantle plume, and at the upper one, at the top of the above the mantle plume, there's a cylinder representing the exploration lid. Exploration is representing the intrusive body bearing diamonds. The map on the left represents the gravitational response of the mantle plume. The second map on the middle shows the gravity effect the cylinder, and on the right, on the middle right, the map of the summation of the mantle plume and the cylinder, the intrusive body. On the rightmost of the mesh, on the rightmost of the map, you can see it. That's the recovered or the captured lit areas of the primary diamonds. The next slide, please. The map on the top left is the Bouguer gravity. By doing the filtering or the discriminating the map, we could get the map on the right, the big one, which consists of patterns of low gravity gradients represented in blue patterns, elliptic to circular and to elliptic patterns, where the circular pattern are highly potential to host the intrusive body, the intrusive body which carry diamond, while the elliptical patterns they represent sedimentary, the core of sedimentation, the core of sedimentation. The next slide, please. On the right map, on the right hand side, the patterns of the list area are overlaid on the topographic map. We are only interested in the narrow pattern which represent our highly potential in hosting the intrusive body. Next slide, please. Next slide, please. The next slide, please. Okay. The map on the left, this is the recovered area, the captured area, using the wider discriminating windows. On the right hand side, we use the narrow filter, the narrow window of the filter. The result of the narrow filter is associated with the pattern of the intrusive, the pattern of the diamond bearing intrusive body. Next slide, please. This is the plan to demonstrate you that the choice of the wider windows and narrow window will result in different pattern, and that will be in East and Kalimantan area 1. In area 2, in the Putus Sibau area, we will try to identify lit areas and make an estimate on the gross reserve of the primary diamonds at a chosen lit area. In area 3, in area 3, this is in Mount Newt area. I will leave this for you to to make estimate on of your area of choice. Next slide, please. The next 5 slides. Yes, thank you. This and the next 4 slides compare the size of captured areas of the explosion leads using these discrimination windows width of 4 minutes and 2 minutes. Yeah. You see the map on the left is the topography of the area, and on the right side, on the right hand side, it's topography. As you might notice, the outline, the area outlined by mantle plume structure, indicated by red and green colors in the topography, and blue to white on the topography, are very potential to host the intrusive body. To the southern part of the map, on the right hand side map, we can see the low gravity that indicates the sedimentary basin. Next slide, please. Okay. Slide on the left is the gravity, bokeh gravity. On the right hand side is the recovered or the captured pattern, the white spots with low gravity, low gradient are mapped. The right hand side is the gradient map, which show the patterns of low gradient, which are the candidates for the explosion leads. Next slide, please. Could I have the next slide? Okay. The pattern on the right hand side shows white pattern in the south. That is the sedimentary basin, while a little bit narrower in the upper part of the maps. The upper part of the maps, which demonstrate narrower pattern, are potential for hosting diamond-bearing intrusive body. Next slide, please. You can see now the map on the right-hand side looks so patterns that is much narrower. That is more appropriate to locate the primary diamonds, the leads of primary diamonds. So the 2-minute discriminating windows will be used throughout the remaining part of this work. The next slide, please. The next slide, please. Next. Okay. This is Putusibau area, West Kalimantan Province. On the left-hand side, we can see the topography. On the right-hand side, the topography. The high topography is characterized by low gravity. Again, the low gravity in this map are potentially hosting the diamond-bearing intrusive bodies. Next slide, please. The enhancement of pattern from the gravity map on the right, on the left, to become the gradient maps to the right, in which there was narrow patterns of the gradient strongly indicates the leads exploration idea. Next slide, please. The map on the left-hand side is translated into the right-hand side by manually picking the pattern of flow gradient, the sickle pattern with blue color on the right-hand side, and I have marked the number 1 and number 2 as the potential lead area, the potential exploration lead areas of primary diamonds, area 1 and area 2. Next slide, please. This is blown up the lead map, highlighting lead areas 1 and 2. Lead areas 1 was chosen for the gravity modeling to make estimates of the gross reserve of the primary diamonds. Lead areas in the Ardennes which host a cluster of lead areas, may be explored later. Could I have the next slide, please? The next slide, please. Thank you. This is for the exaggeration of the area 1 map to show the transect west to east of the model analysis, along with the composite profiles of the elevation, green line, the Bogey gravity, black crosses, the gravity trend line, solid black line, and the residual gravity, red line. The modeled intrusive body was assigned as to have an average density of 2.52 ton per cubic meter, floating on the granitic background of 2 and 0.67 ton per cubic meter. The computed gravity anomalies of the model shows a reasonable match to the observed ones, and this was taken as the first approximation for the estimation of the gross reserve of the primary diamonds at lead area 1. The next slide, please. Could I have the next slide, please? Hello, thank you. The detailed model consists of mass of the top cone V1 on the right-hand side, with its base at the ground level, and the peak of the cone is at about 310 meters. The other V2 and V3 masses are situated at deeper level of subsurface. The gross reserve estimate was carried out for the top cone 1, for the top cone V1, which in this case, the computed total mass is almost 4 billion tons. At a recoverable ore grade of 100 milligrams or 1/2 carats per ton, the gross reserve of the primary diamonds at lead area 1 is about 396 million ton or 198 million carats. Next slide, please. Next. Next, please. Next slide, please. This is the Mount Newt area, yeah. Okay. This is the Mount Newt area. The map on the left is the topography, and the right-hand side is, of course, gravity, Bogey gravity. You may notice the elevated area of Mount Newt is about 500 to 1,200 meters. Is marked in red. Is characterized by low Bogey gravity of about 5 millikel to minus 10 millikel, exhibiting a cluster of cyclic patterns which are potentially probable to host diamond bearing intrusive body. Other narrow patterns which show elevated topography are also consistently characterized by low Bogey gravity. These are the candidates for lead areas of the primary diamonds. Could I have the next slide, please? The map on the left is the Bogey gravity, and the map on the right is the gradient maps of the Bogey gravity. The small pattern shown in low, the small pattern of low gradient in the central west to southwest part of the map. I'm sorry, on the Mount Newt area, smaller, narrow pattern of low gradient are the candidates for the exploration leads, as well as the narrow pattern in the central southwest, also potential for hosting the diamond bearing intrusive body. The next slide, please. Well, that means sometime in the past, the Mount Newt was situated, the Mount Newt area, the Mount Newt was situated above the mantle plume. But since the earth skins, the crust slips towards southwest at the speed of 135 kilometers per million year during about the last 2 million years. The plume outline is at present situated about 370 kilometers to the northeast. This is a global regional tectonic. Could I have the next slide, please? The next? Okay. This is the model of topography showing transport pathways, which is indicated by small and white arrows, from the central range region to the interior areas of Kalimantan. The buoyant force of the upward moving mantle plume has resulted in the rapid uplift in the central range region, which in this case also results in the high rate of erosions and weatherings of the exposed part of the diamond bearing intrusive bodies. The eroded and wetted materials are subsequently transported downhill by streams of rivers which carry rock aggregates containing masses of diamonds. Thus, examining the appropriate river mouth areas of Kalimantan may lead to the discoveries of pockets of diamond masses. The next slide, please. Okay, thank you. Based on gravity analysis, we will compare the occurrence of diamond in Kalimantan and in South Africa and Botswana. In the slides, in terms of the dimension of the mantle plume, it is estimated that the size of the mantle plume beneath Kalimantan is only about 99% of the size of the mantle plume beneath South Africa and Botswana. The depth to the top of the mantle plume beneath Kalimantan is about 160 kilometers, and in South Africa and Botswana ranges between 180 and 200 kilometers below the sea level. Well, this figure may suggest that the total amount of gross use of primary diamonds in Kalimantan. Next slide, please. This map compares the patterns of gradients in both in Kalimantan and in South Africa and Botswana. As we can see in both maps, the low gradient patterns both South Africa, Botswana, and Kalimantan show fairly consistent appearance, where low gradient values appear to host diamond bearing intrusives. As an example, the big open pit diamond mines of Orapa and Karowe and Zwaneng, the Gaborone capital is in between. Could you show the location, please? The Gaborone and okay. At the big open pit diamond mines of Orapa, Karowe, and Zwaneng are all characterized by low gradients, by low gravity gradients. Similar patterns are also present in Kalimantan, as you can see here. However, since there isn't any open pit diamond mines in Kalimantan, head-to-head comparison between Kalimantan and South Asia and Botswana cannot be made. Could I have the next slide, please? This is conclusion, okay. And the conclusion, the gradient spatial filter provide an indispensable tool for delineating exploration leads of primary diamonds. The central range regions, with this height about 160 kilometers above the mantle plume, is highly potential for hosting the diamond-bearing intrusive body. Rapid uplifts in the central range region promote a higher degree of erosions and weathering of the exposed part of the diamond-bearing intrusive, which subsequently transported downhill to the areas of Kalimantan. The present study marks the end of the tenure on the enigmatic and headless diamond deposits and unlock the opportunity to the search for the primary sources of diamonds. The present study also predicts the existence of pockets of diamond masses at river mouths of areas, of diamonds. Could I have the next slide, please? This preliminary work is recommended to be followed by activities for validating the result of this study. This may include a systematic and detailed online gravity and magnetic measurements covering the identified lead areas, shallow drilling to collect rock samples containing diamond masses, and laboratory analysis for the physical and chemical characterization of diamond-bearing rock samples. Alternatively, the validation of result of the present study may consist of the acquisition of an analysis of geophysical data set of a higher accuracy, such as the airborne gravity gradiometry and magnetometry at selected lead areas. The analysis of the higher accuracy data set will also be complemented with the ground truth, as well as the laboratory works. This is conclude my presentation. Thank you for your attention.
Yeah, thank you very much Bapak Sarjono for the great presentation and very well time management of Bapak Sarjono, so the presentation finished on time. Okay, we will keep all of the question to Bapak Sarjono after third presentation on the discussion session. Now we will move to the second speaker, Bapak Elino Febriadi. I will introduce the CV of Bapak Elino. Committee, please share the CV of Bapak Elino on the screen. Thank you. Yeah, Bapak Elino currently is a geology and engineering advisor from PT Cakrawala Langit Sejahtera, and his education background is graduate from Teknik Geologi Institut Teknologi Bandung, and his work experience since 1991 until 2007. He worked as a coal exploration and mine geology, also mine planner in PT Arutmin Indonesia, and then he became manager geology and engineering, then moved to contract administrator as a manager, then after that as a general manager engineering, contract maintenance for infrastructure, and then currently after retirement in 2021, Pak Elino became the advisor at PT Cakrawala Langit Sejahtera. His professional background in MGEI and EIG, and then Perhapi also AUCMM member. And then he also has the recent publication in PTAI History of Coal Discovery, and then KCMI code implementation, and then impact of complex geology to mining in PT Arutmin. Welcome Pak Elino to deliver your presentation. Time and screen yours.
Assalamualaikum. Thank you very much, Mbak Astri, for the opportunity to give this presentation. My presentation will be titled Sustaining Coal Inventory Through Persistent Exploring Brownfield Areas. This presentation is basically based on experience in PT Arutmin. So, My presentation will follow the outline as follows. First, I'm going to talk about historical flashback on Arut Min coal exploration. Then I'm going to talk about difference between greenfield and brownfield exploration. Then we're going to look at the observed problems based on the experience and possible solutions. And then conclusions. Let's go to historical flashback. Arut Min got its license in 1982, and up to 1990, it did exploration, greenfield exploration basically, because there is no mine exists at that time. Ownership changes several times during this period because coal prices vary during that period, and also apparently the findings shows vary. There is a thin coal, there is thick coal, there are high calorie, there's low calories. So it gives different perceptions, and stakeholders change their mind, sell their stake, and other people come in. In 1990, the trial mine begins as we got the license to mine, and then followed by Satui, where I joined in 1991. But greenfield exploration continue in other areas, but it decreases because as the interest dwindling down at some areas is not as good as the other area. In 1997, greenfield exploration stopped. 37 geologists being transferred to other BHP area at that time, to Central Kalimantan. So the number of geologists decreased significantly in that period, from maybe around 40 geologists to maybe close to 10. But in 2000, as the ownership changed to Bakri, the brownfield exploration started again as the owner wants to extend the mine life and reserves, and also the existing mining start encroaching into insufficient data, drilling data area. So let's look at locations. This is Indonesia, Sumatra, Java, and then location is in South Kalimantan. Initially in 1982, we got 1 million hectares. So basically in the southern part of South Kalimantan, Maratus Mountains in here. So this is Anjung Formation for in purple, and then Warukin Formation in green, light green, where the coal is. Warukin is in dotted orange. Yeah, this one. So coal was found around those two formations. In 1990, the interest area was in this orange polygon. So from 1 million hectares, it becomes 75,000 hectares, less than 10%. Sorry, this is a problem, sorry. Okay, let's go to next slide. I have a problem before I can resolve that problem. Okay, we go to the difference between greenfield and brownfield. Greenfield, as we understood, is project development in undisturbed terrain when there is no mining. And then brownfield, the continuation of existing mining project or rebuild of older mining activity. So brownfield exploration means exploration from the existing mines. Because it has support from the existing mines, brownfield exploration is supposed to be more efficient. We're going to see that in the subsequent discussions. So let me describe the greenfield first, which is quite simple. There will be more pictures, so that's why it appears in the small areas in the top corner. It will consist of surface mapping, drilling, survey topography. Then geologists will create geological model and geotechnical model, and then we will come up with resource estimation. This is what the greenfield doing. When the mine happens, then it will become another cycle of process where the mine planners will start creating a mine planning and then produce reserves and then feasibility study, and then infrastructures being constructed. And then if it is a contract operation, then it will be a contract management, and then it will be a mine operation. And the mine operation will produce coal, and it will generate sales and revenue. If some areas is finished, it will be reclaimed, and then mine closures is started. What we want to show here is in cycle is the in-pit mapping and reconciliation, which is part of the mining operation, but done by geologists. So it will produce a working geotechnical model, data from in-pit mapping, and will produce working geotechnical model and working geological model. And then it will update the mine planning, and then it will update the reserves, basically reduce reserves because they already have been sold. And then if there is nothing happen, then mining will stop once the reserve exhausted. But this is where the brownfield come up. And so the brownfield is quite a separate activity, but it has connection with the operation where it will start, sorry for this typing, it will start with the existing geological model, yeah? And then from that, the geologists produce drilling plan, and then it will acquire land and develop access. And then there's a drilling management, build database. This is just a more detailed description about exploration. That happens in the greenfield also. Then it takes a couple of weeks, maybe 2 or 3 weeks, maybe 1 or 2 months to get the quality. Then only then you can produce the updated model with quality. But after drilling, you can produce the immediate geological model without quality, and that should be done in while the drilling happens. Yeah. So the geologists need to update the drilling plan using this immediate geological model. So let me summarize the difference between brownfield and greenfield exploration. In the greenfield, there is no nearby mines, but in brownfield, we assume there should be a nearby mine if it hasn't been closed. While we are doing greenfield, we don't know how the coal will be sold, whether it can be sold as raw or it has to be washed. In the brownfield, we know that already, so as target is clearer. Where its impact will be on the sampling procedures, the drill spacing, what type of analysis to be done. So brownfield will be much accurate in its doing to get the objective. In greenfield, there is no infrastructures. Geologists stay in flying camps and drop by helicopters. The logistic was sent through boat or helicopters. That will happen in Arutmin. And in brownfield, the geologists stay in nice air-conditioned room and very easy travel from cities to the site. Mining procedures has not yet defined, so we don't know what is the best sampling method. So we tend to be overkill in sampling, but in brownfield, we can lean on sampling procedures, maybe because it's not necessary for the specific mine process. Drilling support has to be dedicated. We bring people from various areas and we pay them on a permanent basis. In the brownfield, we can change the crew, unnecessary crew, through the nearest nearby village. So we only maintain the key personnel. Accommodations, yeah, as I said, it will be not good generally in the greenfield, but in brownfield is good. What it means is that the geologists should be more comfort and their performance should be much better. Land access easier. This is what I mean is purchasing the land. Yeah, when in 1980 to 1990, there is no people in the exploration areas, but at the moment, most of the land is owned by somebody. So it's much harder to get land during the brownfield from 2000 to 2020. When we do greenfield, less understanding in geology, database was in the form of field mapping data. But in the brownfield, we have digged the deposit and we've done more work in general geology. So we get some ideas of how we should do the exploration, what is the spacing, and sometimes we apply geostatistics to confirm our judgment. And in the greenfield exploration, the geologists normally permanent basis because they are very important people. But in the brownfield, as I say, the number of people reduced from 40 to 10. And there is more people who appear to be key on running the mining. So geologists become on a contract basis. So they are not they're not exposed to company as much as before. Same line. Okay, now go back to observe problem. What we have found is there is interruptions on to the brownfield exploration when the coal price is down, and it comes from the decrease in budget and also a delay in procurement of parts. So we have a period where I think it's 2013, 2015, there's no drilling at all because we couldn't maintain the drilling equipment. I would say that the brownfield now include reconciliation and in-pit mapping because it is done by geologists, and the brownfield exploration, if you say it's really about producing the geological model. So these two activities is key to produce an accurate geological model. But because the problem with competency of geologists, which I'm going to explain in the next slides, we could not get useful data from this process at some point. So I'll describe that in detail later. There will be a communication issue between department from geology to mine planners to operations to contract, and even operation to marketing and sales and finance. So there has been lack of support at some point with the brownfield exploration. This is the skill retirement. We're going to look deeper into this one. And data collection and preservation, that's another problem. illegal miners has happened in our main areas, and that has caused existing model become invalid and cannot be immediately developed into mine planning. So let's look at the interruption due to decline in coal price. Exploration budget will be chopped first because that's not going to stop the process. Generally, mining operation will be first priorities. So we expect the competent geologists need to work hard to convince the management to get the budget. General reason would be to maintain the sustainability of the mining. Again, about ineffective reconciliation, we know that geological model is key. If it is not accurate, then the mining process might not doing the stripping correctly. So coal losses could happen through sterilization, or finance losses could happen through stripping in no coal areas. It happens in Arut Min. Mbak Asri, sorry, berapa menit lagi, Mbak? Just want to keep the, I tend to be too details in talking things. Mbak Asri?
7 minutes. 7 minutes more. Yes.
7 minutes.
Yeah.
So what happened in the reconciliation? As I said, geologists need to look at what appears in the pit. No, I mean in the in-pit mapping to appear in the pit, and use that to improve the accuracy of the geological model. And even in the geotech data, the current paradigm is to extract data from in-pit mapping, because the value of drill hole data is very small, because it's only a small coring. But if the geologist is not competent, then they will not be able to mine those data. As I show in the graph here, this is the process of geological model management in the mine. Yeah, this is the key in there, but it can be improved through exploration, or it can be improved through in-pit mapping and reconciliation. But if like here, the geologists need some input from the contract management, maybe a dispute between contractors and owners, and mine operation has to provide input to geologists doing the working geological model through this process. But the data from this has to be communicated back to contract, to mine operation, for them to negotiate with contractors, and mine operation to negotiate with the contractors. But we saw some problem, and also in here there is feedback from geologists working in the pit, in the area, in the field, with the drilling plan, which is created generally by head office. So if they are not talking, then the drilling plan might drill in the area that's incorrect. So that we need communication between these parties, and they are interdependent. But there's been problem where sometimes the geologist doesn't understand what to look at the pit in related to the interest of the contract. So the solution there is to have the geologists to be rotated across other departments for them to understand. But it never happened because of the limited number of geologists in our region. So here's a good brownfield drilling plan, which is a result of collaboration between mine planners and geologists, where the purple area is the pit design produced by the mine planners based on the working geological model. I should say this is the existing mine, this is the mine out areas, and this is illegal miner area. So then the geologists will plot their drilling plan based on understood drill spacing on top of that. But so they don't necessarily drill this area because the mine engineers have said that the strip ratio is bad, is high, so don't drill unnecessary drilling in this area. So it's very efficient drilling, brownfield exploration. So geology skill is also important because what we find is the geologist's contribution is hard to be recognized compared to the sales people or the mining people, where they can report by production target, and then when it achieved, they will get credit for that. And also if the marketing, if they had a good deal on marketing, they will get credit immediately. So they look contributing. But geologist is working behind behind the scene, and how hard they work maybe is not going to be recognized easily. As a result, then the promotion avenue becomes narrow and narrow, to particularly when the management changes, so the historical contribution is not recognized, and then they tend to be resigned to look for a better opportunity outside. So I can say that by the time I resigned, geologists' experience in Arutmin is very young. Many fresh geologists, but there is no old friends to me. So the solution there is geologists has to, I think they have to work hard to promote link between geological model and company performance. So management aware about their work. And then we should strive for non-structural functional career path, because so it doesn't have to depend on promotion to get a better benefit. But as long as they stay long and contributes, they can increase their benefit through functional career path. Skill retainment, I think we covered it in before. So they need to show their contribution, so the management can recognize. So here's some skill required, which is not easily maintained. Yeah. So this is correlation, and this correlation shows that top seams is high in sulfur, and the bottom seams is low in sulfur. So even when in the rightmost boreholes the seam changes, we know, because this low in sulfur, we know that the naming is the same as the one who is very far on this area. So correlation, I found it is difficult to maintain the skill of correlation because the software Mindscape doesn't support it, and even Minex and other. So this is something that we need to look at, whether we create the software ourselves or find it somewhere else. Illegal miners has disturbed many areas, mining, low strip coal. So there's many lakes in Arutmin area. So Arutmin created a drilling platform like this to drill in a pond. So this appeared to be successful in helping us to recreate the model once the illegal miners leave. So I'm talking about, sorry, I think I'm not covered. Land access is a problem. I think I covered it because the community developed around the mine. So proactive land release program is required for smooth drilling executions. Data collection is an issue for the 30 years experience in Arutmin. It's some of my work in pre-2000 is now gone. I don't know, because I've been moved to other department. So my suggestion there is to assign competent geologists to be assigned to manage data compilation, and ignorance of data to data value could lead to data loss. And that happens during office movement, media degradation, and ferocious attack. What I also see is the geology field now reports and documentation is being taken by resigning geologists. So we only leave with drill hole data and survey data and topo data. So it's very, very unfortunate because it makes the geological understanding very limited.
1 minute, Pak Elino.
Okay, so 2 slides left. So ideal brownfield exploration will be like this. Yeah, it will done by competent geologists to produce effective and efficient brownfield data collection, and leads to more good mining practice and then sustainable and profitable mine. On the other hand, there is a cycle. There is the competent geologists need to promote themselves to, there's a management awareness of the geology issue, and then support the geology development, and then we can maintain the competent geologists in the company. So conclusion, brownfield exploration should be more efficient than the greenfield one. But a competent geologist is required to recognize and utilize the advantages of brownfield over greenfield. And geologists and mine management needs to work together to establish competencies by recognizing the geologist's circle of competencies, as I shown before, which underline the need to develop competencies, maintain it by non-structural career path, and provide resources for geologists to maximize their performance in the brownfield exploration. Thank you.
Okay, yeah, thank you very much, Bapak Elino, for the great presentation. I know this is you share your experience, yeah, and I know that so many geologists, senior geologists, and also mining engineers that already have the GPI certification, yeah, under your mentoring before in PT Arutmin. Okay, we will keep all of the questions to Pak Elino after third presentation on the discussion session. And now we will move to our last speaker, Bapak Yoga Suryanegara, who will present about Indonesian metallurgical coal, current update, and the future. I will introduce the CV of Bapak Yoga Suryanegara. Committee, please share the CV. Okay, already. Bapak Yoga Suryanegara, currently he work in Paramine Consulting, member of PT Pandawa Suryanegara, and he graduate from master degree on geological science from Unpad, I think, yeah, from Unpad. And then he also a competent person under JORC code 2012, yeah, and then also certified in KCMI, and then his professional affiliation is a member of AUCMM, and then also IAGI, MGEI, and also Perhapi. And then the professional ticket of him is Indonesian Mine Operation Supervisor Certificate for POU, yeah, and POM, and also POP. And then also in Queensland Australian Coal Corps General Health and Safety Induction. And then yeah, Pak Yoga currently, as I know, is the one special geologist who specialize in cooking coal in Indonesia. So currently we will hear from the expert, yeah, about the cooking coal that right now is become, yeah, very demand, yeah, in this situation. Okay, let's welcome the distinguished of Pak Yoga to deliver his presentation. Pak Yoga, time and screen are yours. Oh, Pak Yoga still in the field, yeah? Still in the field?
Still in the field. Yeah. I'm sorry for that one. I'm sorry for the noise or something like that one.
Okay.
I just apa namanya get out into from the jungle from the exploration project a couple minutes ago, and try to hurry up check the apa namanya internet connection covered
Central
area.
Kalimantan or where?
Central Kalimantan.
Oh, okay.
Yeah, in the Central Kalimantan.
The central of cooking coal, ya.
The central of cooking coal in Indonesia, yes.
Okay, then Pak Yoga silakan.
Okay, thank you very much for all attendance. Without further ado, I want to directly deliver my presentation. And before I deliver my presentation, let me start with a small history about the cooking coal industry here in Indonesia. You see, before 2008, there is two idea or two opinion in the Indonesian coal exploration. The first opinion always mentioned that there is no cooking coal here in Indonesia, and the second one mentioned that yes, there is a cooking coal potential deposit here exists in Indonesia. Before that period of time, before 2008, the first opinion should be the most popular opinion here, because most of the explorer and also geologists was always thoughts about the coal here. Most the coal of Indonesian deposit is only favorable for the thermal coal until there is until there is a formal report from the Energy World Council submitted in 2009. In that report mentioned that there is already have been exported from Indonesia about 31 million ton of the cooking coal. Since that time, all the geologists, especially coal geologists, realized that there is a potential coal, cooking coal here in Indonesia. Okay, I want to start my presentation. Bu Asri, can I have access to share my
you will
screen?
share by yourself? Or by committee? Committee, I think already have your
okay.
presentation. So maybe
Okay.
yeah, committee can share your presentation.
Okay.
Please.
Okay, Bu.
Yeah. Committee, please. Yeah, to avoid the unstable internet connection also from your side ya, Kang Yoga, because you are in the jungle right now. Luar biasa ya. Mas Dion and team, please share the presentation from Kang Yoga. Yeah, thank you.
Okay. Okay, Bu. Okay, I would like to start talking about the Indonesian metallurgical coal exploration, especially talking about what is the coal characteristic, metallurgical coal characteristic, and also what is the deposit potential here in Indonesia. Actually, my presentation have been produced by the collaboration not only one or two coal geologists here in Indonesia, but this is a huge collaboration between the government geologists, government staff, especially the Geological Research Center, with other professional here in geology. Okay, the content next please. The content of my presentation should be consist of the at least 5 chapter. One is talking about Indonesian coal deposit as the introduction, and the second one is about coal resource on reserve here in Indonesia. So everybody would know that how much the resource and reserve here in Indonesia. And the next chapter is talking about the metallurgical coal for the general information, just for the refresh. And the next chapter is talking about Indonesian metallurgical coal characteristic. And I want to close with the some information regarding to the Indonesian meteorological coal deposit potential. Next, please. I want to start with the what is the actual coal deposit here in Indonesia, especially the characteristic or something like that, the positional setting, and especially talking about the what is the most latest information regarding to the coal Indonesian coal deposit. Next, please. In 2003, the Indonesian Geological Research Center have been published the big picture of the coal-bearing basin here in Indonesia. At least we can recognize about 21 of the main coal-bearing here in Indonesia, distribute from the west and to the east and from the south to the north. But the most important thing among that basin, this is the basin occurred in the Sumatra, and the second one is in the Kalimantan. Next, please. There is good and clear information have been published by Frederick et al. In 2016 in International Journal of Geology, talking about where is the Indonesian position among the Pacific region. The interesting thing is the Indonesian coal-bearing sediment is part of the Southeast Asia Cenozoic sedimentary coal-bearing basin. And the basin, where is the basin can be grouped into at least 5 region location: the Northern Sundaland, Southern Philippine Archipelago, Western Myanmar, and Eastern Indonesia. And Frederick also mentioned that the most significant Indonesian coal deposit from in the large sedimentary basin within the Neogen in the island of Borneo and Sumatra. And also the environmental depositional setting will be controlled by regressive setting, and the rank the rank of seam is variable, and multi-seam with the thickness more than 5 meters typically have low ash yield and also sulfur content. Next. And also the comparison, the regional stratigraphic comparison between Sumatra and also the East Coast Borneo, there is some information can be obtained from this chart, which is the tectonic and depositional history of the southern region of Sundaland was affected by Phalangian extension, resulting in the development of a small Siem Reap basin. The initial Siem Reap basin were eventually transgressed by marine sediment. That means there is a fluctuation in the seawater level will affect to the coal depositional setting here in Indonesia. Next, please. And this is also the most important thing, the combination of the large basin that quickly infill to the base level and ever wet climate and a depositional setting where pit mires could form and be preserved resulted in the formation of aerially extended thick coal deposit from the middle Miocene through the Pliocene. That is for the Neogen coal. But how about the Phalangian coal? Next, please. This is some coal sedimentary summary of the tectonic and sedimentary setting, which is Frederick in 2016 classified that the area of South Sunderland can be classified into 4 region area, which is Eastern Borneo, Central and Southern Sumatra, Central and Southern Sumatra also, and also Southeast and Central Kalimantan. And the most important thing here from this table, you can see in the summary of all property, which is the bituminous rainfall is only mentioned by Frederick, only occurred in the Central Kalimantan. So that is the most important for the earlier information for the coal geology Indonesia who want to explore about the coking coal or metallurgical coal here in Indonesia. That also similar mentioned by one of the senior geology in Coltran 2012, that the focus explored area for the metallurgical coal here in Indonesia should be located in the Central Kalimantan. Next, please. And there is also some theory and also some thesis research conducted by some expert here in Indonesia, mentioned that the quality coal of Indonesia is very and strongly influenced by the geological environmental. The positional environmental, which is affected to the coal type, and the degree of the qualification will be affected to the coal rank, resulting in the wide variation of the characteristic. And compared to the other coal basin deposit like Australia, China, Mongolia, Africa, and also United States, there is quite a different type compared to that depositional setting, because in Indonesia commonly dominated by Cenozoic coal, whereas in this of the other country commonly predominantly by Permian bituminous coal. But also compared to the some area tertiary sedimentary coal bearing in German and Gippsland basin, Indonesian coal has a similar type with both of that area. The Paleogen and Neogen coal is rich in vitrinite maceral, and that maceral content can be ranging from 80% until 96%. But the inertinite is commonly less than 5%, as well as the liptinite also commonly less than 10%. That also make the quite different thoughts about the metallurgical coal occurrences here in Indonesia. In the Permian coal, most of the coal geology expert always mentioned that the the content of the inertinite will be controlled the characteristic of coking coal. But here in Indonesia, even we have less than 5% of the inertinite maceral content, we still can get the good coking coal quality in the Central Kalimantan. Next, please. This is also some general information regarding to the metallurgical coal here in Indonesia. That commonly the Asian coal were formed under the extensional structural regime or RIP basin with the transgressive depositional environmental. As the result of this coal, generally tend to be more continue but thinner and also have a splitted. Typically, on the some of the open cut mine economical exposure, the Asian coal have thickness are ranging from 0.3 until 6 meter. Maybe some of the coal geology have already known that a few area in Indonesia has a very thick of the metallurgical coal deposit, like in Adaro met coal, and also the DBK met coal also in the central of Kalimantan. That type of the geometric coal deposit is anomalous, because commonly here in Indonesia, the Asian coal only the coal occurred in the Asian coal only formed in the two zone within the Eocene sediment bearing formation. One we call is the lower zone, and the second one is the upper zone. And the unique coal deposit of the Eocene coal here in Indonesia, even the interburden between the lower and the upper zone is very thick, ranging from 50 meter until the thickest interburden I found here in Central Kalimantan is up until 300 meters between lower and upper zone. The difference of the cooking coal characteristic or cooking coal parameter between both of that zone, coal zone, is not significant different. And instead of we found good cooking property in the lower zone, in the most area here in Central Kalimantan, I found that the good cooking property is located in the upper zone of the coal bearing formation. Next, please.
5 minutes left, Pak Yoga.
Yes. Okay. I want to skip some of the presentation like this one. This is the simplify of the characteristic of Indonesian coal deposit. Next, please. Also, I can skip this one. This is just only for general information. What is the distribution of the coal? Okay, we can go to the next chapter talking about the Indonesian coal resource and reserve. So actually, the coal resource in Indonesia is predominantly by low to the medium coal resource. Hello.
Yeah.
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 And it's only 9% of that total resource. The total resource is about 130 this is the new status, 149 of billion ton coal resource here in Indonesia, and only 9% of them is high until very high of the calorific value coal deposit type. So it's on the high and the very high coal deposit, coal quality deposit is very limited, and also located in the remote area where the mine accessibility is very difficult and is very long from the transshipment point. Next, please. This is the general information charts about the
Halo, Pak Yoga, you with us? Looks like Pak Yoga lose the connection ya. Just wait a moment ya, because Pak Yoga looks like lose the connection. Okay, so because time also already ended ya for Pak Yoga time for presentation ya. Appreciate for him because he directly presentation from the jungle ya, fresh from the jungle ya. And now we will continue with the discussion session ya. We have 20 minutes for discussion. And we know that there will be many questions to our speaker due to the very interested topic. And but for the first segment, we will choose 2 questions for each speaker. Yeah. So for the first speaker, Bapak Sarjono, we already have 2 participants who already give the question. For the first, Pak Noel Pranoto. I already conveyed the question to Pak Sarjono. And the first is there are 3 questions from Pak Noel Pranoto. The first, what is the type of intrusive that Pak Sarjono referring to as diamond bearing rock? Is it kimberlite type? And number 2, if yes, what is the age of this rock? And then the third, if yes, is there any magnetic survey to confirm the prospect? Under magnetic survey, this kimberlite normally can be seen as circular shape of anomaly. This is the first question from Pak Noel Pranoto, and the second one is for from Pak Lukas Doni. That because let to join with us ya. So Pak Lukas Doni asked to Pak Sarjono to explain again about the source of geophysical data that Pak Sarjono used in this presentation. Maybe Pak Sarjono mentioned about mantle plum model. So could you please explain again in little bit deeper and type of igneous rock associated with mantle plum setting? And then finally, do you have any information of company currently conducting the primary diamond exploration in Kalimantan? Okay, Bapak Sarjono, please your time to respond. Pak Sarjono? Bapak Sarjono, can you hear me? Bapak Sarjono, can you hear me? So
yes.
You can respond. Yeah.
Yes.
Okay, silakan Bapak.
The question number 1 is what geophysical data the geophysical data which I use for analysis of this work originated in the public domain. It is TOPEC gravity data as well as TOPEC topographic data. And the question number 2, I'm sorry, question number 2, what was the question number 2?
What is the age of this rock, Pak? The age, yeah.
What I mean by the diamond bearing intrusive rocks is in general could be what is it? Kimberlite or lamberite as usual that contains diamond masses. And the question number 3, the magnetic survey. There are some parties doing magnetic surveys, but it's not in a very good integrated or the data is not very coherent. For example, one company may do some aeromagnetic data for their own purpose, and the other company may be doing the same thing, while the government also doing the same thing, but it seems the organization of the gravity and magnetic data in this country is not very good. That's what my answer, I think. Thank you. Hello?
Yeah. Sorry, we lose your voice, Pak Sarjono. Maybe the connection problem, Pak Sarjono.
Can you hear me?
Yeah.
Hello?
Yeah, okay.
Can you hear me?
Yeah. Maybe you can repeat the latest one, Pak.
Okay. The magnetic data, as a matter of fact, there were some aeromagnetic surveys done by several companies for their own purposes, I think, as well as government also doing some aeromagnetic survey. But it seems that the database in overall package seems to be fragmented. I mean, that's not organized in one place, or otherwise the access of anyone who needs the data is not very easy. Thank you.
Okay. Yeah, thank you, Pak Sarjono. How about Pak Lukas Doni? Are you happy with this, or you still need to ask again to Pak Sarjono?
Please.
Okay. So the next question, you can raise hand. Participate, maybe for Pak Elino or maybe Pak Yoga, because Pak Yoga already joined us again, yeah. Pak Yoga, we direct to discussion, yeah, in discussion session, because time also already up, yeah, for you. Yeah, poor of you. Yeah,
sorry for that one.
No problem, yeah.
Sorry,
no problem.
sorry.
Yeah. Okay. Participant, please. You can raise hand if you want to give the question. Maybe for Yoga, because we also the team also doing the exploration in cooking coal, yeah. The problem in this area, in Central Kalimantan, the problem is about the high sulfur, that the sulfur also organic, yeah, so cannot separated, yeah. So this is also the big problem for us. About your experience, yeah, in cooking coal, yeah, especially in the cooking coal market. How about the cooking coal market for the high sulfur cooking coal from Indonesia, Pak Yoga?
Okay, thank you for the question, Bu Asri. Actually, the Indonesian cooking coal is not predominantly. I'm sorry, I just turned off my video, Bu Asri, because
okay, no problem.
I have limited access for the internet.
Yeah.
So back again. Actually, the coal, cooking coal, we call metallurgical coal, because that is the formal terminology here right now here in Indonesia from the government. So the metallurgical coal deposit here in Indonesia is not predominantly by the high sulfur. Instead of the high sulfur, I found many area also occur of the low sulfur here in Indonesia, especially if we found the coal deposition in environmental setting associated with the fluvial depositional setting, that is will predominantly by the low sulfur. Many area here in Central Kalimantan indicate of that deposit. Back again to your question, how we can market our high sulfur, our cooking coal produce. Actually, back again to the Zimmerman 1975 theory, not theory, that is also have been proved in many industry during the many decades around the world, to produce one of the good coke, it's will not be came from one or two deposit coal deposit. It has to be blended from maybe more than 5 of the cooking coal. So yes, the high sulfur will be the main challenging to market our coal deposit, but the most important thing, as I also discussed with my geologist college from IMC, I agree that the most important thing to convince the market is the continuity of supply, Bu. Once we define, on smelter can define the composition of the blended cooking to produce good coke for the smelter, then we have to ensure that we can supply continue along that period time, Bu. So even we have, let's say, like I found some high sulfur in the north of the Indica area in the Patas, also spread to the south, but I found that the market still accept that that cooking produce. Yes, we can get significant discount for the high sulfur, but still the price is reasonable. I mean, the price is still make everybody happy, Bu, especially for the miner, because cooking is very limited, especially in the current condition, whereas there is obstacle coal trading between Australia and China. So we can replace all that position, and I have also do some discussion with some big trader from China. They quite happy to accept our high sulfur cooking coal, as long as our as long as we can guarantee for the continuity on the supply. Yes.
Okay. Yeah. Thank you, Pak Yoga. Yeah. We are still having remaining time around 8 minutes. Yeah. So for audience who want to ask directly to the speakers, please raise your hands. Oh yeah, in here we also I see that Pak Nas, ya, as the one of expert in the cooking coal also. Pak Nas, how are you, Pak Nas? Sehat, Pak Nas? Okay, good. Yeah, nice to hear you, Pak Nas. Ya. Okay, yeah. Pak Elino, this is I just thinking, Pak Elino, ya, when you talking about the brownfield can be the best indication, ya, for the prospect of the mining, ya. But usually this is also what become the the good idea for the illegal mining, ya. Because if there is the active or production mining surrounding that area, so then the illegal mining also will come, yeah, and then doing the work there, yeah. So, but sometimes also I heard that there is the investor from overseas, yeah, for Singapore. They come to Indonesia and then visit directly to the jungle, yeah, and then they try to get the prospect for the good, yeah, in this case, yeah, from the illegal mining actually, yeah. So if there is the illegal mining, then they come to there, so there is the prospect here. So yeah, this is the story about the brownfield, yeah. So Pak, during your time doing the exploration, yeah, so how about the greenfield? How many time how long to develop the mining in coal from the greenfield until production usually normally based on your experience?
Apparently for Arutmin, the process is gradual. In 1990, we do trial mine, and trial mine is only a small pit producing a couple 100,000 in a very short period, and send that to various potential customers. So, and that's very short, maybe only a couple of months. And using the in Satui particularly, because I was involved. No, I was not involved. When I arrived, the trial mine already finished, but I was told that it was using the forest company, Sumpol Road. So it's using existing road, and the port, they don't have port at that time. There is a very temporary jetty in the Satuis rivers. So it really depends on setup. What kind of setup do you want? If you want to do a quick shipment of coal, part of the trial mine, then it could be in the order of a couple of months. But in Arutmin, they built port 100 million port at Kota Baru, and that finished in 1995, 1996. So it's 6 years after starting of the mine, they become fully developed infrastructure. So they have ports in Satu and Senakin, and they have ship capable loading port at Empel City. If you look at the small mines, it could be very fast. Yeah, it could be a temporary jetty where the trucks simply climb to the barge and dump the coal in the barge. But it is not a very efficient process. So because coal will be crushed during the loading process, so there are a lot of fines, and the customer will not happy. What you're going to find is the most sophisticated mine, you are targeting a luxurious market, but it means the coal price is going to be premium because you can provide good quality coal and you can establish long-term commitment. That's what happened with Arutmin. But if you see other mine, a small mine, maybe they're trying to use the opportunity of the high coal price, and then when the coal price down, they just shut down, and they only work in the spot market where the coal price may be $5 to $10 lower than the coal price that can be obtained through big companies like Arutmin. So it depends on the size of the mine, your philosophy of operations, available infrastructures like rivers, roads, etc. If you have to build long road, then it's going to take months.
Yeah. Okay. Yeah. Thank you,
Bu Asri.
Yeah.
Bu Asri, can I also involve in this discussion regarding to the mine development, especially with the current condition right now?
Okay.
I think this is just only my suggestion. Maybe MGEI or IAGI should initiative to start discussion with the whole mine stakeholder industry here in Indonesia, because don't forget that the current big mining right now has been developed with the very I said very easy access, very easy condition, thick seam or high rank of like in the south East Kalimantan or something like that, close to the big river, close to the transshipment point or something like that. That is very profitable mine. The current condition right now, we have huge deposit of the good coal located in the remote area, very remote area. You can imagine, I just spoke with one of the miner here in Central Kalimantan.
Yeah.
They have to hold the coal within 150 kilometer, then continue with barge around 700 kilometer along the river to the nearest transshipment point. So that is the huge challenging condition here in Indonesia. We have very good coal sit here in Central Kalimantan, but I didn't see any intention from the government to help. How if the government initiative, initiative to discuss how to build the integrated infrastructure, so we can bring all that good coal and export that good coal to the global market to get the big national income, rather than we just focus in the low rank or the medium rank and something like that. This is just my opinion, because if you see in my presentation, we have about 8 million with the let's say around 8 billion ton of resource, metallurgical coal, and 2.something billion ton of the reserve. Whereas in Indonesia, we just only need less than less than 20 million ton every year. So we can have a good market for our cooking coal, but yes, we need the initiative from government to lead us to build the integrated infrastructure to bring the coal to the global market. This is just only my idea. Maybe IAGI or MGEI can start serious discuss with government and other stakeholders.
Okay, thank you, Pak Yoga, because we also already aware about this, not only in Central Kalimantan but also in other area in Sumatra. The logistic is very struggle for us, and if government can accommodate this one, so will be very good, and then good benefit for all of us. Okay, thank you. So time is up right now, so we have good topic today in this afternoon, and then also good presenters, very interested, and we know that the audience are still curious with so many questions maybe, but due to the limited time we must end this session. But before that, so I can resume our discussion and topic today. From Bapak Sarjono, the resume is the Central Range region of Kalimantan, which resides vertically about 160 km above the mantle plumb, is potentially more probable to host the numerous intrusive body containing mass of diamond. And then rapid uplift in the Central Range region of Kalimantan promote a high degree of erosion as well as weathering of the exposed part of the diamond-bearing intrusive, which subsequently transported downhill to the entire lowland area. The Central Range region represents the habitation of the primary source of diamond. And then the second presenter from Bapak Elino, the conclusion is the nearby mine gives brownfield exploration advantage to be more efficient than greenfield exploration, and then a competent geologist is needed to utilize the advantage and to promote the data collection from the mine activity, as it needs effort from various departments. And then the latest one from Bapak Yoga, Indonesia sought to accelerate on metallurgical coal proper exploration program by apply a correct, complete and an integrated exploration program, and in accordance to the global metallurgical coal standards. According to this condition, also due to the remote area of the coal deposit, So Indonesia would need to build some integrated mine logistic chain supply. Indonesia should also establish the global metallurgical coal market brand in purpose to have best long-term coal market price. Okay, that's on the resume from all of our presenters and our discussion this afternoon. Thank you for Bapak Sarjono, Bapak Elino, and Bapak Yoga for sharing and discussion that overall all very interested. And thanks all for the participant for being active in the discussion and to always stay in along the session. We back to the next rundown and then time and screen back to Mbak Rahma, our Smart Master ceremony this afternoon. Thank you.
Thank you.
Thank you very much, Ibu Asri Dia Wijayanti, and also to our speakers, Bapak Sarjono, Bapak Elino Fedriadi, and also Bapak Yoga Suryanegara. And now we would like to move on into the memento of appreciation and also the photo session. First, it will be given by Ibu Rosmalia Dita Nugraheni as Staf Bidang Kajian Strategis dan Hubungan Kelembagaan. The first memento of appreciation will be given to Bapak Sarjono. Okay, to Bapak Sarjono and also to Bu Dita, please look to the screen. 3, 2, 1. All right, thank you very much. The next memento of appreciation will be given to Bapak Elino Fedriadi. Okay, everyone, I will count from 3, 3, 2, and 1. Thank you very much. Up next, we would like to call Bapak Yoga Suryanegara.
Hello? Oh. Sorry, Bu. I have problem with my video. Sorry.
It's all right, but if you need a bit of more time, it's all right. We'll wait for you.
Oh.
While we wait for Bapak Yoga, I would like to just remind you to please check out the booth exhibition, as there will be our sponsors, media partner, and also the student research posters, which you can check them out now. And of course, stay tuned for the next session. Later on, there will be the presentation from the winners of the student chapter research posters. Okay, is everyone ready? All right, 3, 2, and 1. Thank you very much, everyone. And now we would like to invite for a group photo along with Bapak Sarjono. I apologize. We would like to give the memento of appreciation to Ibu Asri Dia Wijayanti as our moderator. Okay, ladies, please smile to the camera. 3, 2, and 1. Beautiful. Up next, we would like to invite you all for a group photo. We would like to call upon Bapak Sarjono, Bapak Elino, Bapak Yoga, and also Ibu Asri and Ibu Rosmalia Dita for a group photo.
Oh.
And of course, just to remind you all again, there will be a presentation from the student research posters contest from the winners. And of course, please check out the booth exhibition again, where there will be our sponsors, our media partner, and also the students who've made their posters. Please check them out. It'll give them a big, it'll be very appreciated if you could just please check them out. And also, during the break, please don't go anywhere because there will be another quiz for you all to attend. There will be 3 lucky winners, so do not be sad that you did not earn any merchandise yesterday, because maybe today is your lucky day. Okay, could everyone please look to the camera? Okay, 3, 2, and 1. Okay, thank you everyone. Thank you also to Bapak Sarjono, Bapak Elino Febriadi, Bapak Yoga Suryanegara, and Ibu Asridia Wijayanti for this session.
Terima kasih.
All right, ladies and gentlemen, it is now time for another break, but this break is very special because we have the quiz. For this break, there will be 3 lucky winners, and perhaps it can be you, and you might receive MGEI's merchandise. I would like to first apologize in advance to our foreign participants, for I will be reading this session in Indonesian. All right, is everyone ready? Please turn on your cameras. Bapak-bapak dan ibu-ibu, kalau boleh dinyalakan kameranya. Oke, sambil kita tunggu. Oke. Kalau boleh operator lihat slide selanjutnya, apakah sudah nyala? Oke, sudah siap ya semua Bapak dan Ibu? Pertanyaan yang pertama, 1 tambah 1 sama dengan 2. 10 dikali 12 sama dengan 120. Sedangkan 100 dikurang 78 sama dengan 22. Sudah berapa kalikah event annual convention dilakukan? Oke. Raise hand, mungkin Bapak dan Ibu sekalian. Oh, kita udah ada satu raise hand dari Ibu Rosmalia Dita Nugra ini. Kepada Ibu Rosmalia Dita, bolehkah? Oke, kepada Bapak Beni. Bapak Beni sih.
13, Bu.
Baik. Oke, benar. Bapak benar dan selamat Pak. Nanti Bapak akan dihubungkan oleh panitia mengenai pengiriman merchandise MGEI. Baik Bapak dan Ibu sekalian, ini adalah pertanyaan selanjutnya. Presiden Republik Indonesia adalah Bapak Joko Widodo. Presiden Rusia adalah Mr. Vladimir Putin. Menteri SDM saat ini adalah Bapak Arifin Tasrif. Siapa nama Ketua MGEI Annual Convention tahun 2021? Ayo, seharusnya ini pertanyaannya sangat gampang. Oh, sudah ada. Oke, kepada Bapak Bashar. Bapak Ahmad Bashar.
Ya Pak.
Mas
ya Pak,
Andi
kalau
Yahya.
boleh diulangi jawabannya.
Mas Andi Yahya.
Betul, benar Bapak. Nanti panitia akan menghubungi Bapak mengenai pengiriman merchandise MGEI.
Alhamdulillah.
Baik, selamat Bapak. Oke, masih ada satu pertanyaan lagi. Pancoran adalah tempat gaul di Jakarta. Malioboro adalah tempat gaul di Yogyakarta. Jembatan Ampera adalah tempat gaul di Palembang. Di manakah alamat sekretaris MGEI? Oke, tidak perlu lengkap Bapak Ibu, nama gedungnya saja sudah cukup. Oke, sudah ada yang bisa menjawab? Bapak Alfon? Bapak Alfon Priambodo? Kepada Bapak Alfon, kalau bisa.
Bisa pancoran.
Ya, bagaimana Pak? Apakah Bapak tahu jawabannya?
So pancoran, Bu.
Betul. Baik, Bapak. Akan kami nanti hubungkan mengenai pengiriman merchandise MGEI. Baik, selamat kepada seluruh pemenang. Jangan sedih, mungkin tahun depan adalah waktunya Anda untuk menjadi pemenang. Baik, Bapak dan Ibu sekalian, saat ini adalah waktunya break time. Break time ini kami akan kembali setelah beberapa menit, namun tentunya kami harus mengucapkan terima kasih kembali kepada sponsor kami, dimulai dari Superbyte Sponsors, terdiri dari PT Geofix Indonesia, PT Merdeka Copper Gold Tbk, PT Petrosi Tbk. Sponsor Gigabyte kami adalah PT Antam Tbk. Sponsor Megabyte, PT Agincourt Resources, PT Aman Mineral Nusa Tenggara, PT J Resources Nusantara, PT Namsu Maluban Abadi Sumacorp, PT Reka Buana Penjuru Mineral, PT Sumbawa Timur Mining, dan sponsor Kilobyte kami adalah PT Eksplorasi Nusa Jaya, Minerba Indonesia, PT Greenland Resources, Harita Nickel, PT Indodrill Indonesia, PT Nusa Halmahera Minerals, dan PT Timah Tbk. Workshop sponsor kami, Sequent Limited. Dan sponsor others kami adalah PT Medco Energy Mining International dan PT Minevesting Resources Indonesia. Dan yang terakhir adalah media partner kami, Dunia Tambang. Untuk kepada sponsor dan media partner kami, kami ucapkan terima kasih banyak atas supportnya sehingga event ini dapat berlangsung. Okay, ladies and gentlemen, that is all for this session. We will come back shortly, so please enjoy the rest of your break time. Stay tuned and we'll see you soon.
Satu cik. Selamat datang di Tambang Batu Hijau, salah satu tambang tembaga dan emas terbesar di Indonesia yang terletak di Kabupaten Sumbawa Barat, Provinsi Nusa Tenggara Barat. PT Aman Mineral Nusa Tenggara mengoperasikan tambang batu hijau sejak tahun 2016 pasca akuisisi dari PT Newmont Nusa Tenggara. Disinilah kami melakukan rangkaian proses untuk menghasilkan mineral yang sangat penting bagi kehidupan manusia. Aman melakukan transformasi dalam berbagai aspek operasional untuk mencapai visi menciptakan warisan terbaik. Strategi operasional Aman adalah untuk meningkatkan copper recovery sebagai upaya konservasi mineral dan mengurangi kandungan mineral pada tailing yang ditempatkan di dasar laut atau deep sea tailing placement. Recovery penambangan juga didukung dengan peningkatan produktivitas peralatan utama, seperti shovel elektrik dan juga haul truck.
Selamat bergabung kembali Bapak dan Ibu yang kami hormati. Sebelum kita memulai sesi wrap up, Indonesia saat ini sedang dalam pandemi COVID-19 yang sudah berlangsung kurang lebih selama 2 tahun. Dalam upaya peningkatan herd immunity, MGEI dan IAGI menyelenggarakan vaksinasi gratis dalam event sosial, vaksinasi kebumian, pada yang telah dilaksanakan pada bulan September untuk vaksinasi pertama dan bulan Oktober untuk vaksinasi kedua. Selanjutnya, belum lama ini, tepatnya pada tanggal 4 Desember 2021, Gunung Semeru mengalami erupsi. Erupsi ini menyebabkan kerusakan infrastruktur dan hilangnya korban jiwa. Kami segenap anggota MGEI menyampaikan bela sungkawa terdalam kami kepada para korban yang terkena dampak erupsi Gunung Semeru. Dalam upaya membantu korban erupsi Gunung Semeru, MGEI melalui IAGI telah menyumbangkan dana bantuan sebesar 20 juta rupiah. Kami berharap bantuan ini dapat membantu para korban melewati peristiwa bencana alam erupsi tersebut. All right, ladies and gentlemen, we now would like to invite you all to watch the highlight of the last 3 days of the 13th MGEI annual event. So please check it out now.
Every single day, I'm gonna make something great. That's my way. Every single day, I'm gonna make something great. That's my way.
ladies and gentlemen, the last 3 days have been very eventful, with speakers sharing their knowledge and experiences according to each of their own expertise. And as today is the last day of this year's convention, I would like to invite Bapak Adi Sulaksono to wrap up the last 3 days. To Bapak Adi Sulaksono, you may now wrap up this convention. Hello, Bapak Adi, how are you?
I'm good, thank you. How are you?
I'm good as well. Well, Bapak Adi, without further ado, you may now take the lead.
Okay, thank you very much. Good afternoon, everyone. I'm Adi. It was a great 3 days conference. We have got a lot of knowledge in order to accelerate perpetual endeavor towards sustainable mineral and coal resources. And to summarize then, let me just run through what we have learned. This may not be so detailed, but hopefully this will help you to summarize the content of this event. So on day 1, as a keynote speaker, Pak Ridwan Jamaluddin reminded us to continue exploring the mineral resources. How can we find something without exploring? And efficiency is the key. He also encouraged us to increase the implementation of the CPI to make sure that everything is okay. And finally, he emphasized that it is our obligation to manage the environment. And the following keynote speak by Pak Eko Budi Lelono highlighted about mineral inventory in Indonesia and provide us important information regarding the further opportunities. He highlighted mineral conservation that involve the REE potential in coal and coal ash, metallurgical coal potential, and also underground or deep-seated coal potential. And Pak Fraser, as another keynote speaker, inspired us by explaining the new crash discovery success that include the discovery of the famous Kadia porphyry deposit, the Kosowang gold field, the Golpu porphyry deposit, as well as the Havieron deposit in Australia. And the lesson is a deeper drilling may end up with either new discovery, a higher grade of mineralization, or even a more challenging stuff. And then in the afternoon session, we have 4 invited speakers. Pak Hafid Rahadi, a young geologist, opened up the invited session by showing us the updated geology of the famous Tujuh Bukit porphyry system. It was a great presentation. The lithocap overprint seems very interesting, and I guess it's kind of unique because the level is almost at the same level with the porphyry deposit. And the following talk by Pak Ernowo Harjanto gave us important information regarding the geodynamic setting of the northern Banda Arc that meets the characteristic of an orogenic gold deposit. And the following speaker was Pak Brad Wake, who has 20 years work experience in Indonesia, most notably at Tokatindung, Cibaliung, Trenggale, and Sihayo. He gave us a great explanation of the success story at Sihayo. However, it is not over yet. There are still prospects that need to be evaluated, and hopefully in the next year conference, we will see the update information of that project. And Pak Reza closed the day 1 by showing us the use of white mica as a vectoring tool in the porphyry copper deposit exploration. The lesson from his presentation is that the white mica is still a good tool, but we must take a note that white mica is not as simple as we see. We need to use tool carefully, properly, and understand how they work, not only white mica for sure, but also for any other tool in exploration. Then on day 2, Jeffrey Adenquist opened up the day with his talk about the transition to tops of porphyry deposit from lithocap and other epithermal deposit. He started his presentation by pointing out that arc host epithermal deposit form at shallow depth, less than 1 kilometer below the surface, and epithermal and porphyry deposit are both intrusion center, and therefore there are magmatic fluid in evolve in all of them. And from the epidermal to deeper porphyry level, there is a transition of zone alteration. And as a summary, he saw us a different environments to produce advanced argillic minerals in arc-related porphyry system. The steam heated acid sulfate alteration at the near surface, then the advanced argillic alteration formed by vapor condensate at higher temperature, forming the residual quartz and also quartz alunite. Then another style of advanced argillic alteration is that form at the transition between the porphyry and the lithocap, which is the result of cooling of magmatic hydrothermal fluid from white mica to pyrophyllite. And if we only call this all advanced argillic alteration, we are losing the detail. We must mention the mineral name and mineral assemblage rather than summarizing it as advanced argillic. At the end, he points out that do not force a prospect or deposit into a published model. So build your own model. And then the following talk by Yao Sang Chang was about zoning pattern and the factor controlling a skarn deposit. He outlined metal zonation and mineral variation in a skarn deposit, and we learned that skarn are typically zoned as a result of transfer of heat and mass from intrusion or fluid conduit to calcareous wall rock. We also learned that there are several factors affecting the formation of skarn, such as redox state gradient between magma and wall rock, and how is causative magma evolve, which may include the volatile content, the degree of fractionation, and the redox state of the magma, and wall rock characteristic, of course, and also depth of formation, as well as the distance from the magma. And then Pak Daniel Smana opened the invited session in the day 2 by talking about ore conservation from the utilization of the Kosowong tailing, in addition to geology investigation, resource estimation, mining design, and mining and processing strategy. He also saw us the future plan regarding the tailing management, which is low cost and even safer. And the following talk by Pak Janjan Herdiana was the mining conservation scheme at Martabe Gold project. As a summary, the continuity of improvement in Martabe Gold project agrees with government policy, aiming to have an optimum gain of recognized mineral resources and or reserve. And the mining reconciliation is within accepted tolerance, and blast movement monitoring was implemented, and our blending practice has applied for years, and the improvement processing that aims to enhance metal recovery, mill throughput, and also recycle cyanide will reduce processing costs and increase the economic value in reserve block model. And the following talk by Pak Ferian Anggara was about the current and future trends of valuable elements in coal, which is the case study of REE and yttrium in Indonesia, coal and coal ash. As a closing remarks, he mentioned that there is a possibility to find coals with high-grade REE and yttrium in ash that are compatible with those of conventional economic ores. Exploration and exploitation for coal as potential source of REE should be conducted based on suitable geological condition, selective mining and modification of coal power plant, and also suitable extraction method for coal fly ash. And then in the afternoon, as a keynote speaker, Bapak Luhut Binsar Panjaitan MPA of the Indonesian Coordinating Minister for Maritime and Investment Affairs gave us an insight on managing COVID-19 pandemic and economic recovery. He mentioned that today, in general, the COVID-19 situation is under control. Vaccination has accelerated more than 130 million Indonesians. And yeah, we have a rapid economic recovery. the consumption and production has returned to a pre-pandemic level, and the investment performance remain stable and become the driver of economic growth throughout 2021. And regarding the investment opportunity, he explained the rule of thumb of investment that include environmentally sustainable, value-added industry, the use of local labor force, and transfer of technology. He also highlighting the Indonesia investment priority areas that include downstream mineral resources, lithium battery, transportation, renewable industry, as well as lowering carbon emission. And the following talk was about the critical materials in bauxite and red mud by Ibu Amar Didi. She opened the presentation by explaining the definition of critical raw materials, bauxite and red mud, which is wasted product, become interesting resource for REE. Red mud originated from karst bauxite is even better REE source, as the condition during the formation of bauxite allow the enrichment of metals. And the following presenter was Pak Darius Faria Nemil. His presentation was about the geometallurgy application for sustainable mining in Aman field. He emphasized that quantifying ore hardness in terms of impact resistance for crushing application and grindability for milling application plays an important role in an effective mine-to-mill program. Pursuing continuous improvement on geometallurgy program, PT Aman Mineral engaged SIM SAG and applied hardness index texture for updating the ore hardness geological mapping of the Batu Hijau deposit. The program has completed within 6 months, which involved 326 drill core samples being tested. And then during the last talk on day 2, Pak Tony Gultom gave a talk entitled Nickel Mine Was Management as a part of ESG commitment, a case of Obi Island, South Halmahera. He started the presentation by showing us the transformation of Harita. He also emphasized a sustainability framework that include good governance, climate change, and also human rights. And in the day 3, we have Pak Steve Garwin, Pak Rob Bills, and Pak Ibu Kiki Siagian as a keynote speaker. Steve Garwin opened up the day by talking about satellite derived topography as a basis for geological interpretation and deposit targeting. He showed us an example from the Andes, northern Peru. He emphasized that deposits were localized along the margins of regional topographic height near smaller scale topographic break, and the linemen defined are inferred to represent the fault or a fracture that control the mineralization, and exploration target may be delineated in zones of lineament intersection that are proximal to regional topographic height, and mineral occurrence and after inferred hydrothermal alteration. And the following talk by Pak Rob Bills presented an exploration philosophy that very useful for us as an exploration geologist. And as a conclusion, knowing the geological and mineral system are very important, and geological intelligence is essential. And at the end, matching the technological strategy with commercial will open up the new search area. And the following talk by Ibu Kiki Siagian based on applied random forest algorithm in the Batu Hijau mine provide us a new insight of the classification of the penetration rate of a blast hole drilled using geological data. The random forest algorithm has a significant ability to predict the rock drill ability classification with the predicted model obtained 74% accuracy. And the improvement and further research will be done by applying Tunning ML algorithm and collecting other rock hardness variable to generate a better prediction. And the following presentation was that by Pak Imam Purwadi. He provided us a new insight on the remote sensing, and the remote sensing gives us benefit in exploration ranging from continental to local scales. And although the data are abundant, there are still some limitation when we use them in Indonesia due to some load and vegetation, for example. And thus, many studies are required in order to improve the result. And then Pak Iwan Setiawan gave us a talk about the weather crust in North Sumatra, especially the mineralogical and geochemical signature of potential ion adsorption type REE. He started with the introduction of REE and then up with the conclusion that the parental granite at the Sibolga contains REE-bearing minerals such as apatite, allanite, and titanite. They are likely to be the source of REE, and the REE content in the weather crust in Sibolga is lower than the parental rock, indicating that REE were leached out during the weathering, and most of the REE was observed as ion exchangeable forms in SSA, which are likely to exist on the surface of clays. And the following presenter was Pak Saryono. It was about the exploration lead of primary diamond in Kalimantan, a preliminary study to discover the existence of primary diamond can be carried out by observing the Bulger gravity anomalies, which also represent the revelation of the mantle plum structures. And a computed gravity was used to discriminate the exploration lead from the deep concealed mantle plum. Two types of discriminating windows were used to compare the lead areas in Central and East Kalimantan, and the second order vertical gradient successfully discriminate the targeted area of the mantle plum structure, which is significant for exploration leads of the primary diamond. And in addition, the depression pattern of the observed gravity and computed gravity model also suggests the existence of diamond-bearing intrusive body. And then his presentation end up with the recommendation that a follow-up activity may be initiated for the validation of the present study. And for the purpose of updating information, the geophysical surveys may be carried out, and visiting the identified lead areas may also be done. And shallow drilling seems to be mandatory, followed by some laboratory works. And the following presentation by Pak Elino Febriadi was about sustaining coal inventory through persistent exploring brownfield area. He started his presentation by explaining the historical flashback on Arutmin coal exploration, followed by the difference between greenfield and brownfield, problem that observed in the brownfield coal exploration, such as interruption due to the decline of coal price, the ineffective reconciliation and in-pit mapping, connection between department, skill retainment, data collection, as well as the preservation and illegal mine and land access. And as a conclusion, brownfield exploration should be more efficient than greenfield. Competent geologists is required to recognize and utilize the advantages, and both geologists and management need to work together. And the last talk was by Pak Yoga Suryanegara. It was about Indonesian metallurgical coal exploration, coal characteristic and deposit potential. The quality of Indonesian coals varies and is strongly influenced by the geological environment. The rank itself varies from lignite to sub-bituminous, high to low volatile bituminous, and semi-anthracite to anthracite. And high rank coal is mainly controlled by the distribution pattern of the Paleogene coal measured by burial processes. And low volatile content is mainly controlled and affected by igneous intrusion and major fault. And he mentioned at the end of his presentation that only 9% of all resources is high to very high in caloric. So that's all. Once again, thank you very much for giving me this opportunity. I'll return the time for Miss MC.
Thank you very much to Bapak Adi Sulaksono for wrapping up the last 3 days event. And now for the next event, we would like to move on to the Student Research Poster Contest. Ladies and gents, this is the most anticipated event for this session, especially for our fellow university students. For this session, I would like to invite Ms. Sylvia Manurung, coordinator of SRPC, to explain a little bit of SRPC and also to announce the winners.
Okay, thank you, Mbak Rahma. Student Research Poster Contest MGEI 2021 have 20 finalists. In the end session of SRPC, for this year's, we get 6 winners. So, for 6 winners, we'll get the chance of their full paper to publish in IJEC, Indonesian Journal of Economic Geology. And for our big 3 winners, you'll get the prize with the third winners 2 million rupiah, second winners 3 million rupiah, and first winners 5 million rupiah. And the other chance for the end announcement session, first winners and second winners will present their poster to us. So, here's the names of our big 6 winners of SRPC MGEI 2021. From runner-up 3 with the author's name is Bayu Pradana, R. Aditya Manggalayuda, and Oh Kita. And for our runner-up 2 with the author's name Anjar Kurnia Ramadan, Fikri Mahendra Malik, and Brigita Nadia Eman. And for runner-up 1 with the author's name Bayu Aji Dwi Laksana and Muhammad Syarifuddin Ansar. And for our 3 winners with the third winner's author's name Unggul Prabowo, Makruf Nur Hanafi, and Reza Krisnandi. And for our second winners with the author's name Almira Rizkianindia Rianka Ayu. And for our first winner's author's name is Alsa Nabila. So, congratulations to our big 6 winner on Student Research Poster MGEI 2021. Thanks to all the awesome participants who passed through all the sessions of SRPC MGEI 2021. In the end, for next session, I'll return to the MC, Baramba. Thank you.
Thank you very much, Ms. Sylvia. And now it is the memento of appreciation to our runner-ups and also to our winners. This session will be given by Ibu Utami Sastra Miharja, a jury representative. The first 3 photos will be taken with the top 3 runner-ups. For the third runner-up, we will take a photo with Mas Bayu Pradana of Institute Science and Technology Akprin. Kepada Mas Bayu, boleh dinyalakan kameranya?
Oke, 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2,
Baik, akan kita foto terlebih dahulu. 3, 2, 1. Oh, akan difoto kembali. 3, 2, 1. Baik, terima kasih banyak kepada Mas Bayu. Selanjutnya kami akan foto bersama Mas Fikri Mahendra, runner-up kedua dari Universitas Jenderal Sudirman. Oke, saya akan hitung dari 3. 3, 2, 1. Baik, terima kasih banyak kepada Mas Fikri. Selanjutnya untuk runner-up pertama, Mas Bayu Aji Dwi Laksana dari Universitas Gadjah Mada. Baik, 3, 2, 1. Baik, terima kasih banyak kepada Mas Bayu. Selanjutnya adalah foto bersama dengan 3 pemenang Student Research Poster Contest. Dari pemenang ketiga, dari juara pertama, dari juara ketiga adalah Mas Unggul Prabowo dari Institut Teknologi Nasional Yogyakarta. Tiga, 2, 1. Baik, terima kasih banyak kepada Mas Unggul. Selanjutnya adalah pemberian memento kepada juara kedua, Mbak Almira Rizkianindya Rianka Ayu dari Universitas Gadjah Mada. Kepada Mbak Almira, bolehkah dinyalakan kameranya? Baik, sudah siap, Mbak? Oke. 3, 2, 1. Baik, terima kasih banyak kepada Mbak Almira. Selanjutnya adalah foto bersama dengan pemenang pertama, yaitu adalah Mbak Alse Nabila. Baik, akan saya hitung dari 3. 3, 2, 1. Baik, terima kasih banyak kepada seluruh pemenang. Dan selanjutnya adalah, next we will continue with the second and first winners presentation. But unfortunately there will be no live Q&A, but you can send your questions into the chat box. First, we would like to invite the second Student Research Poster Contest winner, Ms. Almira Rizkianindya Rianka Ayu from Universitas Gadjah Mada, to give her presentation. The presentation will run for 10 minutes. To Ms. Almira, you may now begin your presentation. Ms. Almira, if you could kindly please turn on your camera. All right, while we wait for Ms. Almira to come, we would like to remind you to please check out the booth exhibition where our sponsor media partners can offer their services and products. And also please stay tuned for this will be the last day of the annual convention, and I'm sure even though this is the end of the convention, there will be a post-annual convention activities. Okay, now we will move on to the first winner's presentation. To Ms. Alsa Nabila, you may now begin your presentation. Hello, Ms. Alsa. How are you doing today?
I'm fine, thank you.
Congratulations on being the first winner. I'm sure you're very happy.
Yes. Okay, should I start the presentation?
Just a quick reminder, Ms. Alsa, your presentation time will take around 10 minutes. Thank you.
Is my screen good enough? Or okay, can I start now? Check.
Yes, we can hear you clearly, Miss.
Okay. Thank you. So good afternoon for all the audiences. Thank you for giving me this occasion. I am Alsa Nabila from Universitas Gadjah Mada, and I'm going to deliver a presentation with Pak Ernomo from Pusat Sumber Daya Mineral Batubara dan Panas Bumi, Pak Arifudin Idrus from Universitas Gadjah Mada, and also Pak Dedi Sunjaya from PT Aneka Tambang, with a research poster entitled Gallium and Vanadium in Lateritic Bauxite and its Red Knot of the District West Kalimantan, their occurrence and application for future exploration. And this is for the outline of today's presentation, started from the introduction. We know that gallium and vanadium are both metals that recently used as materials for high technology application. And due to the increasing demand of the technology development, and also calculated from their economic importance and supply risk, both gallium and vanadium are classified as critical raw materials. Meanwhile, bauxite is aggregate of fine-grained minerals, consists of aluminum oxide minerals as a weathering product of aluminum, high aluminum content rock. And as shown in the figure, that we have West Kalimantan's bauxite belt, that Tayan itself has the biggest prospect of Indonesian bauxite. And bauxite mining started from crude bauxite mine taken from bauxite zone. Then it goes a washing process to produce washed bauxite and also bauxite residue. The washed bauxite then put into the stockpile and also sent to the processing unit to produce alumina products through bioprocess. And at the digestion stages, when the aluminum content minerals is leached through the strong base in high temperature, it will also produce red mud that will cause another environmental problem. And stated that gallium and vanadium, which found in bauxite, are also found in the red mud. So this research is aimed to investigate gallium and vanadium occurrence in both lateritic bauxite and its red mud through petrography, mineralogy, and geochemistry. And then for the regional geology, as we know, Tayan is located in the West Kalimantan as a part of Swanner Block Mountain that resulted from the subduction of Paleo-Pacific in early Cretaceous. And our research location is focused on spout tonalite formation from the early Cretaceous. And the methodology started from literature review, and then field sampling from 2 bedrocks and 11 channel sample lateritic profile from Bukit 16 and Bukit 13 from PT Aneka Tambang, and also washed bauxite residue and also red mud taken as a residual product of bioprocess from PT Indonesia Chemical Alumina. Also, it later conducted laboratory analysis through petrography, XRD, XRF, and ICP-AES. And then from the geochemistry data, mass balance is calculated, then all the data is integrated and interpreted. So the aim from this research is reached. And then for the result in discussion, divided into 3 main lateritization zones, started from the above, latosol, and then bauxite zone, and also Kong zone, which are all covered by the topsoil on the very top. And it's very common to find the bedrock fragment in the Kong zone, considering that this zone is the least weathered part of the profile. And Kong zone is usually characterized by clay mineral dominated, and also the bauxite zone is characterized by the high accumulation of gypsite mineral as the aluminium mineral, aluminium bearing mineral. And then for the lithology, we can see that from the petrography that based on Lebas and Strykensen 1991, that Bukit 16 bedrock is specified as granodiorite, and also Bukit 13 bedrock is specified as quartz diorite. And also shown in the table, the other minerals found in both of the bedrocks. And at the left figure, we can see that XRD data in Bukit 16, how it changed from the uppermost profile into the Kong zone. And then from both petrography and XRF data, we combine the vertical mineralogical transformation in the right figure. I see that quartz minerals is found along the lateritization profile, means that these minerals is very resistant to the weathering. And then we can see the feldspar group, plagioclase and also orthoclase will weathered into the clay minerals of kaolinite and also illite. And in more intensive lateritization, we can see that kaolinite will change into the gypsite. And also found that biotite, hornblende, and pyroxene is suspected to give the iron element, so it will occur as magnetite, hematite, and goethite along the profile. And then from the geochemistry data from major element, also gallium and vanadium, we can see the left figure from Bukit 16 and Bukit 13. It shown that both gallium and vanadium are enriched in the bauxite zone. So the correlation test is conducted to see the correlation between gallium and vanadium also with major element. There's a strong correlation between gallium and also aluminum oxide, and also vanadium with iron oxide. Meanwhile, there is less strong iron oxide and also vanadium with vanadium. And then from all the data, we can make this kind of diagram stating that mineralogical and geochemical changes through lateritization process, washing process, and also extraction process. We can see in the left figure the mineralogical changes. So we can see from the bedrock to the bauxite zone that there is accumulation of gypsite mineral, and after the washing process, we can see that the gypsite is also enriched in washed bauxite and also residue. It interpreted that in the washing process, the fine grain of gypsite mineral is also accumulated in the residue sample. So after of Bayer process, we can see that the gypsite is shown in small number, and meanwhile the red mud is dominated by the iron minerals and also another minerals that is caused by the high by intensive reaction in Bayer process. And we can see in geochemical changes that gallium in washed bauxite is higher than the residue. Meanwhile, the vanadium is higher in the residue rather in the washed bauxite. And also we can see that the gallium and vanadium are accumulated significantly in the red mud. Then the mass balance is calculated through the immobile elements method of McLean 1997. The aluminum oxide is used as immobile element, considering that is enriched in bauxite lateritization process by residual enrichment. So after the calculation, we know that in residue samples, gallium is slightly depleted by 0.3, and also vanadium is enriched by 11 to the wash bauxite. While in red mud, we can see that gallium is enriched by 1.001, and vanadium is enriched up to 36.8 times wash bauxite. So we can take the conclusion that mineralogical and geochemical composition is controlled by its bedrock type, geochemistry, and also the lateritization process. Gallium and vanadium are enriched through lateritization in bauxite zone, and also gallium is found in association with aluminum and also with iron, while vanadium is associated with iron and also titanium. And also found after process, gallium is found higher in concentration in wash bauxite than in residue, and vanadium is vice versa. And also after the extraction process, it's found that gallium and vanadium are more enriched in the red mud by 1.001 and also 36.855 to the wash bauxite respectively. Further study is needed for understanding their behavior prior to the advanced exploration and also extraction strategy of gallium and vanadium in bauxite and its red mud, prepared to fulfill critical raw materials global market for their application in high technology industries. The authors want to acknowledge the Pusat Sumber Daya Mineral, Batubara dan Panas Bumi, and also PT Aneka Tambang for giving us permission to use the data. And this is the references we use. Thank you for the time.
Thank you very much to Ms. Alsa Nabila from Universitas Gadjah Mada for your presentation. And we also would like to congratulate again to our student research poster contest winners, Mas Unggul Prabowo from Institut Teknologi Nasional Yogyakarta, Ms. Almira Rizkianindya Rianka Ayu from Universitas Gadjah Mada, and also to Ms. Alsa Nabila from Universitas Gadjah Mada. We first would like to apologize that our second winner of the student research poster contest was not able to attend and present her presentation. Up next, we have the MGEI election session, which will be led by Bapak Hashari Kamarudin as Ketua KPU MGEI 2021. Kepada Bapak Hashari Kamarudin, dipersilahkan. And while we wait for Bapak Hashari Kamarudin, please again check out the booth exhibition, as there are all the products and services our sponsors and media partner can offer. Good afternoon, Bapak Hashari. How are you doing?
I'm fine, thank you.
All right. Before you start, would it be okay if you press your mic a bit closer?
Okay.
All right, perfect.
All clear?
Yes, all clear. We can hear you, but perhaps could you put the screen a little bit lower?
Actually, in my tab, it looks like it's okay, but somehow...
Oh, I see.
Okay, it's better now?
Yes, much better. Thank you very much, sir. You may now continue your session.
Okay, thank you very much. Since I will present the event for our election period, like usual, I will continue in Bahasa Indonesia. Terima kasih panitia yang sudah kembali memfasilitasi KPU untuk menyampaikan tahapan pemilu yang terakhir yang akan kita lalui pada hari ini. Dan untuk tahapan awal, sebelum kita menuju ke kepengurusan yang baru, kita sama-sama akan mendengarkan terlebih dahulu laporan pertanggungjawaban dari kepengurusan sebelumnya. Untuk itu saya mengundang kepada DPP MGEI periode 2018-2021 untuk menyampaikan laporan pertanggungjawabannya. Baik, selamat sore Pak Ketua MGEI, Pak Budi Santoso. Belum kedengaran di saya.
Seharusnya terdengar jelas, Pak.
Baik, terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih Pak Hasari, terima kasih rekan-rekan. Untuk laporan pertanggungjawaban kami akan serahkan kepada Wakil Ketua MGEI periode 2018-2021, itu Mas Dion, dipersilakan.
Ya, terima kasih Mas SJ.
Silakan Mas Dion, dilanjut.
Ya, terima kasih Mas SJ, Pak Asari atas waktu yang diberikan. Izin share, bisa share. Sudah terlihat? Oke. Terima kasih, selamat sore. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih atas waktu yang sudah diberikan. Di sini saya mewakili Pak Ketua, Pak SD Budi Santoso, dan teman-teman PP pengurus pusat MGEI tahun 2018 dan 2021. Mungkin saya langsung saja karena sudah sore. Jadi MGEI terbentuk dari tahun 2008 sampai dengan 2021, di mana pada waktu itu jumlah member MGEI dari tahun 2009 berjumlah 203. Kemudian berjalannya waktu terus kita mengajak teman-teman seprofesi di geologi ekonomi untuk bergabung di asosiasi kami, sehingga tahun 2021 anggota MGEI sebanyak 1.289. Walaupun memang kondisi anggota aktif di tahun 2001 masih lebih banyak yang tidak aktif atau yang belum membayar iuran, sehingga itu menjadi tugas besar kami agar bisa melaksanakan tugas untuk yang 66% ini menjadi yang warna coklat lebih tua, sehingga gap antara yang sudah membayar iuran dan yang belum membayar iuran bisa berkurang atau tertutupi dengan cara-cara seperti program kerja yang sudah kami lakukan. Nah, kemudian ini garis besar cash flow dari MGEI di tahun 2019 sampai dengan 2021, di mana income di tahun 2019 itu sebesar 1,6 miliar, kemudian expense yang dikeluarkan 1,6 miliar juga, tetapi kita punya dana kas di tahun 2018 sebanyak 1 miliar, sehingga kami bisa mengalokasikan sebagian dana tersebut untuk pembelian aset berupa sekretariat kita saat ini yang kita berkegiatan. Jadi di tahun 2019 kita melakukan DP untuk pembelian Soho ini sebanyak 871 juta. Kemudian di tahun 2020 income kita ada sekitar 1,3 miliar. Kemudian pengeluaran kita itu ada sebanyak 1 miliar rupiah, dan kita bisa menyisihkan untuk sekretariat kita sebanyak 600 juta rupiah. Kemudian di tahun 2021 kita memiliki income sebanyak 1,1 miliar dan pengeluaran kita sebanyak 700 miliar, sehingga kita bisa mengalokasikan sebanyak 780 juta untuk sekretariat kita. Dan pada saat ini, pada saat November 2021, kas kita ada sekitar 560 juta rupiah. Dan kami harap dengan berlangsungnya annual MGEI 2021 ini, kita bisa menghemat cukup banyak, sehingga di tahun depan maksimal atau paling lambat semester 1 2022 kita bisa segera melunasin sekretariat kita, sehingga sudah agak berkurang beban cicilan atau beban yang harus kita bayarkan di tahun 2022 dan seterusnya. Semoga seperti itu. Oke, kemudian kegiatan yang dilakukan MGEI pada tahun 2018 sampai 2021 secara garis besar, pertama target pengadaan sekretariat beserta fasilitasnya alhamdulillah sudah tercapai, walaupun memang masih ada beban atau cicilan yang harus kita lakukan, tapi tidak apa-apa. Dengan adanya beban tersebut, alhamdulillah teman-teman pengurus jadi bersemangat untuk melakukan banyak kegiatan yang bisa mendatangkan pemasukan untuk bisa memberikan sebangsihnya agar sekretariat bisa segera lunas. Kemudian untuk acara anual yang sering yang rutin kita lakukan, yaitu ada MGEI Annual CEO Forum. Ini kita mulai sejak tahun 2019 sampai dengan tahun ini alhamdulillah masih berlangsung, dan untuk tahun depan dan tahun selanjutnya semoga tetap akan berlangsung. Kemudian IEDC, Indonesia Explorer dan Developer Collegium, di sini tahun 2021 itu kita memulai IEDC ini, dan untuk tahun-tahun selanjutnya. Kemudian ada annual convention yang tentu saja ini flagship yang harus kita jaga terus menerus dengan selalu meningkatkan tema-tema dan topik-topik yang sangat up to date. Kemudian pekerjaan atau kegiatan profesional yang kita lakukan yaitu CPI Development Program atau CDP. Kemudian ada Discover Mind yang berupa podcast dari wawancara orang-orang hebat di dunia minerba. Kemudian ada MGEI Webinar Series, di mana MGEI Webinar Series ini kita mengambil dari berbagai macam komunitas yang ada, sehingga bisa menambah wawasan teman-teman atau anggota MGEI pada khususnya. Kemudian industri atau government, kita ada MGEI Goes to Industry, kemudian ada workshop MGEI untuk negeri, kemudian ada narasumber atau partner diskusi dan perumusan kebijaksanaan. Ini beberapa tahun kebelakang ini MGEI sering diundang atau diajak diskusi dengan pemerintah dalam hal perumusan kebijakan yang berhubungan dengan kepentingan minerba untuk Indonesia yang lebih maju. Kemudian di student atau kemahasiswaan kita ada flagship training camp yang tahun ini kita melakukan dengan judul PBC, Guaranteed Bootcamp, yang kemarin dilaksanakan dengan alhamdulillah cukup sukses untuk jalur dari Yogyakarta sampai dengan Pacitan. Kemudian ada software training program. Software training program saat ini MGEI sudah melakukan MOU dengan Microman, tapi tidak menutup kemungkinan untuk software-software yang lain agar bisa bergabung atau bisa berkolaborasi dengan MGEI untuk mencerdaskan teman-teman atau untuk membuka wawasan teman-teman di kampus atau di pendidikan, agar mahasiswanya di tingkat akhir atau yang baru lulus bisa sudah mulai melek tentang software di pertambangan tersebut. Kemudian ada SCMGI, dan terus saja ini sudah cukup banyak menyebar dari Sumatera sampai dengan Papua. Ada 14 SCMGI di Indonesia. Kemudian ada MGEI Goes to Campus. MGEI Gustu Kampus. Sebelumnya kami berkunjung kampus to kampus, tapi karena 2 tahun kebelakang ini pandemi ada di Indonesia, sehingga memang untuk Gustu Kampusnya agak berkurang, tapi kita bisa melakukan dengan kegiatan offline-nya atau webinar-webinarnya. Kemudian di tahun ini juga ada satu program yang cukup mendapat banyak apresiasi dari teman-teman mahasiswa, fresh graduate maupun senior atau profesional, tentang fresh graduate mentoring program, di mana ini tempat kawah candra di muka kalau orang zaman dulu bilang ya. Jadi teman-teman yang baru lulus atau mungkin baru 1 atau 2 tahun bekerja, dia bisa mendapat mentoring atau bisa didampingi oleh profesional-profesional yang sudah sangat expert di bidangnya, sudah malang melintang di seluruh dunia pertambangan yang ada. Ini sebagian besar atau garis besar dari kegiatan MGEI di tahun 2018 sampai dengan 2021. Ini detail kegiatannya di tahun 2019. Ini ada MGEI Care, kemudian ada public training, ada third course, ada special publication, kemudian halal bihalal, ulang tahun dan sebagainya. Alhamdulillah bisa kita lakukan di tahun 2019. Dan sayangnya di tahun 2019 ini merupakan kegiatan offline sebelum pandemi. Jadi setelah 2019 ini kita semuanya online karena pandemi menyerang kita. Tetapi dengan adanya pandemi ini kami juga bersyukur karena kita bisa membenahi database, membenahi sistem yang ada di internal kami, di internal MGEI, sehingga database dan sistem yang kita lakukan bisa lebih terintegrasi dan lebih memudahkan member-member kami untuk mengaksesnya. Kemudian kegiatan MGEI di tahun 2020 sama juga, setiap tahun annual MGEI pasti ada, tetapi ada LS MM di Juli 2020. Ini MOU pertama antara MGEI dengan Micromine atau ALS. Kemudian selanjutnya terus sampai dengan akhir tahun kita melakukan semua kegiatan secara online karena pandemi sudah ada di situ. Kemudian di tahun 2021 ini cukup banyak karena kita sudah bisa beradaptasi dengan kondisi pandemi yang ada, sehingga apa yang kita create, yang pertamanya kita masih gagap untuk menuju ke online. Di tahun 2021 ini kita sudah bisa cukup belajar tentang bagaimana kita melaksanakan kegiatan secara online. Dan di tahun 2021 ini alhamdulillah cukup banyak kegiatan yang bisa menambah pengetahuan teman-teman MGEI. Terima kasih. Demikian secara singkat paparan kegiatan pengurus pusat MGEI dari tahun 2008 sampai dengan 2021 di bulan November ini. Semoga apa yang kami sajikan bisa diterima dengan baik. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Baik, terima kasih kepada pengurus DPP MGEI 2018-2021 atas seluruh pencapaian, komitmen, dan kerja keras yang dilakukan sehingga bisa membawa MGEI ke posisi yang seperti sekarang ini. Selanjutnya mungkin kita mempersilakan satu atau dua anggota jika ingin mengkonfirmasi atau menyampaikan sesuatu, kami persilahkan. Baik, kalau tidak ada kita akan melanjutkan agenda kita. Saya mengundang kepada seluruh anggota KPU, juga termasuk Dewan Pengawas KPU, kepada Pak Zardi, Mbak Acim, Mbak Ulan, Mas Hazret, dan Mbak Lina, untuk bersama-sama di dalam forum ini kita menyampaikan laporan pertanggungjawaban kita terkait kegiatan yang sudah kita lakukan sebagai KPU MGEI, pemilihan Ketua MGEI periode 2021-2024. Juga kami mengundang Pak bakal calon ketua kita, Bapak STJ Budi Santoso, untuk juga bisa tampil di podium. Oke. Baik, kita akan melanjutkan untuk agenda hari ini. Sebagaimana yang sudah kita lewati bersama, kita sudah melalui tahapan penjaringan bakal calon ketua, kita juga sudah melalui tahapan verifikasi dari calon ketua, yang kemudian hasil dari verifikasi dan pernyataan kesediaan daripada calon ketua tersebut, kita telah memperoleh satu calon ketua MGEI untuk periode 2021-2024. Kemarin kita sudah sama-sama mendengarkan program kerja yang akan dibawa oleh calon ketua MGEI 2021-2024 ke depannya. Nah, hari ini sebagaimana biasanya kita selalu memiliki ketua untuk MGEI periode berikutnya di akhir flagship acara kita, yaitu Annual Convention 2021. Selamat sore kembali, Pak STJ.
Selamat sore, Assalamualaikum.
Juga rekan-rekan saya, Mas Hazret, Mbak Lina, Mbak Acim, dan Mbak Ulan. Kemudian sebelum kita melakukan penetapan, ini karena kita cuma punya satu calon ketua, kita akan langsung menanyakan kepada seluruh anggota yang hadir pada hari ini, dan juga sebenarnya kita sudah mengkonfirmasi beberapa kali sebenarnya pada beberapa kali pertemuan. Setidaknya saya mengingat kami sudah pada dua agenda sebelumnya juga sudah menyampaikan, jika ada komentar yang ingin disampaikan kami persilahkan, tetapi jika tidak maka kita akan segera melihat tayangan yang akan disampaikan oleh KPU dalam rangka penetapan Ketua MGEI periode 2021-2024 yang calon ketuanya adalah STJ Budi Santoso. Ada yang ingin menyampaikan, menanggapi, atau memberikan komentar? Saya persilakan. Baik, kalau tidak ada, silakan Mbak Ulan untuk kita putarkan hasil akhir dari kerja yang dilakukan oleh MGEI dengan dukungan dan aspirasi yang sudah disampaikan oleh seluruh anggota MGEI. Baik, demikian kita akan menetapkan calon ketua kita sebagai ketua MGEI 2021-2024. Pertama, saya meminta persetujuan seluruh anggota. Jika memang tidak ada yang ingin berkomentar, akan kita tetapkan sekarang. Dan Anda juga bisa menyampaikan ekspresi Anda, apakah dengan persetujuan dan sebagainya, dengan omongan yang ada. Sekali lagi, silakan ada yang ingin berkomentar. Kalau tidak ada, dengan mengucapkan Bismillahirrahmanirrahim, dengan mengharapkan keridhaan Allah Subhanahu wa Ta'ala sebagai ketua KPU Ketua MGEI periode 2021-2024 bersama seluruh komisioner KPU MGEI 2021-2024, kami menyatakan Bapak STJ Budi Santoso sebagai Ketua MGEI 2021-2024. Selamat kepada Pak STJ Budi Santoso atas kepercayaan yang diberikan oleh seluruh anggota MGEI untuk memimpin kembali di 2021-2024. Kami semua percaya bahwa Mas STJ akan membawa MGEI ke level yang lebih lanjut lagi. Untuk berikutnya, untuk tidak memperpanjang, silakan Pak Ketua yang baru untuk periode yang baru ini untuk menyampaikan speech-nya. Silakan, Mas STJ.
Baik, terima kasih Mas Hasari, rekan-rekan KPU, Arsadi Darius sebagai pengawas, kemudian juga kepada seluruh rekan-rekan MGEIers, apakah itu yang tergabung di dalam kepengurusan yang tidak saja aktif, tapi juga kepengurusan yang sangat aktif sejak 3 tahun yang lalu, kemudian juga para senior yang selalu memberikan dukungan moral dan juga hal-hal lain yang jika itu hanya kita lakukan atau dilakukan oleh PPMGEI 2018 sampai 2021 sepertinya akan sulit untuk terlaksana. Terima kasih sekali. Kita melihat di sini ada salah satu senior yang selalu memberikan support, mengingatkan, menyampaikan juga koridor-koridor bagaimana kita berjalan berorganisasi. Yang terhormat dan sangat kami hormati Pak Khairulnas dan juga tentu para senior yang lain yang mungkin pada kali ini atau sore kali ini belum bisa bersama-sama dengan kita. Sekali lagi saya ucapkan terima kasih atas kepercayaan rekan-rekan semua. Yang jelas jalan ke depan apa yang selalu kita pikirkan atau kita pegang sebagai sebuah guidelines begitu, bahwa apa yang seperti katakan oleh Sultan Syahrir ya, beliau adalah salah seorang intelektual, beliau adalah pejuang perintis kemerdekaan, seorang revolusioner, selalu mengatakan bahwa hidup, apakah itu hidup kita, apakah itu hidup sebuah organisasi, tidak pernah dimenangkan atau tidak dimenangkan jika tidak pernah diperjuangkan. Jadi saya pikir apa yang sudah dilakukan oleh rekan-rekan selama ini sejak berdirinya MGEI sampai khususnya masa 3 tahun kepengurusan kita semua, sudah sangat luar biasa itu, apakah itu berkeringatnya, karena kita tagline-nya kan the sweat, the time, the dedication with integrity. Jadi itu semua mengacu kepada perjuangan effort yang sangat luar biasa dari rekan-rekan, pengertian yang sangat luar biasa dari keluarga Anda semua dan juga partner begitu ya, mengabdikan diri untuk melakukan pekerjaan pro bono, pekerjaan sosial dan profesional seperti ini bukanlah sebuah capaian yang bisa atau hanya bisa diukur dengan hal-hal yang berkaitan dengan material. Ini sesuatu yang sangat spiritual, sesuatu yang sangat beyond dari yang kita bisa lakukan atau kita dapatkan di dunia profesi kita saat kita melakukan pekerjaan profesi kita. Saya pikir itu saja untuk yang terakhir saya sampaikan. Kita selalu sering mendengarkan rekan-rekan di MGEI, para senior, para junior juga menyatakan kalau ingin berjalan dengan sangat cepat, berjalanlah sendiri, tapi kalau kita ingin berjalan jauh untuk mencapai sesuatu, jalanlah atau lakukanlah sesuatu itu bersama-sama. Nah, kalau ingin cepat dan jauh, bersamalah MGEI, karena kita insya Allah akan selalu bisa melakukan itu. Terima kasih banyak untuk rekan-rekan PP MGEI 2018-2021. Jika 3 tahun terakhir Anda pikir perjuangan itu sudah nyaris selesai, sepertinya mulai besok atau mulai detik ini perjuangan yang baru akan mulai lagi. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, selamat sore, salam sehat untuk semua.
Baik, terima kasih untuk pidato awal sebagai Ketua MGEI periode 2021-2024. Selanjutnya, karena memang kita pada periode ini di awal telah menetapkan bahwa kepengurusan akan dibentuk oleh tim formatur. Setelah ini dan kita hanya memiliki 1 calon ketua. Tadinya jika calon ketua lebih dari 1, maka calon ketua lain akan masuk juga sebagai tim formatur. Tetapi KPU sudah mengantisipasi hal ini. Jika memang kita hanya memiliki 1 calon ketua, nantinya tim formatur akan kami minta rekomendasi dari ketua terpilih, siapa-siapa saja yang akan masuk menjadi tim formatur, yang kemudian akan bekerja maksimal selama 2 bulan untuk menyusun kepengurusan lengkap DPP MGEI 2021-2024 di bawah kepemimpinan STJ Budi Santoso. Saya kira itu saja yang bisa kami dari KPU sampaikan pada kesempatan ini. Sekali lagi kami mengucapkan terima kasih yang sebesar-besarnya atas dukungan seluruh anggota selama proses pemilu MGEI 2021-2024, dan juga kami mohon maaf jika sekiranya dalam perjalanan kami dalam melaksanakan tugas tersebut terdapat kekurangan dan kehilapan. Demikian saja dari kami. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore, salam sehat untuk kita semua. Saya kembalikan kepada MC.
Baik, thank you very much to Bapak Hashari Kamarudin for your presentation, and also huge congratulations to Bapak STJ Budi Santoso as MGEI's Chairman for 2021 until 2024. We believe under your leadership, MGEI can become greater. Up next, ladies and gentlemen, we would like to take a photograph together, so please turn on your camera. Okay, we still see several people with their cameras not turned on. If you could please turn on your camera. Okay, we will take the first photograph for the first slide. Everyone ready? 3, 2, and 1. All right, the next slide. Okay, everyone ready? 3, 2, and 1. Okay, the next slide, please. 1. And for the last slide, 3, 2, 1. Thank you very much everyone for the photo group. And up next, we've officially arrived at the closing session of today's event. Ladies and gentlemen, it is unfortunately the end of the main event, but do not be sad, as we have another event after this main event. Earlier, we also had 2 pre-convention events, which were Student Research Poster Contest held on the 26th and the 29th November 2021, with 3 winners already announced today. And second, we had the workshop with the topic Mineral Resource Estimation from the 7th until the 9th December with 13 participants and 10 attendees. And today, we've completed the main event. But do not be sad, we still have the post-convention event with the virtual trip from Central till East Java, which the date will be announced soon in MGEI's socials, so please keep an eye out. Alright, ladies and gentlemen, for this event, we again would like to thank our sponsors and media partner for making this event happen. Starting from our Superbyte sponsors, we have PT Geofix Indonesia, PT Merdeka Copper Gold Tbk, PT Petrosi Tbk. Our Gigabyte sponsor, we have PT Antam Tbk. Our Megabyte sponsor, we have PT Aginport Resources, PT Aman Mineral Nusa Tenggara, PT Namsuma Luban Abadi Sumacorp, PT Reka Buana Penjuru Mineral, and PT Sumbawa Timur Mining. Our Kilobyte sponsors, PT Eksplorasi Nusa Jaya, E-Minerba Indonesia, PT Greenland Resources, Harita Nickel, PT Indodrill Indonesia, PT Nusa Halmahera Minerals, and PT Tima Tbk. Our workshop sponsor, we have Sequent Limited. And our other sponsors, we have PT Medco Energy Mining International and PT Minevesting Resources Indonesia. And of course, our media partner, Dunia Tambang. To our sponsors and media partner, we sincerely thank you again for making this event happen. Now, before we officially close this event, I would like to remind you that next year we hope to see you again. So please make sure to attend and check out the next MGEI's annual convention in 2022. Stay safe, everyone. Stay healthy. Good afternoon. I'm Rahma Marsha, your host, and we wish you a good day. Bye-bye, everyone.
nikel telah menjadi bagian penting dalam perkembangan peradaban dunia. Berbagai produk yang menunjang kehidupan manusia saat ini tak lepas dari kandungan nikel di dalamnya. Dan Indonesia adalah negara dengan sumber daya nikel terbesar di dunia, khususnya di Sulawesi dan Maluku Utara. Pulau Obi yang terletak di Kabupaten Halmahera Selatan, Provinsi Maluku Utara, menjadi salah satu daerah penghasil nikel. Sejak tahun 2009, Harita Nikel telah mengelola sumber daya alam nikel dan memberi berbagai manfaat dan kontribusi bagi para pemangku kepentingan. Melalui entitas bisnis Tri Megah Bangun Persada, Gani Permai Sentosa, Megah Surya Pertiwi, Halmahera Persada Legend, dan Halmahera Jaya Ferronikel, Harita Nikel melakukan aktivitas penambangan, pengolahan biji nikel kadar tinggi, dan pemurnian nikel kadar rendah di wilayah operasi yang sama di Pulau Obi. Dengan berbagai entitas bisnis tersebut, saat ini ada lebih dari 5.000 tenaga kerja dan 70% lebih berasal dari wilayah lokal. Sebagai bentuk komitmen mendukung cita-cita bangsa dalam mewujudkan hilirisasi sumber daya alam, Harita Nikel melalui Megah Surya Pertiwi telah mengolah biji nikel kadar tinggi atau saprolit menjadi ferronikel sejak tahun 2016. Ferronikel banyak digunakan sebagai bahan baku industri logam karena bersifat anti karat. Komitmen Harita Nikel akan hilirisasi terus berlanjut. Melalui Halmahera Persada Legend, Harita Nikel mengembangkan industri pengolahan dan pemurnian nikel kadar rendah menjadi produk yang lebih bernilai, yakni mixed hydroxide precipitate, dan diproses lebih lanjut menjadi nikel sulfat dan kobalt sulfat. Produk-produk tersebut merupakan bahan baku utama baterai kendaraan listrik. Keberadaan industri ini merupakan wujud komitmen perusahaan dalam konservasi mineral dan mampu menciptakan tenaga kerja bagi anak bangsa dan terjadinya alih ilmu pengetahuan dan teknologi. Penerapan teknologi high pressure acid leach menjadikan Harita Nikel sebagai pionir dalam mendukung terwujudnya program pemerintah dalam percepatan program kendaraan bermotor listrik berbasis baterai karena mampu memanfaatkan biji nikel kadar rendah atau limonit yang selama ini tidak diolah. Di Harita Nikel, seluruh proses pertambangan hingga hilirisasi dijalankan dengan tata kelola pertambangan terbaik. Kesehatan dan keselamatan kerja menjadi komitmen utama dalam menjalankan operasional sehari-hari. Program pemantauan lingkungan dilakukan dengan mengacu pada aturan pemerintah, termasuk melibatkan pihak akademisi dan lembaga independen dalam pelaksanaannya. Secara reguler, perusahaan melaporkan hasil pemantauan lingkungan kepada pemerintah. Harita Nikel juga memiliki fasilitas pembibitan tanaman mandiri untuk menunjang aktivitas reklamasi. Kegiatan reklamasi telah dilakukan tanpa menunggu operasional selesai. Perusahaan juga mengelola sisa tanah olahan atau produk samping berupa slag nikel menjadi produk bermanfaat. Dengan izin pemanfaatan dari pemerintah, slag nikel dan abu hasil pembakaran batubara diproses menjadi material bahan bangunan yang kokoh dan berkualitas tinggi, yaitu bata beton. Produk ini telah dimanfaatkan secara optimal dalam pembangunan fondasi berbagai fasilitas perusahaan. Melalui kerjasama dengan pemerintah setempat, Harita Nikel juga berkomitmen dalam pengembangan dan pemberdayaan masyarakat. Berbagai program terus dilakukan untuk mewujudkan cita-cita bersama, yakni menjadikan masyarakat setempat mandiri. Seluruh program mengacu pada 5 pilar, yaitu infrastruktur, pengembangan ekonomi, pendidikan, kesehatan, dan sosial budaya. Dengan dukungan dari seluruh pemangku kepentingan, Harita Nikel berkomitmen untuk senantiasa mengoptimalkan sumber daya alam Indonesia bagi kemandirian bangsa serta kontribusi terhadap pembangunan dan kemajuan ekonomi daerah maupun negara. Dari OBI untuk Indonesia.
PT Timah Tbk merupakan salah satu perusahaan penghasil logam timah terbesar di dunia. Perusahaan ini berkantor pusat di Kota Pangkal Pinang, Provinsi Kepulauan Bangka Belitung, Indonesia. Wilayah operasi PT Timah meliputi Provinsi Kepulauan Bangka Belitung dan Provinsi Kepulauan Riau yang dikenal sebagai Indonesian Tin Belt. PT Timah memiliki visi menjadi perusahaan pertambangan terkemuka di dunia yang ramah lingkungan. Dengan misi membangun sumber daya manusia yang tangguh, unggul, dan bermartabat, melaksanakan tata kelola penambangan yang baik dan benar, mengoptimalkan nilai perusahaan dan kontribusi terhadap pemegang saham, serta tanggung jawab sosial. Sejak tahun 1995, PT Timah telah tercatat di Bursa Efek Indonesia. Pada tanggal 29 November 2017, PT Timah bersama PT Aneka Tambang PT Bukit Asam dan PT Freeport Indonesia resmi tercatat sebagai anggota holding industri pertambangan Main ID di bawah naungan PT Indonesia Asahan Aluminium atau Inalum. Sebanyak 65% kepemilikan saham PT Timah dimiliki pemerintah melalui PT Inalum dan 35% oleh publik. PT Timah merupakan perusahaan penambangan yang terintegrasi, mulai dari eksplorasi, penambangan, pengolahan, smelter, hingga pemasaran. Penambangan di darat di wilayah izin usaha pertambangan timah berlokasi di Pulau Bangka dan Belitung. Sedangkan penambangan timah di laut menggunakan kapal keruk dan kapal isap produksi. Sebelum dilebur, biji timah hasil tambang diproses di pusat pencucian biji timah. Setelah dipisahkan dari mineral ikutan, kadar SN ditingkatkan hingga mencapai syarat utama peleburan. Untuk mendapatkan logam timah berkualitas tinggi, maka dilakukan pemurnian. Prosesnya memakai crystallizer dan electrolytic refining. Proses peleburan dilakukan di Muntok, Bangka Barat, dan di Kundur, Kepulauan Riau. Saat ini dikembangkan proyek fuming dan ausmelt untuk mendukung operasional peleburan. Jenis logam timah yang diproduksi PT Timah yakni Bangka Tin, Mentok Tin, Kundur Tin, Bangka Lowlit, dan Bangka 49. Merek dagang Bangka Tin dan Kundur Tin terdaftar di London Metal Exchange dan bersertifikasi CFS dari RMI. Negara tujuan ekspor antara lain Jepang, Korea, Taiwan, Cina, Singapura, Belanda, Jerman, Prancis, Spanyol, Italia, serta wilayah Amerika Serikat dan Kanada. Kegiatan usaha PT Timah Tbk ditunjang beberapa anak perusahaan, yakni PT Timah Industri, PT Timah Investasi Mineral, Timah International Investment, PT Dok dan Perkapalan Air Kantung, Indometal London Limited, PT Timah Karya Properti Persada, PT Timah Agro Manunggal, PT Tanjung Alam Jaya. Guna menjaga eksistensi perusahaan, dicanangkan 4 pilar utama rencana pengembangan perusahaan yang mencakup pilar 1, mempertahankan dan memperkuat bisnis pertambangan timah perusahaan dengan melakukan peningkatan jumlah cadangan dan produksi. Pilar 2, pengembangan bisnis pertambangan non-timah dengan fokus pada mineral ikutan timah. Pilar 3, pengembangan bisnis hilir timah secara agresif dengan menguasai pasar domestik dan menembus pasar global. Pilar 4, Pengembangan bisnis selektif fokus pada bisnis yang memberikan keuntungan kompetitif pada grup PT Timah. Sebagai salah satu faktor penting keberlanjutan perusahaan, PT Timah terus mengembangkan SDM berbasis karakter unggul dalam kinerja maupun perilaku. Hasil kerja keras semua pihak ini membuahkan penghargaan dari berbagai lembaga, baik dari dalam maupun luar negeri. Sebagai entitas di tengah masyarakat, PT Timah mempunyai program tanggung jawab di bidang sarana, pendidikan, usaha mikro, sosial, dan pelestarian lingkungan. PT Timah Tbk, perusahaan pertambangan terkemuka di dunia yang ramah lingkungan.
PT Nusa Halmahera Minerals adalah usaha bersama antara PT Indotan Halmahera Bangkit dan PT Aneka Tambang Tbk yang mengelola tambang emas Gosowong di Kabupaten Halmahera Utara, Provinsi Maluku Utara. Saat ini, perusahaan mengelola 2 tambang bawah tanah aktif, yaitu Tambang Kencana dan Toguraci, yang memiliki produktivitas dan potensi cadangan yang tinggi. Sementara itu, eksplorasi juga terus dilakukan secara agresif untuk terus menambah usia produktif tambang. Keselamatan kerja, serta kepedulian sosial dan tanggung jawab lingkungan selalu menjadi prioritas dalam semua kegiatan perusahaan. PT Nusa Halmahera Minerals menjadi salah satu industri penyerap tenaga kerja terbesar di Halmahera Utara. Kegiatan operasional perusahaan telah menjadi kesempatan bagi sumber daya manusia setempat untuk mengembangkan keahlian dalam bersaing secara global. Selain menambang secara profesional, kontribusi perusahaan untuk masyarakat lingkar tambang juga dilakukan dengan langsung menyentuh kebutuhan masyarakat yang sebenarnya. Di mana selain program pengembangan dan pemberdayaan masyarakat, perusahaan juga melakukan berbagai program tambahan sukarela lainnya. Seperti program bedah rumah, akses layanan kesehatan yang nyata, dan bantuan khusus untuk kaum duafa, anak yatim, dan lanjut usia. Menambang dengan hati. Itulah semangat yang diusung oleh PT Nusa Halmahera Minerals di tambang emas Gosowong, Halmahera Utara.